for them to ask you, you know. Please don't make any sudden moves. You don't know the hope or the abuse. Why did you come? You knew you should have stayed. I tried to warn you just to stay away. And now they're outside ready to burst. It looks like you might be one of us.
All my friends are toxic, all ambitionless, so rude and always negative. I need no friends, but it's not that quick and easy. Oh, I'm drowning, let me breathe. I'm better off all by myself. No, I'm feeling kinda empty without somebody else. So I hear you cry and I for help, but you never showed for me when I was laying yourself on. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know. I'm drowning, let me breathe. I'm drowning, let me breathe. I'm drowning, let me breathe. I'm drowning, let me breathe.
But life is immaculate, backing and up a bit, counting my hours and knocking the wood. Finding my opposites, showing the chocolate. Had to be limited time, but it should. It good for a minute, to want to admit it. I'm running up seconds of rigid, I'm screwed. Don't know what to do, I'm thinking of you. I'm drinking up bottles and bottles of booze.
Better off all by myself. Though I'm feeling kinda empty without somebody else. So I hear you cry and I for help, but you never showed for me when I was playing your cell phone. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know. I fell into your living. That's where you told me lies. You said that I feel better, but this is where good guys die. You took my pride away, but you cannot take my life. I find another way, but now you're taking my life. Don't you see how I'm better off all by myself? Though I'm feeling kinda empty without somebody else. So I hear you cry and I for help, but you never showed for me when I was ringing your cell phone. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know. I'm better off all by myself. Though I'm feeling kinda empty without somebody else. So I hear you cry and I for help, but you never showed for me when I was ringing your cell phone. No, you don't know how it feels to be alone, baby. Oh, I'll make you know, I'll make you know.
I drink till I'm drunk, smoke till I'm high, castle on the hill, wake up in the sky. You can't tell me I ain't fly. Yeah. I know I'm super fly. I know I'm super fly.
Okay, so it works. Lovely. So, good morning, jPrime. Hello. Make some noise. Yes. How was the traffic jam today? It was good? I mean, as usual. How did you get to the venue? The metro was working, I guess. Yes, anyway, really good to see you here. And I hope you're enjoying. This is the hardest talk for the conference, day 2 in the morning.
Yeah.
Yes.
Everybody's still drunk, I guess.
Everybody is drunk, especially the speakers, after yesterday. Yes, and what we usually say, good morning, but today we say it a little bit differently. We say Gunnar Morning, jPrime. Yes, because Gunnar is here today, and well, actually, he's one of the most important specialists in data. Yes, don't hesitate. One of the coolest guys about data processing, about CDC, actually inventor of the CDC. Let's be honest.
Okay.
Yes, and really awesome. And good pleasure to have him here. By the way, after one J Professional. Who was at J Professionals with Gunnar Morning? Is there anyone?
I was there.
Yes.
It's like there's some.
Okay, then you will learn.
Two
definitely
brave people.
2 brave people. Yes. So once again, Gunnar Morning, everybody, and please welcome our good friend Gunnar Morning.
All right. Thank you so much for the nice words. Well, welcome. I hope you're all awake. You had a good. Great first conference day, and I hope you will have another great second conference day, and I'm very happy to kick things off for you. Okay, so, I mean, Dimitri shortly mentioned CDC, Change Data Capture, and I will explain what it is and why you would want to use this. And I've been working on this for, well, quite a few years now as part of what's called Debezium. It's an open source project for Change Data Capture, CDC for short, so I used to be the project lead. And, while doing this, there were certain themes which came up again and again. And one is this topic of today's talk, which is dual rights. And this is not a good thing. You want to avoid it, and I will explain you why. And this, kind of became a meme. At some point, we even did a T-shirt which says, "Friends don't let friends do dual rights." And the other day, I was cleaning up my wardrobe, found a T-shirt, and then I thought, hey, I should actually do a talk about this, And I realized I could have ironed the shirt, but, you get the gist of it. Okay. So, I want to talk about a couple of things. I want to talk about the outbox pattern, which helps us to deal with this dual right problem. I will talk a little bit about how to implement the outbox pattern, and we will discuss, some alternatives. Does it still make sense? Are there trade-offs? And so on. So that's the rough idea for the talk today. Few words about myself. I work at a company called Confluent. They were the original creators of Apache Kafka. By the way, who is using Apache Kafka? So, okay, this should be way more. So I would say that's maybe like 1/5 of you. I hope it's going to be like half of you next year. So yeah, at Confluent, I used to work, as I mentioned, at Debezium, and I'm involved with a few other things, and one of the things is the 1 billion row challenge. So who has heard about the 1 billion row challenge last year? It was a coding challenge, okay? Few people. Did anybody participate in the 1 billion row challenge? Like nobody? No awesome hackers who participated? Well, you should maybe participate next year, because I'm thinking to do it again. So this was, kind of like a viral challenge. People went all the way to tune their implementations, all kinds of big names from the Java community, like Thomas Wörtiger, who is the lead of GraalVM, Cliff Glick, who was the original developer of the hotspot JVM. So all those people, were implementing on the challenge. And this happened last year. And then people asked, are you going to do it again this year? And I said, no, I'm not going to do it this year because I was still recovering. It was just too much work. But maybe I'm going to do it again next year. And that's why I'm mentioning this, because if you have some ideas what could be an interesting topic for a coding challenge, let me know. And maybe we can talk about it and get something started for next January. All right. Okay, so let's get into it. So let's get into this dual rights and outbox pattern stuff. So the idea is, well, I guess many of you work on enterprise systems, right? So maybe order management systems or whatever it is really, right? And you may have a microservices architecture, which means your overall domain, your problem space is decomposed into multiple systems, which of course interact with each other, right? And very often what you have there is you need to modify the state in your own services database. So let's say a purchase order comes in, your microservice, it needs to persist that purchase order in its own local database. And now, well, this is a microservices system. It's a connected system of services. Of course, we want to loosely couple them, and we don't want them to rely on each other, but at the same time, they don't exist in isolation. So they will need to cooperate and collaborate. And this means our first microservice, very likely, it will need to notify those other services about this new purchase order. And now those two things, like persisting a purchase order in our own database and then telling those other services about this fact, this needs to happen consistently, right? This needs to happen in particular atomically. So we either want to do both of those things or none. We don't want to update our own database, but then fail to tell the other services. So that's the challenge. And well, what could we do to solve this? And this is exactly where now this idea of dual rights comes in. Because, well, this is how things could look like, right? So we have our order service. Maybe it has a REST API. It receives requests to place new purchase orders. And, well, it will store them in its own database, right? So maybe Postgres, MySQL, you name it. And at the same time, we want to notify those other services, like our shipment service. Order has been placed, so we need to create a shipment, or we want to notify our customer service that, credit balance needs to be deducted, and so on. Very often, you want to put something like Apache Kafka in between those services, so they don't rely on each other synchronously. So this is something you might find. Maybe you're even doing this in production right now. The problem there with this is, this looks fine on the surface, but well, now those two things, they're actually not guaranteed to happen transactionally or consistently. So, for instance, it could happen, we write to our database, commit a transaction in our, let's say, Postgres database, then we want to send a notification via Kafka to those other services, but now this failed for whatever reason. Maybe our Kafka cluster, is down, or we cannot reach it, there's a network split, so we are ending up in this situation where we have done one of the things, we have persisted our order, but we have forgotten or we have failed to notify those other services. And that's bad, right? Because now, well, we have a purchase order in our system, but it might not be fulfilled because, well, we didn't tell the shipment service. But that's sort of a problem, right? Also, there might be an ordering concern here. So let's say we do multiple changes shortly after another which apply to the same purchase order, let's say some updates, or to the same customer, and they happen shortly after another. What could happen is you apply those changes, let's say, A before B in your database, but then it could happen you actually send B before A via Kafka to those other services. So again, your overall system state would be inconsistent. So that's not something which we want to have, right? That's what you want to avoid. And now the problem is, again, it's very tempting to do this, and I've seen it again and again, and it looks fine. It might work fine for a while, right? But errors are guaranteed to happen. At some point, you will just run into the situation that this does not work, and then you have some trouble. Okay, so that's what you not want to do. And the question is, well, if we don't do that, what should we do instead? And this is exactly what this outbox pattern is about. And this is what I want to dive into a little bit. Okay, so let's see. Well, I hope I could make the case, well, as things are, I cannot guarantee I update my database and I send a message to Kafka transactionally or consistently. It's not something as of today which I could do. So those two systems, they are not part of one transactional boundary, one distributed transaction, so I'm subject to those potential inconsistencies. But I always can update a single resource consistently, which in this case is my own database. So let's zoom in a little bit. Let's say I have, in my domain, I have tables like customers and addresses. And now if we receive that request, new purchase order comes in, I will be able to submit a transaction in my own local database. I guess that's pretty straightforward. And now what I do as part of the same transaction in this database, I also persist an event in another table, which is called the outbox table. And this outbox table, this is now my messaging channel, let's say, to the outside world. All this happens locally within one database, one local transaction. So this happens atomically, right? So if this transaction commits, we are sure we have updated our customer and address table, and we also have inserted this event into this outbox table. Or if this transaction rolls back, then we are sure that none of those writes have happened. So this is atomically. It's also like all the ACID transactions you would expect from a transaction. Of course, now the question is, well, persisting a message in an outbox table, that's interesting, but how do we get it from there to our consumers? And this is exactly where a component gets added which is called the outbox relay, and we will dive into different implementation approaches for that. But the outbox relay, that's in charge of extracting the messages from this outbox table and, well, send them out to our consumers. There could be different ways. Many times, or oftentimes, this is done via a system like Kafka. So the outbox relay will grab all the messages from the outbox table and send them to Kafka. And now this avoids this dual write issue because, well, we only have written to our database. So as I mentioned, this happens transactionally. And this outbox relay, well, if there is something in this outbox table, it will be able to extract that change and propagate it to our consumers. And typically this happens with what's called at least once semantics. So this means, this outbox relay, it might get messages from the outbox table, but let's say it crashes, at some point it will be restarted, and it might happen to extract a few messages which it already got before a second time. So consumers typically, they would have to expect to see duplicates, but we will see how we can handle this. But it's not a big problem in reality. So this addresses the concern of dual writes, consistency, and it also addresses this ordering concern, because as we will see, the messages in this outbox table, they exactly also represent the order of how we transactionally updated our own database. So also the ordering concern is addressed. Okay, so that's still, let's dive more into the details. So I mentioned, okay, we have this outbox table. We will persist outgoing messages there. So how does this table look like? And most importantly, there is what's called, or what you could call, a payload column. So this really is the message which you want to send to external consumers. And this could be really anything. So here, for the sake of the example, I put some JSON structure, as per our domain. So it would have all the data fields which you want to emit. But it also could be something like Avro or protocol buffers. Really, whatever works for you, what are you using in your stack, you could use this as the format in this payload column. That's the most important thing. And you could leave it at that. So that's the one thing which you need to have. But then there's a few other data items which you typically also want to store in such an outbox table. One of them is, and I'm using here the terminology of the domain-driven design. I guess many of you are using that. So you want to have something like an aggregate type, so which defines, okay, what is the kind of entity or aggregate object which is represented by a given object or a message in this case. So, you could have something like purchase order, or customer, or whatever your domain is about. And the idea here as well, those aggregate types, we could use them to fan out different outbox events of different kinds, for instance, to different Kafka topics. So that if you have a consumer who's only interested in purchase order events, it would be able to do so. So that's the aggregate type. Then we also want to have something like an aggregate ID. So that's the ID of our purchase order or the ID of our customer. And this is important to ensure ordering because, well, typically we don't need global ordering here. So we don't need, to ensure the ordering is consistent across all our purchase orders or all our customers. But what we do want to ensure is that the events for a particular aggregate, that they are correctly ordered. So all the events which we emit, let's say for purchase order 1, 2, 3, they should be received by consumer exactly in the same order as we have created them. And this aggregate ID, so those of you who are familiar with Kafka, I guess you will see where this is going. This will be used as the Kafka message key because this ensures that all those messages with that ID will go into one partition in our Kafka topic. So that's the aggregate ID. And finally, well, we want to have something like an ID probably, so we can uniquely identify our events, for instance, for deduplication purposes. Let's say, we get a duplicate. I mentioned this probably has at least once semantics. So a consumer could then use that ID to see, okay, I have seen this event before, and if I get it a second time, I probably will just put it aside and ignore it. Okay. So all this is still at the high level, right? So we have an outbox relay, we have an outbox table, and well, we can use this to get our messages from our application to our external consumers. Now the question is, how can we actually do this? And how can we implement this outbox relay? So let's dive a little bit into that. And there's two different approaches which I want to talk about. And the first one is polling. So essentially, It's, I guess, pretty intuitive. So we would go to our table, to our Outbox table, and then we would query, are there new events in that Outbox table? So for that, what we would need is we need to have some sort of ordering field, right? So yeah, like a position, you could call it, right? And then essentially our query in the Outbox relay, it could select all the Outbox messages which have a position which is larger than the last one which we fetched before. And we will order it, of course, by position. I guess that makes sense, right? So we essentially go through that Outbox table ordered by this position. And again, and there's so many cases where those things seem to work fine, they seem to be a good idea on the surface, but actually the devil really is in the detail, because there is some problems with that. But first of all, let's look at the happy part. So this is, how this might work actually. So let's say we use a database sequence to produce those position fields. Well, we could have 3 transactions. In each transaction, we retrieve value from the sequence 1, 2, 3, and we insert them. Once the transactions commit, we insert them in that order into that Outbox table. And if our Outbox relay fetches the records from the table, we will have the correct ordering. So far, so good. But what happens now in a situation like this? So let's say we have those 2 transactions, 1 and 2. They happen, concurrently at the same time. And now the problem is, if we retrieve values from a database sequence, we could end up in a situation like this. So we have our transaction 2, which first, fetches value from the sequence, so we get position 1. And then later on, while this transaction still is running, transaction 1 also fetches a value from the sequence, and it gets, of course, value 2. Now this transaction 1 commits before the transaction 2. So if you look at our Outbox table, and if we query it ordered by this position value, well, suddenly we would get the event which got emitted by transaction 2, we would get that before the one which committed later, which of course is not what we want, right? So our messages would be incorrectly ordered. So that's a problem. But there's even a bigger problem. We also might actually miss events. So let's look at this kind of situation. Again, we have like 3 transactions. They insert values in this Outbox table. And let's say, we poll in our Outbox relay 1 one time, and only we see the first message. So we insert this message into our Outbox table. That's good. And now we poll again where this red line in the timeline is. So at this point in time, transaction 3 has committed already, while transaction 2 still is running. So we run our query, and message or position 1 had been the previous one, which we polled. So we say, please give us all Outbox messages where the position is greater than 1. And now, at this point in time, only transaction 3 has committed. Well, we would get this message with ID 3 or position 3, right? And we would insert that. And later on, transaction 2 commits. But at this point, we already have advanced to position 3. So we would ask, now give us please all messages with a position greater than 3. So we would essentially miss this Outbox event which has been persisted by transaction 2, which of course is a problem, well, because we wouldn't have all the data propagated. Now, there's one way where you can avoid this, or how you could avoid this, which depends a little bit on the database. So essentially, for instance, what you can do with Postgres, you could say, I only want to get data from those transactions where there is no other pending transaction which has started before. So essentially, again, if we are at this red line, we could query in a way that we wouldn't get the third event before this transaction 2 has committed. So, there's ways for dealing with it, but it also means if you have like long-running transactions, which potentially might completely unrelated, they would essentially block you from advancing with this Outbox table. So again, it's not ideal. So really, the devil is in the details with that. Okay. And again, I'm not even saying you should never do this, but you should just be aware of all the implications, all those details, and you should think about, okay, is this, how can I deal with that? But I'm not dismissing it. Now, there is, I would say, a much better way still. And I would say whenever you can use what's called log-based change data capture, this is what you should be doing. So let's take a closer look at that one. So the idea here is, well, instead of going to our database and querying this table for changes and trying to order it and having all those complexities, well, what if instead we could be notified by the database whenever a new event has appended to the transaction log? So I'm sure everybody who works with databases, you're all familiar or you're aware that all the databases have what's called a transaction log, where all the transactions are appended one by one. And this transaction log, that's the canonical source of changes in our database, right? And the idea for log-based CDC, log-based change data capture is, well, we will extract all the changes from that transaction log, and this will be our source of information. And this is exactly what Debezium does. It's an open source tool for log-based change data capture. And again, it solves all those concerns. Well, we have a complete data view because, well, the transaction log in our database, let's say the bin log in MySQL or the val, the write-ahead log in Postgres, this is, that's the source of truth. It has all the data, right? So if we go there, we will be sure we have a complete view of our data, and also it guarantees the ordering because the transaction log, well, that's an ordered sequence of the changes which were applied in the database. So if we get there, we have the complete and correct data in the correct order. Now, how would you go and do this? How would you go to a transaction log and extract changes from it? Well, that's actually quite tricky. It depends, it differs between databases. There's different APIs, different formats, different ways for doing that. But the good news is Debezium, as an open source project, it deals with all that complexity. So, it has implemented those log-based CDC connectors for all kinds of databases like Postgres, MySQL, Oracle, SQL Server, MongoDB, many more. And then it emits one canonical change event format, which we will see in a bit. So it gets, it gives you a generic representation of database change events. That's it on a high level. So by the way, who is using Debezium in production? Oh, there's like a handful of you. Okay, that's the brave corner over there. Very good. Now, there's so many things, I could mention, I could talk about Debezium in terms of features. I don't want to spend too much time on it. There's this notion of snapshotting, where essentially we will start to bootstrap a new connector by just taking a fresh initial snapshot of our data. There's what's called message transformations, which you can use to modify your messages, now also using WASM, for instance. So lots of good stuff. But one thing I do want to mention is a change to the governance of that project, because initially, it always was an open source project available under the Apache v2 license, so very liberally licensed, but it was managed and run by Red Hat. So I also used to work for Red Hat while I was the project lead for that, and they owned the domain, they owned the trademark and everything, so they kind of controlled it. Still very successful open source project, lots of other contributors, hundreds of people have contributed, but still sometimes people have maybe they are a bit shy to contribute to a project if it's not living at a more neutral place, like an open source foundation, let's say the Apache Software Foundation, Linux Foundation, all those places, right? So then people are very willing to come together and contribute to one project, work together on one project, and there's not a single entity who is exclusively in charge. And this is also what happened to Debezium. Just very recently, it moved to what's called the Common House Foundation, which means now it has a vendor-neutral home. And there's, of course, still the people from Red Hat working on it, but then also other people, I hope, even more are now eager to come and join efforts to contribute to that project. Okay, so let's get back to the Outbox stuff. So what I want to mention is, I briefly spoke about those change events, and we see them here on the left-hand side. So this is how a change event, which you would get from Debezium, would look like. So the important thing to understand here, first of all, as well, this Outbox table, this is really only, it's also like an append-only log, right? So we will ever only insert into that table. We will never update events. If you think about it, it just doesn't make sense, right? So once you have sent a message, it's immutable. You don't want to update it, so it's always inserts. And this is on the left-hand side how it would look like. So you have, in this case, because it's an insert event, you have this after structure which has essentially all those columns I mentioned before, right? So aggregate ID, payload, aggregate type, and so on. There's a bit more metadata, like what's the operation type. So this was an insert event, a create event. There's a timestamp, and so on. And the Kafka message key, by default in Debezium, that's the primary key of our tables. So that would be the unique message ID, essentially. So this is how Debezium, by default, would emit the events which we write to this outbox table. Now, from a consumer perspective, that's workable, but it's a bit inconvenient. We rather would want to have a structure as we see it on the right-hand side. So essentially, we would want to have our aggregate ID as the Kafka message key, and we also essentially only want to have this payload as the sole message value in our Kafka messages. And also in particular, we don't want to have all the messages on a single topic, but rather we would want them to be split up by aggregate type. So in this case, it would be on a topic which only has order events. And there's a message transformation in Debezium, which we can see here, which you can apply to your outbox table, and then it will on the fly transform those messages from the default representation into this one, which we can see here. So this is how you could very easily implement the outbox pattern in Debezium. So let's think about a few more implementation concerns. So first of all, there's housekeeping. As I mentioned, well, the outbox table, it's like an append-only log. So we go there and write and write and write new outbox events. Of course, we also need to delete them, right? We don't want to have an ever-growing table. What could we do? Well, we could think about some sort of batch job which deletes outbox events after some time, but actually we don't have to. It can be much easier, because what we can do is we can just, as part of our transaction where we insert events in the outbox table, we also can delete them right away. And this might be a bit counterintuitive at first, but the idea is, well, this transaction, it will append those events, insert and delete, to the transaction log. Which means this is all we need for Debezium to be able to get the events from the transaction log. Now, if we ever go to our outbox table in the database and we would do a select from, we would never see any events because, well, we always deleted the stuff right away. But still, we can capture those inserts from this outbox table. And it also means we don't have to think about housekeeping, which I think is pretty convenient. Now, I guess, well, my favorite database really is Postgres, I guess, because it's so powerful. And as it turns out, for Postgres in particular, there is an even more elegant way for implementing that, because, well, we don't even need an outbox an outbox table in the first place, because what Postgres gives us is this function pg logical emit message. And this is a bespoke function which allows you to write contents, arbitrary contents, into the database transaction log. Now, what you write here, this will never show up in any table. It will exclusively exist as an event in the outbox, in the transaction log. And this function has a couple of parameters. So this first one, this true, it says this is a transactional message, which means this write should only happen if our transaction commits. Then there's sort of like a type discriminator. So here we could say, okay, those are, those events in the transaction log, they represent outbox messages. But we also, we could say those are purchase order messages, for instance. Then there is the payload, which would be our custom structure which we want to write. And this, I really like that because, well, it makes it even easier because now we don't even need to think about a table. Again, we don't need to think about housekeeping, well, because the database will just itself discard outdated transaction log segments. So if you're on Postgres, this is what I would recommend you to implement this. Okay, let's discuss some more implementation concerns, and one of them is in particular important, which is about backfills. So let's say, or snapshotting. Let's say, maybe we have an application which exists already, which has been running in production for quite a while, and now we are about to introduce the outbox pattern to our application. Because maybe a new requirement came up, and we want to add this to an existing application. In this situation, what will happen is, well, we don't have outbox events which correspond to the existing data in our database, right? So we need to bootstrap this state for our outbox table based on the data which already exists. And, well, how could we do this? Well, first of all, it could look like this. So our service, it nicely works. So it produces its regular outbox events, persists them in the outbox table. And now we could add a backfill process or feature in our application, which is in charge of producing those outbox events for, for data which already existed in the database when we started to use the outbox param. And now the challenge as well, those two things happen at the same time, right? So our application produces regular outbox events as data gets produced or updated, and at the same time, this backfill process also inserts outbox events for already existing data. So it's sort of a data race, and in particular, we want to make sure that we don't override any outbox events which our current functionality inserts by outbox events from this backfill process, right? So we want to make sure that essentially whatever happens in terms of changes right now, that this gets precedence, essentially. And for doing that, so for resolving those conflicts, this is what we could do. Essentially, we could insert marker events in our outbox tables. So we could say, we could employ sort of a windowed processing, and we could say, okay, we insert a start marker event, and we insert an end marker event, and then between those marker events, we insert our backfill outbox events. And essentially, those marker events, start and end, they give us a windowed representation of this outbox table and the changes. And now we can essentially implement some sort of deduplication logic, which allows us to essentially make sure, whenever an outbox event actually has been regularly produced by our application, we will take that instead of a backfill event for the same purchase order. And only we will propagate those backfill events for any data within that window where we didn't see a outbox event otherwise. So I realized it's quite a bit to digest, but I want to mention it because it's a very powerful feature. And for those of you who are using Debezium, it might actually sound familiar if you have been using what's called incremental snapshotting in Debezium. And all this is based on a research paper which some very smart guys at Netflix wrote a couple of years ago. It's called dblog, a watermark-based change data capture framework, where they presented or introduced this chunking-based approach, which I just described. So I very much recommend to read this paper. It's very well readable, and this also is implemented in Debezium. Okay, so let's talk about item potency really quick. As I mentioned, we have at least once semantics here. So consumers might receive an outbox event a second time. And the question is, well, what do they do about it? They somehow need to recognize it. So we could have a unique value, as we saw on the examples before, so like a UUID, and this would work. The problem is a consumer now would have to keep track of all the UUIDs which it ever has seen, right? So it would have to store all the UUIDs, and then when a new message comes in, it could go there, and it could check, have I seen this UUID before? And if so, well, then I will discard this incoming duplicate. So we have sort of an unbounded state growth. I mean, I guess at some point we could try and discard old UUIDs, but when would we be able to do so? So that's tricky. So a more elegant way would be to have a value which is guaranteed to monotonically increase. Because then we only have to store the latest value we have seen. So we could store that value, and then if we receive messages and they have a item potency key which is lower than that one, then we know, okay, we must have seen this before because, well, this value is guaranteed to increase, right? So that's much easier because we only have to persist a single value. The question is, how do we obtain such a monotonically increasing value? Because as I explained earlier, we cannot use a database sequence because this is not guaranteed to actually be monotonically increasing in the presence of concurrent transactions. But then again, going to the specifics of our database, we can find actually values which help us with that. So in case of Postgres, there's what's called the LSN, the log sequence number. And now this is part of all the events which we get from the transaction log. And Postgres guarantees to us that this LSN is increasing in commit order, which means it is monotonically increasing for our purposes, which means consumers only need to store the latest, the greatest LSN value they've ever seen, and then if they get events which are smaller LSN, they will know this must be a duplicate. But you can't use a database sequence. That's the most important thing. All right, so let's discuss this a little bit. I mean, I hope I could make the case, why is this useful? How can we implement it? But you also might have some questions. And some questions I see or I hear are, does this not increase the database overhead? Because, well, we persist now more data in our database, right? And I would say, well, it depends. So yes, but. So typically, this concern about overhead, it comes in two flavors. So there are two aspects to it. So the one is, well, we increase the size of our database because, well, we have more data which we store, for instance, in this outbox table. Now, I would say this typically is not a concern because the data in this outbox table is very short-lived. In particular, if you do what I showed with this PG logical emit message, well, this is just part of the transaction log, and this will be discarded very quickly, essentially as soon as this has been consumed by Debezium or our replication consumers. So yes, there is a little bit of more data which we write to the database, but it's short-lived, so I don't think it really matters. And the other concern about overhead as well, our transaction size gets bigger, right? Because as part of our transactions, we do our other writes. We write to our purchase order table, customer table, and so on. But then at the same time, we also write to this outbox table. So our transaction size gets a bit bigger. And yes, that's true. But then I would say, typically that's not that relevant really, because, well, there's a baseline overhead for running a transaction to begin with. We will do other changes already, and then typically if we just do another insert in a transaction where we already do 5 or 10 or whatever other database operations, it doesn't really matter that much. So I think this is more a theoretical concern. I've not really seen this to be actually a problem. The other one is, well, does this not increase the end-to-end latency? So instead of sending a message directly through Kafka, here we go through our database. A problem, because first of all, this log-based TDC approach, which I've shown with Debezium, this can be really fast. So typically, Debezium will capture events from a Postgres database within milliseconds. So you will have your data in 2-digit milliseconds, typically in Kafka. And then, of course, it depends on where you put it, but I've seen end-to-end latencies for data pipelines, let's say from Postgres or MySQL to something like BigQuery in a second or 2 seconds. So, latency is really low. And also, I would say, well, this is, a loosely composed system of microservices, right? So I would argue this shouldn't matter that much anyway. So if we are in a situation where we have a problem if our message from our purchase order service does not get to our shipment service within half a second, then I would argue something is wrong with how we have decomposed the functionality, right? This sounds like then we have too tight of a coupling. So again, yes, latency is slightly increased potentially, but in practice, it shouldn't really matter. So finally, I want to talk a little bit about alternatives. So maybe you wonder, okay, this all sounds good, but I feel this is too complicated, or can we not think about it in different ways? And I want to briefly talk about a few potential alternatives and the trade-offs which they make. So the first one would be, well, what I've shown you is, okay, instead of writing to those two systems, I've made the case we cannot do this reliably. I write to my database, and then from there we take the data into Kafka. You could have the idea, well, I could also do it the other way around. I could, do my write first to Kafka, and maybe if you're familiar with what's called event sourcing, this is pretty much what this is about. You could then consume those events yourself and put them into your own database so that you then can serve read requests of your own application from that database. And at the same time, you would send those events and you would have external consumers which could subscribe to the same topic. So this is something which you can do. I think it works fine in terms of overall consistency guarantees and so on. There's one big caveat with this. Well, writing through Kafka and reading from there, this is an asynchronous process, which means our service could write to Kafka, new purchase order, and then the next second we go to our database and we query for that data, and it might not be there yet. So we don't have synchronous read your own writes. And this can be confusing to our users, because what could happen is, well, I'm in my e-commerce web shop. I place a purchase order. Next second, I go to the list of my purchase orders, and this doesn't show up because, well, it has been sent through Kafka, has not been put to this database yet, so our order list doesn't show my recent order yet. And for me as a user, that's very confusing, right? Because, well, has it been lost? Do I need to place it again? And again, there's ways you can deal with that. I won't dive into the details, but I would say, it adds much more complexity on an application development level than doing it the other way around. So if we go to our database, we have synchronous read-your-own writes, right? So if a transaction has committed, the next second I go, or right after that, I can go and query the data, and it will be there. So I think it's just easier, consistent, semantically. But again, it could be an option. The other one is, well, I made the case so much for, well, we cannot transactionally write to a database and Kafka. And still, as of today, that's true. But there is work happening in the Kafka community. So there is what's called KIP 939, Kafka Improvement Proposal, which essentially aims at solving that. So they want to have support for two-phase commit transactions and make this part of Apache Kafka. I'm not 100% sure where this KIP is at. I think it's still work in progress. But let's say once this functionality exists in Kafka, well, then this would actually be fine from a consistency perspective. So, then we could have a distributed transaction which allows us, to enlist Kafka, enlist our database in the transaction, and it would be applied with atomic guarantees. So either both writes happen or none of them happens. That's fine. But I would argue, again, there is a trade-off which you make, and this is, well, this by definition reduces the availability of your own system. Because now, for your order request, in order to succeed, we need to be able to do those two writes. So we need to be able to update our database, and also we need to write a message to Kafka. If one of those systems isn't available for whatever reason, well, we cannot satisfy that request. So, which just means our overall availability, now it's lower than it is if we only depend on our database. So again, it could be, or at some point it will be an option, but there are some trade-offs. And finally, which maybe is like the most interesting option here, alternative, let's say, is, well, we also could use what's used stream processing. So who of you is using Apache Flink? So yeah, again, like a handful, 5 people. Okay, very good. And again, there could be an entire talk or an entire day of talks about stream processing in Apache Flink. But on a nutshell, on a very high level, what happens here as well, we could try to produce those outbox events based on our actual table level change events. So in this case, we would use Debezium to capture the changes from our tables, like customers and addresses and purchase orders and so on. And by default, Debezium gives you a Kafka topic per table. So we would have a Kafka topic with customer change events, with address change events, with purchase order change events, and so on. And then we could use a tool like Apache Flink for taking all those streams, all those Kafka topics, and essentially merge and join them in an incrementally computed way. So just to give you an intuition how this could look like, there's different APIs in Flink. The one which I think is the most approachable probably is Flink SQL. So essentially, this allows you to use SQL to implement queries in a real-time fashion against streams of changes. So in this case, it could look like this. We could essentially join our two Kafka topics, purchase orders, with order lines. Maybe group it so we have like a single nested data structure for a particular purchase order, and then we could take this data and insert this one into another Kafka topic, and our consumers would subscribe to that. So, again, there's so much which could be said, but really on the surface, this is how you could do this, using a single Flink SQL streaming query for joining your table level events. And then you wouldn't have to, modify your actual application, and it wouldn't have to do those outbox outbox writes. And this is in particular interesting. Well, maybe we have an application, you know, a legacy system, and we cannot really modify it, or we don't want to modify it, and we don't want to add an outbox table to it. So in that case, you know, doing this sort of thing after the fact, this could be very worthwhile. Now, I guess you get already a feeling this also adds quite a bit of complexity, right? Because we need to add this stream processor into the mix. We need to operate and run it. There is questions around, you know, transactionality. So maybe we only want to emit a result from this join once we have seen all the events from a single transaction. So quite a few things like that. You know, so worthwhile option to keep in mind, but it brings in its complexities. All right, and yeah, we're pretty much on time. But to briefly summarize, I think the most important point I could make, or I hope I could make, is, well, all this is about trade-offs, right? So I'm not here to tell you, okay, this is the one way how you should solve a particular problem. You know, there's the one best way. There are no silver bullets here, right? So you really need to think about your use cases, your specific requirements, the semantics you need, and then you need to use one of those options, one or the other. Definitely, if you can, so if you are in Postgres, I would say, you know, use this function, pglogical emit message. Definitely, I think this makes things very easy. The most important thing is, just coming back to the beginning, don't do those dual writes, right? So this is really the one thing which you should not do. Just try and hope for the best. Writing to a database, writing to Kafka, you know, hope is not a strategy, right? So this is bound to fail, so don't do that. Few resources, so if you want to connect, you know, again, as I mentioned, I would love to hear from you about ideas for 1BRC, 1BRO challenge, but also if you want to talk about Debezium, Kafka, Flink, this is how you can find me. And with that, I would say thank you very much. Have a wonderful rest of the conference. Wonderful. And I will be here in the front for questions, so if people, you know, want to discuss, please come here and find me.
Till I'm drunk, smoke till I'm high, castle on the hill, wake up in the sky, you can't tell me I ain't fly. I know I'm super fly, I know I'm super fly, the ladies love luxury, that's why they all touch me. I'm out here with the moves, like I ain't been smooth. You can't tell me I ain't fly. I know I'm super fly, I know I'm super fly.
schedule, so I kindly ask you to take a seat. No, there are not many places actually, which is good. But still, I see some free places on your left and on your right. And there are also places in the front, so don't hesitate. So, I have a question to you. How would you recognize a professional speaker? It's very easy. He had no time to fix his beard. Yes, this man has been to how many? 3, 4 countries for the last 24 hours, yes?
Yeah.
Yes, amazing. Now, here is amazing speaker. A very good friend of mine comes from the most amazing city in the world called Barcelona. I really love being there. Been so many times, and I really wish you go to his conference as well. Dev BCN is so good. And on this talk, you will find out, will you be fired soon, or you will still have a chance to work a little bit, because we are talking about AI, of course. Yes, wonderful. Please warm welcome our good friend, Jonathan Villa.
Thank you, thank you. Let's wait for the slides to show up. Okay, perfect. So hopefully I will say it correctly. Dobro utro. I think that with this first slide, if you pay enough attention, maybe you can just spend 3 seconds, get the information, and leave the room. That's it. This is the whole presentation. You see a happy developer working with a robot, AI, so nice, but there's a devil showing up from the back of the laptop, right? Let's see if I can convince you about the good and the bad from AI. I usually start my presentations with numbers, trying to impact your brain and making you a bit more aware of the presentation. Let's talk about 200 billion. And you need to guess which is the right answer. It can be the text messages sent globally per year, or Bulgaria's GDP in 2024, or videos about vibe coding, or lines of code produced by AI. So who says it's the A? Oh, nice. B? Good. C? And D? That was an easy one, right? Well, surprisingly enough, text messages are 55 trillion. It's Bulgaria's GDP in 2024. And it's not the number of videos about vibe coding yet. But yes, it is the number of lines of code produced by AI. I'm Jonathan Villa, and I'm coming from Barcelona. And we are famous by creating human castles, having buildings being built for ages, like Sagrada Familia. Also for beaches. Who has been in Barcelona? Great. And also for having technology events like Mobile World Congress or DevBCN, that is the conference that I run in Barcelona next July. But we are also famous for other things. Having Bulgarian football players. And for other things that let me enjoy this moment while it lasts. Who dares to say that it is a fan from Real Madrid? And the rest are the fans from Barca, I assume. No? There is no one? Ah, come on. Okay. I'm also Java champion since 2020, and I'm one of the leaders of the Barcelona Java community. and co-founder of JBCN Conf, that now is rebranded to WCN. I've been working in a lot of languages. I'm a bit old. I started more than 30 years coding and having a salary from it, using Pascal, C, and Go, and Java lately. One of the languages that I love the most, by the way, is Delphi. Anybody has used Delphi? Perfect. I thought it was dead. But apparently what it was dead was the developer, because I received a job opportunity 2 months ago. So I assumed that somebody died or got retired. But nowadays, I'm working as a developer advocate for Sonar since, 2 years ago, a bit more. If you want to know more, just this is the QR. I will share the QR for the slides at the end, so don't worry about taking pictures. Well, you can take pictures of me if you want, but who knows who is Sonar? Okay, for the rest, Sonar is the company that, apart from paying my bills, is also having 3 products, Sonar Cube in 3 different flavors. Sonar Cube IDE, that it is the one free for everyone in most of the IDEs that is going to analyze more than 35 languages at the same time. Definitely, I encourage you to use any linter. If it's Sonar Cube, better, but if not, just use a linter. Also, Sonar Cube Server, that is also free. You can do Docker run, and you can run it locally. And Sonar Cube Cloud, that it is in our machines, that it's also free for open source projects and private projects under 50,000 lines of code. So if you have private projects in your company, definitely try Sonar Cube Cloud because it's free. Well, if you want to know more about Sonar or just simply share with me your pains using Sonar Cube, I will be here during the day. We are also introducing AI code fixes. So now, for some of the issues, Sonar can suggest the solution using AI. And because we recently bought the company, we are going to release a version soon that it is doing SCA, detecting vulnerabilities in dependencies, and also creating SBOMs. So this is the agenda for today. Well, first, we'll talk about AI in the whole software development lifecycle. And I've divided into these 6 points. That is, understanding the task, so just before coding. Code creation, this is the most common one, but also deployment. So whenever we have to deploy our application somewhere, we need to create the famous YAML files. Testing, how can AI can help us during the testing process. Also with code reviews. And finally, we will talk about quality. For me, it's the most important part because apparently nowadays, few people only focus on the quality produced by AI. So AI in the life cycle, AI is only a tool, nothing else. It can be a superpower per programmer because it can help you in order to understand things or even suggest new things of doing, of fixing an issue or implementing a feature. But it can impact the whole life cycle. From the very beginning when PO is creating the requirements document, they are going to use Gemini or ChatGPT for creating a lot of stuff. So it impacts from the beginning up to the end. And I always suggest to use AI for a starter, to create POCs, to create boilerplate code, but not to create the core base of your application. And it also can help you in order to distill, so to get information from different code bases and documentations. And it adds uncertainty. It's not deterministic. So it's going to introduce issues, wrong answers, poor solutions, and even runtime or compilation errors. So which are the different things that we can use AI in the whole life cycle? For planning, we are going to get information from forums, surveys, issues, and with that, we can get, okay, which is the the most requested feature, for instance. And with this, we can go to design which are the features that we want. Again, we have a lot of information from patterns, prototypes, specifications, and it will distill all of this information in order to be faster in order to design the feature that we want. With coding, we are going to obviously generate code. Refactor code, definitely, you should. It's super important also to use the explain. I found that one of the best features from AI. It's to explain parts of code. To distill information from different points, we will see how in a moment. And also, it will help you to document your features or your pull requests or your commits. Testing, again, it will get information from different sources, and it will generate the tests. We will talk about testing later. Super dangerous. With deployment, again, it can get information from several sources and generate those artifacts that we are going to use to deploy our applications. Again, it's a scary part. And it can interact with our platform. So we are creating our YAML files, and wow, yes, I can't remember which are the labels that we put for all the pods. Okay, it can interact with the cluster. I will show you how. And it can get the labels from whatever pod you have running, and then it will add it to the deployment files that you have. And with maintenance, again, you can get information from logs, metrics, traces, distill all of this information, and then it would be easier to create, let's say, answers or implement features. It can also forecast. If it's dangerous creating, you can imagine how dangerous it can be forecasting. But it can be to forecast behavior of your application. It's up to you what you do with it. Too many things that AI can do. Don't do them all at the same time. Just start doing one by one, and you will experience how the AI is working for you. So I will summarize into distill and generate, basically. So to get information from several sources, and then generate suggestions, not more than suggestions. And super important, we need to have quality, security, and correctness in our mind during the full process. It's important. Do not believe, do not trust on what AI is giving you. It's interesting, it's nice, it helps, but don't trust blindly. So AI, basically, we can use different models. There are few of them that we can use with Copilot, for instance, or any other assistant. But there are more than 1,600,000 models out there. Hugging Face. These are open source models. You can download them. You can run them locally. Probably you don't need to use GPT-4. For some tasks, maybe you could use Qwen 2.5, and it's going to give you a very good answer. And you don't need to go to the cloud in order to get the answer. So this is important, considering which is the model that you are going to use. The context, every time that you ask something to the AI, the context is super important. Usually, time ago, it was only about the open files. But now it can be the entire code base of the project. But you could add a lot of things into the context. Web page, the test files, using tools with MCP. Now we have hundreds of tools that we can use. Again, you should consider that when you use a tool, you are sending information to someone, somewhere. So be careful with what you send. But with tools I will show you later, we can do a lot of things to complement our AI assistant. Basically, we are going to use, in this distill feature, to summarize information from different sources. AI will use the models, RAG, if you have company information that you have added to the context for the AI, and also tools with MCP that can connect to other sources or even can execute actions. Some of them have price, and some of them are free, depending on if you are hosting them locally. So, understanding tasks. Basically, what we have is a lot of documents, issues that are not well defined, and also going into legacy code. So the usual approach is to read a lot, do diagrams, whoever does diagrams, and asking questions to a lot of people. But there are other ways. We can add docs to the context in order to, well, to ask for clarification, and also to break the problem into smaller pieces that we will implement into our features. Basically, an agent is what it will do. It will execute several parts. It would break it down and execute different parts and not the whole prompt. So if we are using an agentic IDE, in this case is VS Code. Most of the examples are VS Code. What we have is our prompt, the reasoning, if we are using the agent mode. Then we will have interaction, because this agent mode can execute commands in the terminal, can touch files, can do a lot of things. And usually, the first times, it will ask for permission to do it. So we have interaction. And then, in this case, we will have the solution suggested by the AI. If you pay attention, you see that there is a fetch in the prompt. And what it is doing is, hey, get this URL, that is the URL for a GitHub issue, and explain me the issue. So it will connect to the website, it will get information, and it will explain it to me, and it will implement the changes for me. With tools, it's very easy to install them. We just simply go to Awesome MCP Servers website. We'll find lots of them. And we add the lines in order to connect to the tool. Usually, it's a Docker execution, and it's very easy. In this case, we have the GitHub MCP server configured. So I can get issues. I can even add issues to the GitHub repository. I can touch the repository. I can do a lot of things. Well, the AI can do a lot of things. And in this case, I'm not using the fetch tool. Now I'm getting the get issue tool. It will get the information from the issue, from GitHub, and it will do the modifications. As you can see, it's even running the tests in order to modify the code. And if the test is not passing, it will modify the test. And in some cases, it will modify the code if it finds a bug. So again, using the agentic or the agent mode with tools, it's going to be helpful. In the code creation, yeah, you could be one of them. I've never been one. With code creation, we have several ways of interacting with the assistant. Basically, inline prompts. So we are going to do Command I, and we'll introduce something that we want that the assistant do. With comments, but I totally not recommend using comments. With inline chat, you have a conversation with the assistant. With comments, is way more difficult. And you still have the comments there. You need to go there and remove them. So I would totally suggest not to use comments and use inline prompts, or using the chat. The chat, it's also it's richer in order to create a conversation and suggesting changes. And again, the context, we need to add to the prompt the context that we want to use for our interaction. There is also one important point, is to guide the assistant. So if I ask the assistant, create me, I don't know, a method that iterates a collection of integers and give me the average number. What it does is to use a loop sometimes. But it doesn't use the Java 16 collector sting that exactly does that. So what we need to do is to create a copilot instructions in this case, and copilot will use this to send this information as a system message. And then we can say, hey, use the Java latest features, the Java 21 features, or Quarkus best practices, or JUnit 5 or JUnit 4. You can specify lots of things that the assistant will take into the conversation in order to suggest best things. Different IDEs like JetBrains have different files, but they also support this. In order for selecting the model, well, you need to choose or select and try different ones in order to see which is the best result. But Hugging Face has what they call the big models leaderboard, where there are lots of models rated in terms of code generation, depending on the language. So the best one for Java in this case is Qwen 2.5. So we can just download this model, use Olama, for instance, and then we can have a local agentic assistant. In order to have local agentic assistant, I haven't found any way easy to do it with Copilot. But there is a plugin called Continue. With Continue, you can select models, local models using Olama. And then, depending on the model, you can also use the agentic mode. And they also support MCP tools. And it's open source. So definitely, it's worth to try. And then what we can do is to have everything local, and we don't go anywhere, just to ask our questions. Again, it should not write your core. You should ask boilerplate code or easy code that you can understand. It's super important. And if you come back tomorrow, you will still understand what it is doing. It will give you time to do other things. It's the point, not to solve problems. It's to give you time, basically. And you always have to review the code, because guess what? When you do git blame, never says Copilot. It is your name, what it is in the git blame. So definitely, it's important to consider that it's you who is going to suffer the fight with the rest of the team. Also, security. Sometimes Copilot is not giving you the best approach. It's not considering the best, it's not considering security or updated libraries. So it's important that you review that in order to check for security issues. With testing, it's interesting because we know that testing is important, right? Well, only 2, 3? Who thinks testing is important? Come on. Okay, so it's important. So why we are giving the task to AI to create the tests in some cases? Who creates the test with AI? Okay. It's easy. It's fast, right? It will help you in this time-consuming task that it is creating the tests. So what we do is we go to our method and says, hey, Copilot, create the test for me. And Copilot creates several tests, even corner cases, edge cases. Awesome. That's fine. But it's super critical because it will give you the false feeling of confidence. And guess what? When Copilot is creating a test, what it is testing? The business need or the code? So what it is doing is testing the code, even the bug. So if you have a bug in your code, Copilot will create a test that effectively tests that bug happens. But that's not what you want. It can help you in order to create boilerplate, to save you time. This is what AI is for. It can create incorrect, incomplete, useless, assertions. And with poor quality, as the rest of the code. So it will help you. It will give you time, but it won't give you confidence. This is the summary of the talk. It will give you time, not confidence. And sometimes it can also over-rely on mocking, and you have 10,000 mocks for a simple, stupid test. So do not blindly trust AI-generated tests. For instance, in this method, it is a method that calculates your tax. So you give the method your salary, it will calculate the tax, and this country is giving a deduction. I don't know if it happens in Bulgaria, not in Spain. So in this country, they give deductions. But apparently it is not checking if the method is returning a negative number. So you have a salary of 1,000, you have a 20% tax, and there's a deduction of 1,000. Great. The government will give you 800. So the method has a bug. But we have a test for it. It tests that if you give a small number, you will get a negative number. Perfect. Everything green. Deploy. Especially on a Friday afternoon. Deploy and run. So again, it's up to you to check which are the use cases, the corner cases, and to check if the test is doing what you are expecting. For that, you can also use static analysis tools in order to test your tests. They also have rules for best practices, for frameworks. For instance, well, Sonar, as an example, has several rules in order to check for test methods. So it will check that you are doing things correctly. So run also static analysis tools in your test classes. Deployment. Wow, this is a bit scary, right? Because the problem is that when we ship our code, it's involved a lot of YAML files. Who loves YAML? It was you and you. OK, perfect. I knew there was someone, so now I know who it is. OK, so you use Docker files or Kubernetes, Terraform, well, whatever, infrastructure as code in order to define your DevOps pipeline, right? But it's easy to sleep them credentials. It was yesterday or the day before. I gave a talk about infrastructure as code quality in Germany. And I was talking about that. How many issues we don't think it could happen that there are in the public repositories out there. A lot of credentials are coded in the deployment files, secrets. There's a lot, using the Sonar telemetry. So it's a real issue. Check tomorrow your projects, or maybe not, wait for Monday. So with AI Assistant, in this case, for the deployment, this is K9. It's a command line tool in order to connect to your cluster. I have a local cluster using Kind. And what I want is to create a YAML file considering the files that I have in the cluster already running. So in this case, what I prompt is create a Kubernetes file that deploys this application, well, that changes this YAML file, considering another one, using the labels and concatenate the label. Well, I don't know exactly which is the value of this, more than testing or more than to show you the tool. But let's imagine that this is an amazing and super important feature. With this pods get that you can see here, I'm using the Kubernetes MCP tool server in order to connect to my cluster, get the pods, check the labels, and what Copilot does is to create that file. So it is, the black part is what we saw down with K9. And then it gets this value and modifies, or creates a file doing this. So I used natural language in order to tell Copilot to do something, and it connects to, in this case, Kubernetes, gets the information, it knows which files to touch, creates a file, that's it. Then I need to review it, obviously. But it helps a lot to use MCP servers, especially if you control where the information is going or in which country those MCP tools are running. But also, it can help you in order to create a specific variables and arguments for your Java applications. So you need to tweak the memory for those pods. You need to send JDK or JVM arguments. So it's important that you use AI, again, to save you time, but you put the criteria, you put the experience, and it will help you with that. Also, with the JavaOps environment variable, again, you can just tell the assistant, hey, use the correct JavaOps for an application this size. And the assistant will get the variables and the arguments and will do the modifications for you. And also the liveness and readiness probes that usually we miss them. So again, you can have all of this information in the Copilot instructions file that I just showed you at the beginning, saying always when you create a Kubernetes file, consider the JavaOps, consider the memory arguments, and consider the liveness and readiness probes. And then when it creates a file for this, it will add this information to the file. So add the right context, and the AI will give you a more interesting answer. But review those files again. Security is crucial. You can sleep credentials. Insecure defaults, or just opening the network for anyone just because it's easier to test, and then one day, that POC that we all agreed it was a POC and would never. Now I see the application in production. Oops. So sometimes these things happen. I assume that nobody on purpose hard codes credentials. So what I think is we start with POCs, with ideas, we test them, we run them, we do it super fast in 1 week. But then life, the stars, makes hard to guide the assistant in order to follow best practices on everything. Test thoroughly with deployment files. You can do unit tests. You can do dry runs. You can use local stack. Who uses local stack? Local stack is amazing. I used it in a project when I was working for Red Hat. We were testing 8 layers with different things. And every time that a commit was started, it was starting all those Docker containers with all the layers and everything, and checking everything. And the same versions are in as in production. So test with different methods. There is something called Azurite emulator that also emulates the system, and then it allows you to test all your files. And important, understand what you are putting. It's not only related to AI, but it's the same as for Stack Overflow-driven development. So don't just copy, paste, understand what you are doing. So, well, manual review is important, but again, tooling. Use infrastructure as code scanners. There are several. SonarQube is one of them, but there are others. And then it will give you confidence before you submit your changes to the pull request. That's also important. I always say that IDEs are like Las Vegas. Who has been in Las Vegas? You know that what happens in Las Vegas? You know now. You remember things that you won't tell. Okay, so what happens in Las Vegas stays in Las Vegas. So what happens in your IDE stays in your IDE. So you use the tools right from the beginning in your IDE, and then the pull request comments would be easy, kind, warm, and about psychology or philosophy, not about specific, simple issues that you could have solved having a linter. Code reviews, talking about code reviews. So usually, code reviews are time-consuming. It involves a lot of cognitive load because, hey, you are a reviewer for a pull request, and it's like, I don't have a clue what it is this going on. So I don't know what this issue is doing or this code is doing. So it involves a lot of effort. You, in this case, you're lacking of context because I don't know. I was focused on another thing, so context switching is also affecting this. But you can miss issues because you are focused reviewing other things, or the person that has submitted the pull request is missing issues. Sometimes, well, this was very frustrating for me. You create a pull request with several files. You think you did, wow, this is magic, what I've done. And then one says, this variable has only 3 letters. It should have 5. And it's, come on. This is the first comment that you was thinking about. Well, sometimes it's about naming, spaces, I don't know, silly things. And it will also imply that you submit your pull request, and then you need to wait for comments, and wait for approval or rejection. It can create team friction. In my case, it has created team friction. Not everyone has studied psychology in order to give comments or feedback. And sometimes it's like, come on, you could have said things in a different way, or maybe there are other realities and not only yours. Subjectivity, So with AI, what we can do is to mitigate time consumption, high cognitive load, and lack of context. Again, AI saves you time. It doesn't give you confidence. So it will create PR summaries, considering the changes, and also if you give more context, it will connect to those contexts too. It will explain small changes in a pull request. I don't know why this is how it is. And it can even suggest better approaches. So it's not that you need to go and read all the Java 21 or 23 features in order to suggest new implementations. You can ask the assistant. But you need deterministic tools in order to check issues and enforce best practices. Don't rely on AI. It's not deterministic. It happened to me that I asked Copilot, because at Sonar we were creating Spring Framework rules. And there was a rule I was not sure. So before asking to the team, hey, you should change it, I said, I will ask Copilot. Copilot, I think this is not right. I think we could add more parameters to this method. And Copilot said, yes, of course. And Spring will inject those variables directly. And if it cannot inject those variables, then they will be null. So what I did, email to my team. Hey, I don't think this rule is correct. And they said, after investigation, I think it is. So I went to Copilot again. The same conversation. Copilot, are you sure this is right? The answer was no. In fact, it's not. So this is the right situation. Okay. So I said, apologies, my fault. I should have tested before. But I thought, let's take this a bit further. I went to the same conversation with Copilot, and I asked it, are you sure about this last answer? And Copilot said, oh, no, you are right. The right answer is the first one that I gave you. So never rely on what Copilot, well, AI is giving you. If you go with GitHub pull requests, now directly in the website, what you can do is, well, during in the pull request web, you have 3 dots, and you can give personal instructions to the assistant that it will take into consideration whenever it is suggesting or reviewing. Again, here you can tell the assistant, check code quality, use Quarkus and BAD in best practices, in this case, use latest Java version features if possible, and even give the information in Bulgarian. I don't know. Just because it's easy for you to understand the comments from Copilot in Bulgarian, or, I don't know, in whatever other language that you prefer. So you can tweak the way Copilot is behaving during the pull request. For this, I've seen a lot of pull requests without a description or with a very poor description. You can ask Copilot in the same website, give me a summary of this, and it will give you a detailed description of what the pull request is doing. So that's also important for summaries. You can have for each line the icon of Copilot, and then you can ask, explain me what it is doing, or explain the code from this line to this line. And it gives you a suggestion of what it is doing. So it can help you a lot in order to understand what your team colleagues have done. But also you can improve how can it be done, this method. So is this method using the latest Java 21 features? Can it be improved? I've done this in a part of the code. So it will give you the explanation why it is or it is not using the latest Java 21 features. And it will give you the code that you can copy and insert into the pull request. Again, you have with the pull request connected to a tool that it is checking and verifying. So use this pull request decoration, and you will see if your pull request is passing the checks or not. So again, it's not a replacement. It gives you time, not confidence. You need to evaluate always the answer, and it serves to do first pass checks and give you more time, but not confidence. And finally, trying to keep high quality. Let's talk about vibe coding. Who doesn't know what vibe coding is? Perfect. So Andrej created a term called vibe coding. That what it means is you use AI connected to a lot of places in order to create an application. But usually you don't refactor, you don't touch the code. It's everything done by the AI. It uses an agentic IDE, in this case Cursor, but you can use other agentic IDEs like VS Code, IntelliJ, or others, Juni. And is using models, context, and tools in order to do everything. But in summary, vibe coding is this group of guys plus magic. But the first thing is, are you going to understand what it is doing? are you going to be able to modify it or to fix it? So the first step is, I don't understand really what it is doing. The second step is, it is failing, and I don't know why. The third step is, it is working, and I don't know why. And it's like, come on, I'm going home because this is not practical, and I don't, hopefully, put it in production. So there are several movements now against vibe coding. It's considered harmful in Reddit. There are people just saying, I will make a lot of money out of companies using vibe coding and not knowing how to solve the issues. This guy is charging $1,000 an hour to fix vibe code mess. So basically, don't use vibe coding. Do things with your brain and use AI in order to do those things. So because basically, it's not deterministic, lacks true understanding of the context, can hallucinate and give you false positives for everything, and will overlook vulnerabilities. And it's wrong. Sometimes it's wrong. In fact, it's wrong 51% of the time. So it's only correct 29% of the time, and partially correct on the 20% of the time. It creates issues depending on the complexity of the task. And if for a simple, very simple application, I ask Copilot, create a deployment Kubernetes file, it's a file with 6 issues. It's a very simple file, and it contains 6 issues. But you need to use static analysis because it is giving determinism to the process. So you can repeat, and every time that you ask a SAST tool, it will tell you exactly the same issues. It is specific because it's focused on specific parts of the code. Every rule has a lot of code checking for specific parts. And it will introduce, obviously, a high confidence in your pipeline. Now you have time coming from the AI and confidence coming from deterministic tools. So it will help you to learn, to have self-confidence, to create quality. It will give you speed because, again, it's not that you create something, you submit it, it fails, you modify it, it fails, you refactor, it fails. No, you will have all the information and the feedback from the beginning, and it will increase team morale because you are not submitting, let's say, super easy issues to the pull request. So you are going to have conversations about important things, and it will impact in the result in the product that you have. Using static analysis tools from the beginning. As I said, in the IDE, these static analysis tools will check the code, and it will give you the issues. And then you will have a CI/CD pipeline connected to those tools in order to prevent that something was missed during the process. But you need to also introduce methodologies, TDD, rigorous testing, human code reviews, and pair programming. It's super important if you can include pair programming. So I'm wrapping up because it's almost time. So basically, the conclusion is that AI is not taking over the Java development. What it is giving you more time to do more interesting stuff. It's useful, yes, because I've shown you that you can use it for lots of things. For distilling documents, repetitive and boilerplate code, for predictable methods, that's easy. That's fine. But it's not magic or infallible. You cannot rely or trust blindly into what AI is generating. And critical thinking, again, is important. Human review and using deterministic tools that will help you during the process. Here you have the slides so the QR for the slides. Also, the feedback. Please give me feedback. If it's bad feedback, I will totally appreciate too. This is the first time that I'm delivering this talk, so for sure I've done several things in the bad way. You will help me. Also, if you connect to the slides, You have here the links for all the other presentations that I have. So the slides about code quality, top security issues, infrastructure as code, zero trust, Kubernetes, test containers, or migrating Spring Boot to Quarkus. That's all. Thank you very much. Mnogo ti благодаря. Don't go. I need a picture. Thank you.
There are a lot of places on the first row here. So feel yourself upgraded to the first class for free. So once again, I kindly ask you not to stand at the doors. So everything is okay. Okay, technical guys, everything's okay, yes? Good to go. So lovely. Okay, I hope you had your lunch. And I hope it was good, because once again, we do experiments with food, like every year. So we will watch the reaction on you. Was it okay? Yes, once again, I believe this is one of the hardest talks. Second day after lunch. Yes, most people will be sleeping, so don't hesitate. What's special about this talk is that the presenter Taner, as our good friend, he started mostly from our local events and from the jProfessional events. So once again, how many of you have been to jProfessionals? Yes, great. Next time, please more people to come. That means that the idea of jProfessional is to raise new speakers, to help them get to the stage, to help them get experience for other great speakers. And that's what makes me really happy that finally Taner is on this stage of jProfessionals. And he's going to talk about really important stuff, about the architectures. So I really want you to very warm welcome Taner.
Thank you. Okay, now we have audio. Okay, hello everyone. I hope the lunch wasn't too heavy, because this talk will be heavy for sure. But I'll try to not dive too deep into the details. We have a lot of things to cover, so yeah, let's continue. I want to talk about architectures in Java, which is something I'm really interested in. Can you see the mouse pointer? Okay. Wait. Yeah, which is something I'm really interested in, and I think it's not really talked that much, especially in the Java space. But yeah, we'll see. Okay, let's continue. So a few words about me. I am Taner Ilyasov. I work at Trading 212. I'm a Java geek, through and through, both in drinks and programming languages. I'm a productivity geek. I really love everything about tools and finicking with things to improve my way of working. And I'm a master procrastinator. So you can be sure the last slide I edited was 20 minutes ago. So, yep. Let's continue. I want to scope this presentation, and I want to say when these days, architecture is a really big buzzword, because yeah, whenever you think of architecture, you start thinking about AWS, Kafka, RabbitMQ, message queues, and so on. Today, we're not going to talk about distributed systems, and we're not going to talk about the social aspect, which is, for example, the architect elevator. We're going to talk about the most pettiest form of architecture, which is yeah, my most favorite, and that is where do I put this freaking file. So, how many of you have inherited a Java code base that didn't really have an architecture? You don't really know where to put any files. You spent like 2 weeks onboarding just to get the sense of which features, where you work on them. Most of all, it looks like this. This is what you call, in these days, when someone thinks of a monolith architecture, this is what most people see, or most people imagine. This is a term coined like a lot of years ago, and it's called big ball of mud, which is when you don't really have any architecture, you just go with the flow and put all of the files, dependencies, wherever it's most convenient at the time. But when you don't really have an initial architecture, you can't really keep the same pace. Like initially, you have productivity because there is no technical depth at the beginning. So you're fast, you're pushing features, but then productivity slows down, maintainability becomes really bad. You can't really think about scalability because you can't even push features. And no one wants to work on this project because, yeah, it's very hard to get into. So the idea is if you spend a bit initial time thinking about the overall structure of your application and where to put the freaking files, the curve won't really go that high in terms of cost of implementing a feature, but it will go in a steadier pace. That is what we win with microservices as well, but I won't bash microservices today. So, yep. So, yeah, let's see evolution of Java architectures. And the evolution goes like when we start with a project, we have just a single, we have multiple lines of code, so you just create a script. Then at a certain point, you start structuring the parts of code into methods. Then it grows to like 1,000 lines. You start thinking about files. Then you start thinking about packages. When you hit like some threshold of 50,000, then you say, okay, I need to separate into specific modules and then think about some organization because it starts getting really, really slow and really hard to work with in general. Is there anyone who hasn't seen this package structure? Like half a hand. Yeah, this is what I call the default architecture these days. Some would say this is the MVC architecture. For a long time, I thought it was called an MVC architecture, but no. MVC is something which touches upon really something else. Now, since we're at a Java conference, we're going to only talk about the common enterprise Java applications where we don't really parse and render the view code. So we don't parse the HTML, we just have APIs that the front end is calling. So this is called a layered architecture. It's also called n-tier architecture in some places. Most diagrams like this show it as like a 3 layers, but it can have a lot. The most I've seen in one project was we had 7 layers, which is all going down. So this is where we organize our layers by concern. So all of the controllers, we put them in the controller package. All of the business logic, we put them in the service package. The domain has our business classes. And we probably have like a repository package where we put all of the data access objects or, repositories. And what is really important here, as you see, the flow of control goes down. So the controllers are calling the business is calling the repositories and the data, and the infrastructure is all around. When I say the infrastructure is everywhere, what I mean is in the data layer where we should have like the core of our business, the data models, we have @entity by Spring, which is an infrastructure concern. It's not a part of the business domain. So yeah, this is how the structure looks like. We have a project, controller, services, repositories, models, and so on. And then, as with everything in architecture, we have trade-offs. This is simple and familiar. We have a clear separation of technical concerns. It's widely supported by frameworks, especially I think as much as I like Spring, even though most people don't like Spring. Layered architecture is a first-class citizen. They have all sorts of annotations which, for example, you don't really need to have a service if it's a component, but you have a service because it's easier for people if they just annotate something as a service and you know what to put there. This is really good for really small applications, but it has its trade-offs. The issue is domain logic is scattered across layers. So when it's scattered across layers, it's really hard to find all of the code that you need. So it's really easy to start duplicating code just because you can't really find something. You add something in one place and then you can't really find the other places where it's affecting, because yeah, it starts getting really tangled at a certain point. And it often leads to anemic domain models, which means we have a domain where the classes don't really have any code. They're just carrier objects, which a lot of people have opinions on it, but I think some domain objects can also have business logic inside of them, because this at a certain point leads to huge services, really small controllers, and then really small domain models and a repository. So you basically bundle up everything in the service in general, and that's not nice. Integrity challenges that we have with this architecture is layer violations. So we said the flow of control should go from top to bottom. If we start calling from the domain the service, that's not really nice, because then we start going into not really following anything. And as one of my favorite theories, it's the broken window theory. When you see a violation in one place, you do another one, and then they start piling up. The service layer, as I said, it can blow up, it can become really big. And then, yeah, duplication, as I said. So let's continue. And then we have domain-centric architectures. Like when layered architectures, yeah, at a certain point, people said, we need to think about something else. We need to have a clear boundary and safeguard our domain, which is the core of our business. Like the technical advancements in our projects isn't what's making the money for the business. It's the domain problems that we are solving. So that is the thing that's core and it's most important. So there are a few architectures that their whole idea is to protect the domain. And there's an evolution which started in 2005 with the ports and adapters architecture by Alistair Cockburn. So the whole idea with this is you have a domain, which is the business logic at the center, so that's the heart. You have all of your business concerns there. You don't really have anything infrastructure related. The domain doesn't know anything about if you're using Kafka, if you're using whatever messaging service, and so on. And you communicate using ports. And then the technical concerns are in the adapters themselves. Let's look how this is possible. How can the domain not know how we're sending a message? So if we look at the layered architecture again, we see we have a user interface. The flow of control goes from left to right. We have the business logic, the data access layer. So in this case, when we want to persist something, the business logic calls the data access layer. So it knows about the technical concern of that we're using a database, for example, PostgreSQL. So what we do is we invert the arrow, we invert the dependency, where now the data access layer knows about the business logic, so it knows about the domain, the core. And the flow of control still goes from left to right. Normally, we have something like this when implementing these services, which are really CRUD heavy. We have the service calling some kind of a repository, and that repository is an interface in the data access layer. And the repository has an implementation, which is, again, in the same layer. So what we can do is we can move the interface. Move, please. yeah, we can move the interface into the business domain, into the heart of our application. And then the implementation is in the repository. So what happens effectively is in the repository, we just have, for example, a method name, an interface, what we want to do. So send a message. And the business doesn't know anything else. The adapter knows about the business domain. It knows that we have a necessity of sending a message somehow. So in the data access layer, now we implement that using whatever messaging technology that we want. And then we can easily replace it without at all touching the business layer. That's the whole point. The point is, whenever we have a business concern, some kind of a feature, some kind of an implementation, we just do it in the core domain of our application. We don't touch the technical layers, so the outside layers. And then whenever we are changing our database, we just touch the data access layer. So in this scenario, the interface becomes the port, and the implementation becomes the adapter. If we look again at this, so now I think it becomes a bit more clear how the core, the domain, doesn't really know anything about the outside services. Something else that is really important about this architecture, we're separating the adapters into driving or primary adapters and driven adapters or secondary adapters. And the idea is the driving, the primary ones are the inputs into our application. That's the REST controllers. If we have a Kafka listener or something else, this is what's coming into the application. And we do whatever else. And the driven adapters are what is going to the outside, sending a message to someplace else or committing something to the database. The structure looks a bit like this. So instead of the controller, service, repository, model, and so on, we have an application. We have application or the domain. We have adapters. And then in the adapters, we implement like the input adapters, which is the web layer, for example, the controllers that's coming into the application, and the output ports are the persistent, the messaging, and so on. And in the heart, we just have the model. We have application services where we have the business logic, which is agnostic to the technical concerns. Again, we have some trade-offs. The good thing is now the domain logic is isolated from the technical concerns. This means, yeah, you can just have people working on the domain, and those people may not even be really good with technical databases, Kafkas, and so on. They're just really good with the business domain in general. And you can have teams who are working on the business. You can have teams who are working only on the technical details. And they don't even need to know that much about the internal business rules. This also means it's very testable. You can mock everything out from the external layers and just test your domain. It's easy to swap the infrastructure. You can, yeah, the idea was you can just swap out your database with some other database. You don't touch the domain at all. And technology decisions can be different. If you know you will need a database that needs to be very highly scalable, but now it's very costly to implement it initially out of the box, you can just use something else like SQLite. When you hit an issue, then you start migrating, and you can scale the features with the business and the technical layers independently. But too many interfaces, too much indirection can cause a lot of overhead. If we go a bit back here, you see the driving ports. No screen here. The driving ports is not really a good choice. I don't think anyone who actually uses hexagonal architecture uses the driving ports, because what that means is we have separate interfaces which just proxy to our domain, which just proxy to the services. So there's no point at all of that. So it's important to be pragmatic. I'll change the slide when the pictures are taken. Okay. We'll have nicer pictures. Let's trade off. And then, yeah, it can be really excessive for small applications. This became, yeah, this is good when you have an application which is heavy. It's not just, okay, you get data, you write it to the database, get it out. The idea is to have applications which are really big in terms of business logic. That's why we're trying to safeguard it. And yeah, it requires a lot of more upfront design work. Integrity challenges here. You can have the domain code depending on the adapters, because we need to deliver this tomorrow. We can't go through, create new abstractions and so on. So if you start breaking dependency rules, at a certain point, you will drift away. If you have adapters bypassing ports, again, won't be nice. So we can have a lot of things, a lot of issues that can just lead us back to the legacy effect. So then, in 2008, we have the Onion architecture by Jeffrey Palermo. And the idea is the same. The core of the business application is again in the middle. But now instead of the hexagons, instead of the ports and adapters, we have just said push everything to the outside. They also call this like a concentric architecture. It's like a surface. The flow of control is from top to bottom. So presentation, persistence, infrastructure, the tests, it all depend on the application inside. And what he did is he said, okay, why not separate the domain services from the application services? Because it's nice when you say, okay, I want here only to have at the center the business logic, so I can talk through with like a product specialist and then talk through features. But we always have an orchestration kind of code where we need to jumble up separate features, and we need to know about concerns like sending events and so on. So we separate the application part, which is where we do the orchestration, from the domain. Another way this is visualized is like this. We have application services and we have domain services. So domain services can be mostly like the CRUD heavy applications. We have logic which is going to the database, creating an account, viewing an account, deleting an account, and so on. But when you have a feature, a use case which involves doing multiple operations over the business, then we push that out to the application services where we do orchestration. And then 2012, we have Clean Architecture by Uncle Bob, which kind of looks the same. And most people argue, I argue the same, that it is exactly the same thing. What Uncle Bob did is he used a bit more specific terms and so on to present the same idea. And I think this is the most popular out of all of the architectures after layered today. But yeah, idea is the same. If you say I use Onion architecture, you probably use clean as well. Clean sounds cleaner, so I prefer to say clean architecture. So yeah, same thing. And yeah, when we look at it, both the Onion and Clean, we go from the outside, so database, to the controllers, use cases, entities. The flow goes from outside the circle to the inside. He says we have enterprise business rules, which is very core specific, which is in the domain services, and we have application business rules, like when we're creating an account, but when do we notify some other service? When do we clean up something and so on? That's all orchestration code that goes to the application business rules. And he's saying we can play with the flow of control. We don't always have to go into the use cases, the entities, and so on. We can just skip through the database if we need something specific. There is a PHP guy, which is something really strange, because when I hear PHP, I think of legacy, I think of no architecture at all, but apparently they think about this stuff too. Is there any person here who writes PHP today? Almost all of you. No. So what he did is there is a link there which leads to a blog post. He has a series of blog posts going over all of these domain-centric architectures, and then he starts putting all of them together into this majestic diagram that you see. I would love to go into it, but we don't really have enough time, I think. So let's see the structure. The structure would look like this. With onion or clean, we can call our packages use cases, or we can separate them as application layer that has its services, it has its DTOs. We can have the domain package with the domain services and its specific models that we're going to work with, or data carrier objects, and the infrastructure, which is in the outside. And the domain doesn't know about the application doesn't know about the infrastructure, and so on. That's the idea. Again, trade-offs. For clean architecture, hexagonal, for all of these concentric ones, it's nice that the domain logic is isolated from technical concerns. Business rules are testable. We're repeating the same thing with the hexagonal. Decisions can be deferred. We can swap things out. Overload of interfaces, but it's a steeper learning curve, because the more rules we put on the architecture, it's scarier for new developers to go in. It's scarier for people who have just worked with layered architectures to go in and want to do it. And it's very hard to keep the architecture in track and not let it drift away. It's excessive for simple code applications, as we said. And it requires discipline, most of all, in people that care, that work on the project, so we keep it healthy. We have integration challenges, which are the same. We don't want abstractions to leak. We don't want circular dependencies between layers. In general, we don't want layers that, we don't want dependency from the bottom layers to the upper layers. And when I say dependency, in this case, the dependency means even knowing about a file that exists in a different package. So just importing a file, that means we are depending on that specific layer. Then, I think 2018, someone had an idea. What if we organized our code around features or use cases directly? If we look again at layered architecture, we have presentation, application, domain, infrastructure. We say top to bottom. So why not just chop it off? And we have features that go from top to bottom, but they are split. So now, with vertical slice architecture, the idea is we just separate the whole feature into its own layered architecture inside. So all of the technical concerns are within the boundary of a single feature. So what we have is really smart, separate pieces of the code that it's very easy to go into. When you need to do a feature, when you need to create a new feature, you just create a new package, name it, create your controller service, whatever you need. We don't really care, we don't depend on the other services. That's the idea. Yeah, this is called vertical slice architecture. We organize now the code not by technical concerns, but by business concerns. Each slice contains all of the code for one feature. Slices are independent from each other. Yeah, at certain point you will need to have like a shared module that all of the feature ones depend on it. You will have a core domain, but we need to keep it as small as possible. And it's very heavily inspired by CQRS principles. We can create separate DTOs just for creating an account and then extracting it. We can optimize for use case by use case without all of the technical depth from all of the other features that are going to make us do shortcuts. Yep, optimize for real-world change patterns. So this is how it would look. We have features, and then we have add product, place order, view product details. All of them are in separate packages. We have all of the files inside those packages. The slices don't know and don't depend on the other slices. We will need some kind of a shared kernel in the end. As I said, we need to keep it small. And who says we can't have a feature which is just a single file? I don't know if we can see. Can I do this? No. I can't zoom. Wait. No, can't zoom. So you see, this is a single file. If it's readable, we have the controllers inside, we have the command, we have handler, and everything about this feature is encapsulated into a single file. If the feature is small enough, you don't need to create all of the boilerplate controller services, domains, repositories, and so on. So we have very high cohesion, where cohesion means all of the code that relate and depend on each other are sitting in one place. They're not scattered across the application. We have easier onboarding. When you have a new developer, they can just go into a feature, see only 5 files. They work with that. They don't need to learn the whole database, take 2 weeks, and then introduce 5 bugs for the first feature that they're doing. We have reduced context switching. Since we have lowered the scope of the code that we need to look at when creating the features. They can evolve independently, so you can use separate, clearly separate patterns to implement any of the features. Fewer dependencies between teams. We can separate and we can say, okay, these features are for this team, the other features are for team Pechurki, and so on. When you have a layered architecture, it's a bit hard because when your team is growing, when the domain is growing, you don't know who works on what. So what we have normally is everyone works on everything, and we're all just making it hard for each other. So this is very nice to be able to segregate it. But we have a lot of code duplication. Since we're not going to depend when we're doing, for example, add product feature and then edit product feature, there will be a lot of code that will look the same. It can be the same. And that's not that bad. The issue becomes whenever you have something very core to your business, like if you have, as with trading 2 on 2, so you can have a lot of calculations that you need to do in one way. You need to do that calculation across multiple features. And when the formula for that changes, You need to go and change it across all of the features. So in cases like that where you have business logic which will be scattered across everywhere, this may be not the best choice. It's harder to enforce consistent patterns because one team can work in one way. They can use design patterns, follow solid principles and so on. And then you can have just the tiger team mulling through and then implementing whatever comes to their mind at some point. Cross-cutting concerns are hard to manage, and yeah, shared logic is bad. Integrity challenges. It's not, it's hard to not have coupling between the slices. The shared package can grow really bad, and if you grow a shared package too much, that may mean it's better to merge two features together, but then that feature can become too big and bloated and not follow the single responsibility principle. So yeah, watch out for that. And probably a lot of people now think, I think we cut to small chunks. So if we go back to layered architecture, where we had a controller service model, it's nice, it's simple. When we have all of the files in those three packages, when the file sizes grow inside a package, we always start introducing now, okay, we always have orders, so say order package, account package, products package, and these are repeated in all of our layers. So why not just inverse it and say the business terminology packages are at the start, and then the technical things are inside. This is also called screaming architecture, which was coined by Uncle Bob, I think 2013. Now the diagram would look like this. And the nice thing about this is, now who says we have to use layered architecture or we need to keep a specific architecture in each module? So the orders team can use layered architecture, another team can use hexagonal, another team can use vertical slices. So depending on the use case, depending on the team that's working on a specific architecture, they can just choose, and yeah, there's complete freedom. So Conway's law is very easy to follow in here. This is what we call a modular monolith. I don't think anyone coined the term. Simon Brown is like the person who always comes to mind when you think about this, but there's not really a year or when of the term modular monolith. So it's a single deployment unit. And why I'm saying single deployment unit is because a lot of the good things about working in microservices architecture, where you can separate teams to specific microservices, you separate your application to smaller chunks which fit in your head, as Dan North says, we can do it in here without paying the price of using microservices like added latency, error handling, and everything. Modules can have clear boundaries. We can hide the internal implementation details. We can develop them independently. And it looks like this. We have the orders package. So this is a look into a single module. This is an architecture that is a bit harder to enforce because you need to not give access to the other modules. So what we do is, inside a module, we define an API. If we need REST controllers, so an outside client to go inside, we will have an external controller, an external API, and then we have an internal API. The other modules will need to go through the internal API and ask for a product, ask for an order, ask for an audit or whatever. and they can't see the services, the repositories, the model, or anything. They work with the DTOs as if it's a microservice that we're working with. So teams can actually own their data, they can safeguard their data. So multiple modules, again, would look like this. The APIs are the gateways into the specific modules. You will need to have a few shared modules, again, for cross-cutting concerns. But yeah, trade-offs, again, we have very strong boundaries with explicit APIs. Teams can develop modules independently. The architectures, as we said, they can be very flexible. Teams can choose how they work, and they can just give specific only gateways into the application. And a very clear concern of business capabilities without slicing too deep. But modules need to be carefully considered, which is the same thing with microservices. The nice thing here is when we have not cut the business boundaries too well, and we want to merge them together, you can just drag and drop the files in IntelliJ, instead of taking 4 sprints to merge 2 microservices together. And at a certain point, if you need to scale, you can drag and drop into a separate Maven package, Gradle package, and you can deploy it as a separate microservices. This is a very good gateway into using microservices. But we have a lot of ceremony for cross-module communication. You need a lot of discipline to maintain this application. You need tools more than discipline. It's not suitable for small applications. Yeah, integrity challenges, cyclic dependencies is a very big no, like you have with Maven modules, like you have with microservices in general. We can still bypass that, but yeah, it's not nice. I'll speed up since we don't have too much time. This is, as I said, a very good choice if microservices is your goal, because you can have a very quick and fast iteration over your business as it's growing without needing to plan the whole domain and how to split it into microservices in 6 months. And you can just split as you go whenever it's necessary. There is a really nice implementation, or it's a very cool library, which is by Spring. It's called Spring Modulet. It's in general availability from, I think, last year or the year before that, where out of the box you get a test which you call modules.verify, and then if you break the dependencies, if you have a cyclic dependency or whatever, the test will fail. So you automatically just safeguard the modules and internal dependencies. You have annotations like application module test, which separate your modules into specific contexts, so you can just deploy the orders module. You just deploy all of the Spring context for your orders module, and you test it independently. You don't need to boot up everything. But yeah, good intentions are not enough. If you just keep coding, architecture starts to drift. So we have ArcUnit, which is a really cool library, where the point is, it's a testing library. Spring Modulet uses it at its core. It has a very simple, readable Java DSL integrated with JUnit. The idea is you can enforce architecture rules at build time. And it's very flexible because you can define your rules and you can have exclusions as well. So let's look at some. The layered architecture would look like this. You say, we have our layers, and you can say the controller layer should not be dependent upon anyone. The service layer can only be accessed by the controllers, and so on and so forth. If you have cross-cutting concerns, you can have You can ignore specific packages, ignore specific files from these rules. Onion architecture would look like this. Vertical slices would look like this. Modular monolith would look like this. This is a lot of typing. So Spring Modulith is really nice because you can just do modules.verify. But even without it, you can implement your dependencies like this. You can create annotations, and you can create rules on specific annotations. Like even if you just use layered, and people start putting things everywhere, you can have a rule in the service package. We can't put @entity, anything with @entity annotation. You can say, okay, we can't have cyclic dependencies, and so on and so forth. It's very flexible. What you see in the end is something like this. You have a test failing where it says specifically why it's failing. You can add a reason about the test. So the junior developer, when their test fails, it can say, you can't depend from the service to the controller because this is the rule, and so on. And it becomes a living documentation. So we're running out of time. So let's conclude. There is no one-size-fits-all architecture. You need to make a choice. You need to see where you want to go, and so on. Intentions are not enough. You need to leverage tooling like ArcUnit. You can use Maven modules to do clear separate layers. And then you have a compile time failures when you try to depend on something from the outer layer because you don't depend on it. But it's not really that flexible. You need discipline, we need shared understanding, documentation, and onboarding people with the architecture. And we need to be pragmatic most of all, because if you start just following hexagonal architecture and start making interfaces everywhere, but you will never replace the database since it's just a one-month project, then it just becomes too much administrative maintenance work. And most of all, architectures should change with the business requirements that are changing, with the technical requirements that are changing. Don't just start with an idea and then 10 years later keep on doing that same idea. It should evolve. And yeah, I'll conclude with this quote. Legacy code is not about software, it's about people. When you work with a monolith, it doesn't mean you work with a big ball of mud, as you say. And all of these rules, you can implement them in a microservice. You can have a float of big balls of mud, or you can have cleanly architected microservices or monoliths, whatever. And that's it. Thank you.
Like his packages, but I'm not like what's underneath it. And no, I've been to MIA. I heard the Cali never ends. I knew your heart aways. First, let's see the West End. I show you to.
libraries even, which is because the Java class file format is pretty complex, and as you might expect, I cannot go into the depth of everything here today. But we will scratch so much of the surface that you will be able to read up everything you're interested in yourself by your own. And anyways, like with all coding, you have to try it out yourself anyways if you really want to understand it. And then summarizing, I want to show you the wider impact, why this will affect the way you can use Java in the future, because once you made the jump to Java 25, you will probably be able to update your JDKs regularly without updating your libraries. You will still have to do it sometimes, but all in all, I'm expecting that the pressure to update will disappear, which doesn't mean that you shouldn't update your libraries. Of course, you should do that, but if you worked for enterprise customers like I tend to do, besides doing a lot of open source, you know also what pain this causes. So it will make the Java ecosystem more robust, and yeah, that's been an ongoing effort. So to start out with something tangible, what is a Java class file? Sorry? Oh, you don't see my slides. Wait, then I have to probably move this here, and then press here, and hopefully you see my slides then. Great, and I see my slides here down. Nice. Okay, so what's a Java class file? The JVM, very fortunate for us, is a very well-defined language. If you've worked with PHP or other languages, those languages basically happen accidental. So someone implements PHP and then says, like, this is how it works, and you can observe how it works, and you can, of course, do this with the JVM. You can run a Java program, and you can observe the output, and then you can guess what a Java program is supposed to be and how it will work. The Java virtual machine, however, is very well specified. This means there's 2 documents on Oracle's web pages, which for every Java release define on many pages what everything is, how the language works, how the grammar is defined. And it does so for the Java language, but it also does so for the Java virtual machine. So if you want to implement your own JVM, and that's not only Oracle that does that in OpenJDK, there's other people who do it, obviously, you can look into the specification and find out what an expected behavior is. And in the Java virtual machine specification, there's a whole chapter, chapter 4, that defines the class file format. And if you compile a Java program, right, you have your Java code and you run the Java C tool, it will output a class file. And not only Java outputs a class file like that, also Kotlin will do that, and Scala will do that, and all the other languages that run on the JVM. And the class file is basically the common denominator, which makes them interact, right? Without a specification like this, if the JVM would execute Java code as source, you would have to transpile. You would have to translate Kotlin to Java, which is very hard. But instead, Kotlin compiler can look into the specification, look into how class files are supposed to look like, and compile their code to the same format such that the JVM can execute it. And if you read this chapter describes the class file format, such and such, and each class file contains a single class, interface, or module, and you can already say here, wait a minute, what about records, what about annotation types? Those don't exist on a class file level. Records are just classes, and annotations such as interfaces on the class file format. So the Java virtual machine is basically a reduction of Java's complexity to the basic concepts of it, and it then tells you how to read a class file. Because if we, and to have that noted, I'm talking here today, especially if you watch on video, the Java version 24. Every subsequent specification of the JVM might, of course, change a lot, and that happened in the past, right? Java 7 was very differently specified than Java 8 in terms of invoke dynamic and lambdas and so forth. So this is something that will be released formally, and then every user can basically look at the difference of the specifications and update their interpreters and JVMs. Right, so what is a class file? Very basically summarized, it's a sequence of bytes, and a byte array is, of course, it's a binary format, right? It's not text. It basically says, if you encounter this sequence of bytes, it will be a class file. And the most trivial class file we can encounter is a class foo that extends bar, and you can basically open a hex editor and create this class file yourself. Every Java class file starts with a magic number, which is Java trivia. I think a lot of people know that every class file starts with the hex representation of Cafe Babe. You can tell that Java was invented 30 years ago when you would still make a reference like that. And now it's engraved in the class file format forever. Because if those numbers are missing, the Java virtual machine will not even consider the file you're presenting to it as a class file as a Java class. After that, there's different things. There's the Cafe Babe, the minor major version. 44 is the hex representation for Java 24, for example. Then we have those, right? And we have a constant pool, also something you will encounter if you work with class files. Basically, every Java class file lists all strings and numbers and references in a list in the beginning of a class file. And this comes from the times when applets were a big thing, because you try to compress, right? Normally, a class file is not shipped as a class file, it's shipped in a jar file. A jar file is nothing more than a zip file where you would have deduplication to some degree. But in the old days, when you would stream Java classes through the browser as applets, it was important that you already did some deduplication, and all this legacy in the class file format is still around. Right? So foo extends bar, we will need 2 strings. We will need foo and bar and nothing else, because there's nothing else referenced. So we will have a constant pool count, which is ironically also one more than the count, which references that, and then we will have some bytes that state it's public. We will have some bytes that just point to the constant pool index of foo, which is the second entry, the class of foo. Then we have the super class, which is the class of bar. Then we have no interfaces, we have no fields, and we have no methods, and we have no attributes. Attributes, most famously, are annotations. So if you opened a hex editor on your computer and you would punch all these bytes in there and you would save it as a file, you would have generated a valid class file, which you can validate with this specification, right? So, what is the class file API? You can guess that nobody wants to open up a hex editor. So since Java 24, there were of course libraries for that before, but since Java 24, OpenJDK has an API for that to create this byte sequence that is, according to the specification, a valid class file. And it will expose it to everybody through the Java base module. So any trivial Java program from now on will have access to this class file API. And you can already guess, I mean, Android, for example, doesn't use the Java class file format. This is parts of the big dispute that was between Oracle and Google around this. We will have to see if Android ever updates the Java 24 specification, how they're going to handle it, because it's very different. However, official Java, standard Java, which is all Java but Android more or less, will at least be able to do this. And you will be able to define class files the same way as we just did manually, but with a more readable API. So now we want to create this class, foo extends bar, right? How are we doing this? We will say class file of, creates an empty class file. Now we will say build. And now we will support a class description, which is foo. And then we will be passing a builder where we can say, okay, this class, we want public flags. We want to have the class public, because by default, everything is set to the default. The default visibility in Java is package private. Same goes for the class file API. And then we specify a superclass of type bar. If we don't specify one, implicitly, of course, object will be the supertype. And those implicit things, such as the Java compiler normally takes care for us, are added also by the class file API, so there's some convenience to it, but we will be operating on the class file format. So if we write this byte array to a file, foo.class, we will be able to look into the hex representation. Now, I won't go byte by byte, but if we compare this previous slide with the bytes that I spelled out here manually with what we have created with the class file API, they will, of course, be exactly identical, right? And that's kind of the convenience. And this, in a nutshell, is what I'm here to present. So if you understood what I was talking about so far, this is basically what the class file API is. And you can think of who uses class file API? Mockito. which I'm working with, right? How do we use class file APIs? A mock is nothing more than the class that you have written, that you have compiled, and then we will take this class, we will use the so-called Java agent to modify it, so that if you mark an instance of a class as a mock, we basically manipulate the method where we, in the beginning of every method, check, is this instance a mock? If so, do Mockito stuff. If not, do the regular stuff. And that's what we need to do, right? We have to go into the class file, have to parse out what it is, what every byte means, and then we have to change the byte so that the class now represents what we want it to represent. Same goes for Hibernate. Uses your bean, and whenever you set a setter, you also change the flag of the dirty field to true, and then when you pass it to Hibernate, Hibernate will check if the flag is set to dirty, and if so, it will persist it down to the database and so forth. The same goes with Spring. How does Spring transactional work? It again checks there's an annotation present. If so, we add some code to the beginning of the method and open transaction and close it in the end. That's why Java libraries need class files. And if you're interested in the use of class files and so forth, and class file manipulation, as I mentioned at the beginning, go to YouTube, punch my name, choose one of the 50 videos I've done on this, and you will be able to learn on that as well. But I'm not focusing on that today. Since this is the first time I'm talking about the class file API, I want to rather focus on this. Since it's a large topic. All right. However, now we created a boring class. So just to walk through quickly, to define a field, we will also have access flag. A public field will have the access flag 1, as the specification says. It will have a name, f. It will have a descriptor, mentioning the type here, which is a string. And it might have attributes. If it is annotated, it will be attributed. There will be the information about the annotation in there. And again, you have a potential use case. What does an annotation processor do? It won't load the classes and execute code. It will just go through the class file. It will find the attribute for annotations, and it will notify the API that something like this was found without even executing anything, right? Same goes for methods. Methods will have an access flag, methods will have a name, and they will have a descriptor. Descriptor is basically a concatenation of the parameter types and the return type, and those you might even have encountered in your career. Right? If you find a no such method error, those will leak the class file internals. They won't mention the Java names and Java type descriptions. As you see here, this is a so-called descriptor, the Spring Web Application context with the braces in front, which means no arguments, and the L in front of the type, meaning this is a class type, an object type, and not a primitive type, where, for example, integer would be I, and not int. So this is just also interesting to know for that reason, because you might have to debug these things at some point, and then you know how to read this and why it looked like that, right? Right? And these attributes, of course, you can also, and attributes. These attributes, you can also define custom. That is a nice property of the class file format. There's no limit to it. What you can add. You can have a custom compiler that adds custom information to class files that only your compiler is aware of. Again, this is very important to languages like Scala, like Kotlin, where you might want to embed information about a class file that isn't relevant to the JVM, that isn't relevant to the Java language, but that might be relevant to Kotlin again, right? You have a Kotlin compiled library, and your Kotlin classes might contain information that is only relevant to Kotlin. So you can embed this as a custom annotation, and your Kotlin compiler might then read this information and make use of it in a way that the JVM doesn't know about, right? So you can add whatever you want. Of course, you might wonder, where does code go? Where does things like sealed interfaces go? And all these things also are attributes. So every time the JVM introduces something new, and might it be as trivial as code to execute, it adds a new attribute. And those you can also find in the class file. You have constant values, which is the constant value of a field. You have the code, as I mentioned, like the method implementation. And you have nest host, nest members. You have many, many more that are all described in the Java specification. I won't go through them in detail. They have different relevancy. For example, these you might well know, annotations. the irony of annotations is that the JVM itself doesn't care about annotations. The JVM will never process annotations. It will never do logic based on annotations. It's just metadata. So for the JVM itself, you could just remove the annotation feature and it wouldn't have a consequence, right? Even modules are just considered by class loaders, not by the JVM itself. Okay, so let's rather look at a real class file. You've seen the trivial one I've shown you before. Do you think it's going to be as small as the class file we've seen before? Well, of course not, because Java-C adds a lot of stuff. It will add a default constructor, for example. It will add attributes like the code attribute, because a default constructor isn't empty. It will add a line number table so that you can debug your Java application, and it will also reference the source file to allow debugging and so forth. So in reality, class files are big, and of course for that reason also it's fully unrealistic that you walk through a class file manually with a hex editor like I show you now. And even though I've been working with class file manipulation my entire career, I've done it maybe once or twice in very rare scenarios. In reality, I will of course use tooling. So let's expand a bit on how this new class file API is working, right? So we already added foo and we made it subclass bar. How do I add a field? And of course, you can expand this concept, class builder with field. And now you can supply a method, a field type, a string, right? It's the constable. And that is also introduced to prepare this API. A constable is basically just this class desk that we've shown before, and every loaded class can be transferred to one. It's a bit annoying. You have to still return optional because there's a concept of hidden classes, which is used in combination with lambda expressions and so forth, which I won't go into either. So in theory, not every class has a constable description that you can reference, a name. So there's a lot of or else throw in this code. But then we say, all right, we define the field f, and then we'll make it public. Now you already have created a class file, foo extends bar with the field f of type string. Right, as easy as that. We can also add runtime annotations. Again, we can choose to have the type loaded, but, and that's important, we can interoperate with class files without loading anything. This is important because you can guess if you have, for example, a static initializer in your class, and you would do reflection, for example, in the build tool, you would load the class and you would execute the static initializer in a phase where you're not intended to run code. And of course, you normally don't do anything tragic in static initializers, but especially if you download something from Maven Central and you would process code in your build environment, this static initializer could access your file system, it could access your SSH keys and so forth. And there's examples of how this was done in the past, that people try to sneak malicious code into your machine by putting it on Maven Central, stealing a popular library from before, publishing a small update, and adding something to it. So by using the class file API, you can just parse the byte arrays without any possible code execution, and that's why it's, especially in build phases, much more preferred to use these approaches rather than loading and executing. Right. So it's pretty straightforward from there. As you might expect, the class file API isn't supposed to be complicated. It's supposed to be a proper representation of the format. This way we can also add a method. Now we have to add a method type description, not a single type description, which we concatenate by adding the return type and the parameter type. And further we add a modifier. This time we have to tell it what modifiers is before, and then we build the method. So I mentioned the code attribute, and in order to talk about class files, we also have to talk about bytecode. Those two things are often used synonymally. So people talk about bytecode when they mean class files and the other way around, because class files aren't complex. Bytecode, on the other hand, unfortunately is rather complex. Again, Java trivia, bytecode comes from the era of applets and is organized as a stack language. It is, however, implemented in a code attribute in the Java class file, and yeah, we'll rather walk through it. A small example of Java bytecode. How would Java-C translate this method to a code attribute, right? In order to translate or compile a method in Java, you have to understand the abstraction that the Java virtual machine defines for that. And the Java virtual machine defines code as a stack machine. And now if you think back to your university days, you might remember what a stack machine is. The reason why you just might remember it is that even if you work with hardware, there's no such thing in hardware anymore as stack machines. Modern processors use registers, you load data into registers, and you execute operations on these registers, like 1 + 1 is load number into register 1, load number into register 2, execute instruction 1 + 1, and load the result into register 3, right? However, in the world of applets, there were two important things. The first important thing is that the bytecode language was supposed to be as narrow as possible. In order to do so, you wouldn't want to have register addresses in your bytecode. You would just have a stack language where every instruction implicitly is executed on the top of the stack. Means, on average, it's half size. So when you loaded your applet on your Netscape browser through your modem, this was very important back in the days. Today, it's not important anymore, but without these decisions, Java probably wouldn't have been as popular in the days back. It probably wouldn't have made back its money. It probably wouldn't exist anymore. So this is just the price anything that survives as long as Java will have to pay. So first of all, we have an argument, which is called the local variable array. And then basically, for example, you will have supplied the number 25 to the function add. And then we have this operand stack, which is the stack language. And then we have instructions, so how operand languages work. First, we load the value onto the stack, first thing. Then we load 42 onto the stack, 42. Then we execute plus, pop the two top values and push back the result. And then we pop the last value off the stack and return it to the person who called the method. This is, of course, not what your computer will be doing when it executes a Java program. As you all know, the JVM has a JIT compiler, which basically just looks into this representation of the method, which is stack-based, and then it compiles it to a proper executable. It optimizes things. It might not even do any of that anymore when you inline a lot of methods and come up with something much faster. If it did that, the JVM would be very, very slow, and Java used to be very slow, because in the old days of Java, before there was a JIT, the JVM would basically execute instruction after instruction and emulate the stack language, right? Also, the reason why Google didn't use that for Android, JIT compilers work very well when you run a program, you boot it up, right, and you let it run for quite a while, and then it has time to optimize it, and when it actually is up and running for a while, it will be super fast because it's optimized, right? Android, you open your phone, you open your app, you're already bored on whatever's happening on Facebook, so you close that again, and all the compilation is back to zero, right? So that's why they compile it to a different bytecode representation where this is not the case. Anyways, all these things that we just mentioned are a so-called bytecode. And in the class file API, you will be able to trigger these bytecodes and then basically add it to this attribute that is the code of the method. So just as before, we have here the code builder. We say code builder iLoad 0 from the 0 offset, right? This is the argument to the method here, 0. Then we load the number 42. Then we add the numbers, and then we return the numbers. I mentioned at the beginning, you will likely never do this in your career. You will likely never work with bytecode directly, and that's the reason why ByteBuddy, for example, has become so popular. This is nothing you can add to a project for your customers, for example, and expect the next best person to come in and change something. They will not be able to understand that. They will not necessarily know bytecode because you will have to read the specification. There's not, I mean, there's my YouTube videos on it. Other than that, there's not much material on explaining bytecode. And there's many, many more instructions than that, of course, and this is just the surface of bytecode manipulation, so it's always better to not generate bytecode directly, but I'm sure that the power users, I'm expecting, for example, the Spring framework, to generate their proxies using that directly to avoid a dependency that they currently need, right? So also, just to demonstrate why working on bytecode typically is not a good idea, all I did now is I removed the static, right? What does that mean? That means that the first argument to the method is no longer the value, it's the disreference. Meaning that what we do here, every reference to a variable in your code will have to shift by 1. So a manipulation of a method as trivial as making a method non-static is a pretty invasive change on the bytecode level, and nothing you would normally want to do. And again, this is just an example why bytecode manipulation normally is not a good idea, right? So also, if you want to do additional local variables, this will now change the beginning variable array. So in theory, you have to think about all the variables you want to assign already before you create a method, and then adjust it accordingly. This is again something that ByteBuddy, for example, would do for you transparently and allow you to change rather easily compared to this direct manipulation. In the class file API, what you would need to do is you would say code builder, allocate a local variable of type integer, then you get a resulting offset, and then you can store something and load something without going into too many details. All right, I have 15 minutes left, so I have to prioritize a bit. Yeah. Another thing that you have to be clear about when you work with bytecode and you want to do your own bytecode manipulation is that Java is a very high-level language. Java bytecode is not. If statements, while statements, for loops in Java are structured branching on the Java bytecode level, and many of you might have known that from before. Everything you get is the goto statement because it's not very man-friendly. Goto is, of course, something we avoid today. No programming language has it anymore. That is fairly modern, at least. Instead, it is, however, very machine-friendly. Machines like to go through statements because it's clear. There's no complexity to it. You just evaluate a condition, and if the condition is true, you will jump to a certain offset in your code. You can imagine if you have this list of bytecode instructions, you evaluate something, you jump to a different offset there. That's something you can execute quite performantly, and this is something also that compilers like. If you look at the JIT, it has a sea of nodes, basically identifying every segment of jumpable code, and then it merges them in a way that it thinks is optimal for execution. Right? So this is every Java program will basically compile an if statement to an if block, and then it executes the if block, and then it will have a go to the end of the else block if you execute the if block. And this is basically how it's set together, right? In the bytecode API, yeah, just jump. In the bytecode API of the class file API, I would say this is, however, solved pretty conveniently. It allows you to take the high-level constructs of Java and trigger them in form of concatenating lambda expressions. So instead of having to create your own if-else, it will have a template where it does that for you in the background, and you only have to tell the class file API where you want to jump, or what you want to do in case of if, and what you want to do in case of else. Right? So you'll be able to do it like this. However, However, you can, of course, do it manually, and this is how bytecode manipulation has worked so far in most of the Java libraries that did bytecode manipulation. You would have to create labels, and then you would have to say, this is if, check, and in the end you say, this is where I want to jump in case of else. Then I have the goto, the unconditional, and the end block, and bind the end block as well, and manipulate that. You can imagine also that if you want to manipulate bytecode, you will have to look at this kind of bytecode representation, and if you now hibernate, right, and you want to add this dirty flag somewhere and add this if statement, you will have to process what your code is meaning to represent in the worst case and bring it back to something. It's also what decompilers have to do, right? A decompiler, that's why Java decompilation is pretty difficult. If you want to have a class file and you want to translate it back to Java, the decompiler will effectively need to walk through this list of statements, find out what the if block is and what the else block is, and then obfuscate this again, will try to shuffle this around in a way that the decompilers will struggle to understand what an if statement is. And that's kind of the ongoing war, you could say, between decompilers and obfuscators to basically, because also the obfuscator will have to retain the original logic of the bytecode, but it will still try to make it hard to map back to something, right? Okay, I'll jump over stack map frames, which is a more complex topic and takes some time, and rather go into reading class files. So far we've just looked into a very basic view of how you can create class files. Again, this is something that a lot of libraries do, as I mentioned, Hibernate, Mockito. But if you want to manipulate an existing class files, you will have to read the class file first and then transfer it. Of course, the class file API can do this as well by taking a class file, an empty one, and then you parse a file, a stream of bytes, and will get a so-called class model. The class model, for example, you can now say, I want this class, I want the name of the class, and you will get a UTF-8 entry, and then you can transform it to a string and saying what the class's name is. You might think, why not use reflection? Why not use foo.class? But I already mentioned it. If you use foo.class get name, you will load the class. If foo.class will have a superclass that's not available, let's say a dependency that is optional, right? If it will have a static initializer that runs code, then this code will run. If there's a field that references a type that doesn't exist, the loading of the class will fail. You will get a verification error, right? With this API, you can do this safely. So if you, in some context, process untrusted code in your Java applications, you should consider using this API. This is actually one of the use cases I see for myself can be more broad than the people working at the back end of libraries, right? And yeah, that's one of the uses I see for myself. I expect also build tools and so forth to use more of this, like let's say the Maven Shade plugin, right, that renames a class, or other build tools like findbugs that wants to go through the class file and see if there's a pattern that it marks as suspicious, right? They will be able to hook into these APIs and read classes that way. With the class model, however, you can also do the manipulations that I mentioned. And since this is only introduced in Java 24, it is very much focused on modern language features. So it does this switch case statement on code elements. So for example, here we have a method, then we say, for every method, give me the method model. Then we check the name for the method model, and then we say, okay, for the method model, give me the code. If the method has code, meaning it's not abstract or native, give me every code element. And now we're back at the bytecode instructions, right? So we get, for example, an invoke instruction, which is a method invocation. You have a method that invokes another method. Give me the owner of this method. So if foo calls a method on instance class bar, then owner will be bar. If it accesses a field of bar, owner will be bar again. Right, so you can, and all the others, you throw a runtime exception. Of course, this is because you're not done here. There's a long, long list of bytecodes, and it's way too many of them that we can go through it, even in a dedicated talk. But this way, you can, for example, take a class. This is something you cannot do with reflection. You can take foo, and you can check what fields and what methods does it access. And if you have some, for example, you have a tool that wants to avoid that this package calls methods from this other package, right? If you wanted to write code to check that, you could go through the class file doing so, and just go through the instructions that are method and field accesses and validate that this is not happening, right? Yep. So now that we have written classes first, and now we've read classes, we can of course look into transform classes, and there again you can say class file.transform class in the class file API. And the easiest one is where you just say with, meaning that you just retain the class file as it is. Every element you will get from the class, you will pass on to the class you're writing. Once you've done this, you can of course extend. You can say, all right, I want to transform methods. Again, every method model you encounter, you will now transform. Simplest implementation, just passes it along. And then we can say, all right, for every code model that we find in these methods, again, we want to copy them as they are. But now you can start saying, all right, if we encounter a class named bar in foo, we can just change the name of it. And that's, again, how, for example, you would implement the shade plugin in Maven, right? You would walk through the code elements and through all named elements of a class file, check them, just pass them on to the transformed class unless they have a name that you want to change, right? Or if you want to replace a field access with a getter call. Then you can just transform the class and see if a field is accessed, and if you encounter a field has a getter, you will replace the field instruction with a method instruction, and yeah, that way you, in a way, can implement your own Lombok plugin if you wanted to. And that, again, that's how Lombok under the cover also works. It just not with the class file API, because it's so new, nobody really uses it. Let me check the clock. It is 47, so I'm running out of time even more. Then I'll jump through line numbers and rather go through how it, yeah, my slides, by the way, are often optimized for having other talks. Let me rather look into what this means. So the problem so far, and this is what I mentioned at the beginning, is that whenever you update your JDK, you will likely encounter that your libraries won't work. As mentioned, Mockito, if I implement Mockito today, I can support Java 25, and we actually do support Java 25 because Java 25 is already available as a early access release, right? I can download Java 25, I can run Java 25, and I can read the specification of Java 25. So I know what the class file format means, right? However, I don't know anything yet about Java 26. So if I write Mockito today and ship it to you, and you download it and you use it, and now you want to update to Java 26, I cannot transform a Java 26 class file. And if you want an intuitive version of that, let's say I wrote a Mockito version that works on Java 7, and now I ship this to you, and you run it on Java 8. Suddenly, you see a Lambda expression. What's that? I don't know, because at the time I've written Mockito for Java 7, I didn't know what a Lambda expression is. The same goes with, for example, permitted subclasses. In the old days, Mockito was creating subclasses for mocks as instead of inlining them. But if I suddenly received a sealed interface, right, for Mockito, I would try to create a subclass implementing the interface, and then the JVM just will say, no, that's not how this works, right? You're not allowed to do that. But that's impossible to anticipate. However, that's fairly rare, and that was the annoying situation we've had, right? You would have to update Mockito every time we shipped a new JDK was shipped, with all the feature changes we had, with all the breaking changes we potentially had, even though the JDK itself has not changed the class file format. Class file formats between Java 7 and Java 17 were still sort of common. We've had permitted subclasses and seal interfaces. We've had records. We've had, what else do we have? We had constant dynamic, a new bytecode constant. We've had invoke dynamic. But since Java 17, I would say the missing bits have been inserted to the degree that the changes are pretty minimal, right? And I'm waiting for value types, which I'm sure will have some implications. But in between, if value types is shipped in Java 27, you shouldn't need to update Mockito for updating Java to Java 26, right? So, but if I wrote it now in 24, the class file API for 25 will know how to process the class file for Java 25, because this is now not shipped with Mockito, it's shipped with the JDK. And by just plugging Mockito into the class file API, I leave the hard work of parsing the file and making sure it's parsed correctly by the specification to OpenJDK. When you now update to Java 26, this knowledge of how to parse Java 26 class file is shipped together with OpenJDK, and Mockito will just be able to run through the instructions that are the same instructions as Java 25. What's different is, however, that the JVM itself can assure that this is the correct way to parse a Java 26 class file. If I implement this myself, the bytecode processing, I cannot be sure. I will see Java 25, I've never seen this, I don't know what to do. I will have to fail because bytecode errors are hard errors, will crash the JVM worst case, right? Only if Java 27 now introduce value types, something new. Only then there's an actual change in the class file format. And then you will have to update Mockito to allow addressing that. The way OpenJDK wants that to happen is that you add basically a meta-inf, a multi-release class version of the class file processor to your jar, and then it will support Java 24 and Java 27, because that's the disadvantage. If I compiled everything with Java 27 now, you would have to update anyways. Like, you couldn't run this new Mockito versions on OpenJDK 24 anymore. So instead of the library forcing you, the OpenJDK forcing you to update the library, now the library would force you to update OpenJDK. Wouldn't be a great version either. So the recommended convention for bytecode processes like ByteBuddy is doing that, right? To mention that, of course, we've done bytecode manipulation before Java 24, obviously. You've used Mockito before Java 24, and the most common way of doing this was ASM. I think most of you might have heard of ASM. ASM is also being used by OpenJDK itself to generate class files. Like, for example, for Lambda expressions. Lambda expressions are nothing more than ASM-generated classes that call one method, right? That is the Lambda code. So with ASM, you would basically have a class reader and a class writer, and then you would pass visitors in the between where you could manipulate things. Pretty simple, and this is how we've done it. ByteBuddy uses ASM under the covers. It's a very good library to manipulate, but it's not state-of-the-art in the sense of how the API works. It's much more rough than the class file API, much harder to use. To me, this doesn't make much of a difference, because the people who work with bytecode manipulation normally have read up so much that they can use either library. But this is how all code is written, and it's completely unrealistic to me to rewrite ByteBuddy using the class file API. So how would I offer the service? And spoiler, I'm already integrating the class file API. It's as easy as basically saying, or before I go there. So with ASM, the nice thing is I write something with ASM in Java 24, right? ASM knows how to process the class file. But the moment you update to 25, you have to update ASM. Most of the times, ASM will just say, all right, I know Java 25 looks exactly like Java 24, so that's fine. But you will still have to do this update. This is what I mentioned, right? This is why you always have to update your libraries. But then Java 26 comes along, you again have to update ASM, and then Java 27 comes along, then you doesn't fit to update ASM anymore. Now all tools that use ASM actually have to integrate the new features that ASM offers to process these new class file properties, right? So now you have to rewrite everything to Java 27 and fix it. The nice thing, however, is other than the class file API, you don't need the companies that need tooling like, let's say, OpenTelemetry, right? How does the agent inject itself? It uses ByteBuddy, and then it should run on old apps. Otherwise, your OpenTelemetry graph would be broken, where this one important legacy app that hasn't been updated is running. So what I did, I basically implemented a bridge from the class file API to ASM and back. So I could leave all my code in peace. I had to not change a single line of code, but add new processors that basically delegate back and forth and then basically call it. So all you have to do, if you have ASM code today and you want to upgrade to the class file API, is that you substitute your class reader with a JDK class reader, and substitute your class writer with your JDK class writer, and this is all built up top of ASM, right? And then the API is identical, it's the same types even, so you can substitute it. So now you let OpenJDK parse the class file, delegate the information on the class file to ASM, have all the processing done in ASM, and then parse it back. Nice thing is also you don't have to run multi-release jars, and also again, like for complex classes of many thousand lines of code, multi-release jar is just not a good option, because you have to copy-paste the entire class and just have it duplicated, right, for each Java version. And that way, yeah, it's not only me. I think basically everybody who does bytecode processing is already jumping on the train, because it's a very easy update. And I think maybe in the future people will navigate more to using the class file API directly. But for now, I think we can expect with Java 25, most tools will adapt to this approach. And by saying that, the bytecode community is fairly small, so we talk to each other, and that's my impression at least. And also in ByteBuddy, if you use that, you can already, you can say, I want to use the class file API first, but by default, you just use ASM, and only if you encounter a JDK version that the current version of ByteBuddy doesn't know about, you will have to, or ByteBuddy will implicitly encounter a JDK version that the current version of ByteBuddy doesn't know about, you will have to, or ByteBuddy will implicitly use OpenJDK's parser, right? And we've integrated that, and with Java 25 will be the last update that will force you, likely, to update most of your libraries. At least that's true now for everybody who uses ByteBuddy, which is most bytecode manipulation libraries in the Java space. So my hope now is that once you update to Java 25 and you pull all your dependencies to the latest version, from then on, you can just run your apps on all JDKs that are coming, unless they include major changes to the class file API. So yeah, that's the hope and the intention, and I know there's a lot of details in here that you will instantly forget once you walk out of the door, but hopefully you understand why this change is very hidden but quite significant for the Java space, and that's also the only reason why Oracle introduced a so complex and so big library into the core OpenJDK API, into the Java base module, to allow libraries like mine and users of libraries like mine to avoid this constant need to update the JVM. So I think this will be very beneficial to especially enterprises, but hopefully to you. And I have 40 seconds left, so I'll just give up here and say thank you for coming, and jump over this and rather end it here. As I said, I'm Raphael. If you're interested in these things, you find me no longer on Twitter, but you find me in Blue Sky now and on my webpage. And yeah, check out ByteBuddy, documents for Jay, another thing I do. Thank you so much for coming. Have a good rest of the conference. Yeah, and if you have questions, I'll be here and around for the rest of the day. Thanks. Cheers.
'Cause I'm falling in too quickly and I can't break free. Just hold me, lover. I need your lover. Me myself ain't enough. It's like being alone in a crashing car. I need you to know how bad it hurts. Hearing the sound of my broken heart. Oh, 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 are you dreaming of me now? The way I do. Oh, 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 are you dreaming of me now? The way I do.
They don't like the lights, but it's camera time. Said take the picture, but you rolled your eyes. Now I'm mortified and still terrorized. Push me behind to get me from my better side. I wanna push you back, but that's all you want. Wanna rub me up, I'm holding back. Trying to get me framed for me in cuffs. Said I attacked you, that's just a false truth. No need to argue, and yeah, I've had enough. You follow me anywhere I try to be alone. I find you there. There's more to me. Everywhere I try to go alone, I find you there. You follow me anywhere I try to be alone, I find you there. Oh, there's more to me. Anywhere I try to be alone, I find you there. I find you there. I'm so scared to leave my house, so I cannot run free from this. Always being watched by you, and that's so inconsiderate. My privacy, does that exist? Probably haven't heard of it. Need to live a different life, cause lights and cameras are in it. Trying to find a silver lining. All I wanna do is avoid the violence. But you're here again, I'm losing it. There's no more spinning in silence. Get out my face, turn off the flash. I hate the fame, no more of that. Leave me alone, or I'll collapse. I need a break, don't feel the crack. You follow me, anywhere I try to be alone, I find you there. There's more to me, everywhere I try to go alone, I find you there. Yeah, yeah. You follow me, anywhere I try to be alone, I find you there. Oh, oh, there's more to me, but anywhere I try to be alone, I find you there. I find you there.
Can I dive deep into the darkness in your heart? Trust you more than anyone I have met before. Don't care who you are or who you want to be. I'll be here until the day that you leave me. When I'm with you, I know I'm safe inside your arms. I'll make sure that you won't ever feel lonely no more. Whatever past we have, the future we will see. I'll be here until the day that you leave me.
No more gas in the rig, can't even get it started. Nothing heard, nothing said, can't even speak about it. All my life on my head, don't wanna think about it. Feels like I'm going insane, yeah. It's a thief in the night to come and grab you. It can creep up inside you and concern you. A disease of the mind, it can control you. It's too
close for comfort. Put on your regular lights. You're in a city of wonder, ain't gon' play nice. Watch out, you might just go under. Better think twice. Your train of thought will be altered. So if you must falter, be wise. Your mind's in disturbia. It's like the darkness is the light. Disturbia. Am I scaring you? Disturbia. Ain't used to what you like. Disturbia. Fading pictures on the wall, like they're talking to me. Disconnecting on call. I gotta get out, or figure the shit out. It's too close for comfort. It's a thief in the night to come and grab you. It can creep up inside you and concern you. A disease of the mind can control you. I feel like a monster. Oh, you're in a city of wonder, ain't gon' play nice. Watch out, you might just go under. Better think twice. Your train of thought will be altered. So if you must falter, be wise. Your mind's in disturbia. It's like the darkness is the light. Disturbia. Am I scaring you? Disturbia. Ain't used to what you like. Disturbia.
won't stick. When you spit your venom, keep it shut. I hate it when you hiss and preach about your new messiah, cause your theories catch fire. I can't find your silver lining. I don't mean to judge, but when you read your speech, it's tiring. Enough is enough. I'm covering my ears like a kid. When your words mean nothing, I go la la la. I'm turning up the volume when you speak. Cause if my heart can't stop it, I find a way to block it. I go la 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 Before love is running out of time, I will count the hours. Rather be a coward when our words collide. I'm gonna drown you out before I lose my mind. I can't find your silver lining. I don't mean to judge, but when you read your speech, it's tiring. Enough is enough. I'm covering my ears like a kid. When your words mean nothing, I go la la la. I'm turning up the volume when you speak. Cause if my heart can't stop it, I find a way to block it. I go la 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 la
I swear I meant to mean the best when it ended. Even tried to bite my tongue when you started. Now you're texting all my friends, asking questions. They never even liked you in the first place. Dated a girl that I hate for the attention. She only made it 2 days, what a connection. It's like you'd do anything for my affection. You're going all about it in the worst ways. I was into you, but I'm over it now. And I was trying to be nice, but nothing's getting through, so let me spell it out. A, B, C, D, E, F, U. Hey, your mom, hey, your sister, hey, your job, hey, your phone, NASCAR, and the shit you call art. Fuck you, hey, your friends that I'll never see again. Everybody but your dog, you can all fuck up. You said you just needed space, and so I gave it. When I had nothing to say, you couldn't take it. Told everyone I'm a bitch, so I became it. Always had to put yourself above me. I was into you, but I'm over it now. And I was trying to be nice, but nothing's getting through, so let me spell it out. A, B, C, D, E, F, U. Hey, your mom, hey, your sister, hey, your job, hey, your friends, this couch, and the way your voice sounds. Fuck you, hey, your friends that I'll never see again. Everybody but your dog, you can go fuck up.
Me not working hard. Yeah, right, picture that with a Kodak. Or better yet, go to Times Square, take a picture of me with a Kodak. Turn my life from negative to positive, I just want y'all to know that. And tonight, let's enjoy life. Tonight, I'ma love you tonight. Give me everything tonight. For all we know, we might not get tomorrow. Let's do it tonight. Grab somebody sexy, tell them, hey, give me everything tonight. Give me everything tonight. Give me everything tonight. Give me everything tonight. Excuse me, I might drink a little more than I should tonight. And I might take you home with me if I could tonight. Baby, I'ma make you feel so good tonight. 'Cause you might not get tomorrow. Tonight, I'ma love you tonight. Give me everything tonight. For all we know, we might not get tomorrow. Let's do it tonight.
What they say, all the games they play, nothing is enough till they handle up. I want you tonight, I want you to stay, I want you tonight.
Grab somebody sexy, tell them, hey, give me everything tonight. Give me everything tonight. Give me everything tonight. Give me everything tonight. Excuse me, I might drink a little more than I should tonight. And I might take you home with me if I could tonight. Baby, I'ma make you feel so good tonight. 'Cause you might not get tomorrow.
Zany boss, suicide door, brand new bag. College girls give it a hand in my rags. Rockstar life, so much money it'll make you laugh. Hey, bitches say hey, you can't miss what you never had. Hey, hey, off the juice, golden got me tripping. Got the coupe, woke up, roof was missing. Ice, lemonade, my neck was tripping. Ice, lemonade, my neck was tripping. Addy boys got some 60s in my bag. Lips selling, pillow talking, I'm no rat. In my earlobe got 2 carats, VVS. Got a penthouse near Rodeo off the stress. Zany boss, suicide door, brand new bag. College girls give it a hand in my rags. Rockstar life, so much money it'll make you laugh. Hey, bitches say hey, you can't miss what you never had. Hey, hey, the juice, the coupe. Ice, lemonade, my neck was tripping. Ice, lemonade, my neck was tripping. Yeah, I'm a big dog and I walk around with no leash. I got water on me, yeah, everything on Fiji. Zany boss, suicide door, brand new bag. College girls give it a hand in my rags. Rockstar life, so much money it'll make you laugh. Hey, bitches say hey, you can't miss what you never had. Hey, hey, off the juice, golden got me tripping. Got the coupe, woke up, roof was missing. Ice, lemonade, my neck was tripping. Ice, lemonade, my neck was tripping. Addy boys got some 60s in my bag. Lips selling, pillow talking, I'm no rat. In my earlobe got 2 carats, VVS. Got a penthouse near Rodeo off the stress. Zany boss, suicide door, brand new bag. College girls give it a hand in my rags. Rockstar life, so much money it'll make you laugh. Hey, bitches say hey, you can't miss what you never had. Hey, hey, the juice, the coupe. Ice, lemonade, my neck was tripping. Ice, lemonade, my neck was tripping.
Baby, can't you see I'm calling? A guy like you should wear warning. It's dangerous, I'm falling.
Хайде, най-накрая хората се събраха. Аз тук махам, не ме чуват. Anyway, switch to English. So, it was like a long break. Did you enjoy the banana? Banana, like minion, like banana? Yes, lovely. Really great. Once again, the guys in that door, please don't stand there. There's still some places over here. Yes. Yeah, he is like that guy which shows the hand. There's still places there. Anyway, to introduce this talk, as you know, I usually do sharp introductions to the speakers. Yesterday, I even talked some Polish and got a lot of Twitter messages then. How can I speak Polish? Yes, and you know that Milan actually is also living in Poland. And he was saying, okay, what I'm gonna say to him now? What Polish word would I say that only he understands? With a lot of shush and so on and so on. But actually, I didn't sleep this night. I was thinking, how many Polish words else do I know? But actually, it's not about the Polish words. It's all about the stars that get together. You see, there are moments when all the stars on the sky stand like this. We got an awesome speaker. We got not only just an awesome speaker, but a speaker who was at the very first jPrime. Who was there, once again, at the first jPrime? Yes, not very many people, but you were there, so you saw him there. He actually came to support us for that first jPrime, and we are very, very happy that he is here, and this is another star for him. Once again, we have keyword Java. This is one more star for him. As I just understood, there will be live coding, which is 5 stars above for him. And of course, there is the AI, which is like tons of stars, because this is the buzzword. And once again, Milan will help us understand when are we going to lose our jobs. Milan,
Hope not.
yes, Milan is really awesome friend of us. We are so much happy when he is here. So please warm welcome our great friend Milan.
Thanks, man. That's it. All right, thank you very much. Thanks, Dimitri. Let me get up here so you can see me better. Not that I'm, pretty or something. All right, thank you. I didn't expect so many people, so it's amazing to see you all here. And before so after this introduction, I don't know what to say about myself. I guess I'm going to use a minute in a second. But before we start, just a little survey so I can kind of adjust the levels. Hey, raise your hand if you've done anything, any AI communication, anything with AI from a code. Okay, great. So keep your hands up if that was more than calling OpenAI API. Okay, so you folks are in the wrong room, because you already know everything I'm going to be talking about today. I don't know if you noticed, but the talk has like a little subtitle, beginner. So yes, we will talk about very, very basic stuff. So don't expect things to get overly complicated. First of all, because I'm not the machine learning, AI, whatever expert you used to on LinkedIn, even though I spent about 30 years working in software industry, working on all kinds of software for banks, insurances, telcos, you name it. But AI is relatively new to me as well, as it is probably for most of you. And when I say AI, let's be clear what we're talking about, because now, everyone has different ideas. So no, we're not building Terminators here. Calm down. Super intelligence is somewhere else. No, we're not doing general intelligence. I mean, some people do claim we have it. I haven't seen it yet. What we're talking about is artificial narrow intelligence, meaning software programs being able to do some smart things, essentially, and not being able to figure out that a hand has 5 fingers. So that's the level of like artificial intelligence we're talking here in this talk today. And then a little explanation of the why. So when I started dealing with AI and the whole hype, I was like, okay, I'm a Java developer. I've been doing this for many, many years, and I need to understand what's behind that. Calling a ChatGPT or OpenAI APIs, it's calling an API. I mean, like, let's face it, it's an API. Whether there is a super intelligent AI behind it or something, dumb, it's calling an API. It's not, you don't really understand what happens behind the scenes. I need to understand what happens behind the scenes. Do I need to call an API? Can I run that thing locally and interact with it? So that was my motivation, to try to understand, okay, all this AI thing, what can I do with it from my Java code? And so I needed a mental model to start imagining how things are happening behind the scenes. And that's what I'm trying to give you today with this talk, and hopefully that's going to work. And as we talk about models, I want you to keep one thing in mind, namely that quote that says, all models are wrong, some are useful. Now, you may argue with that. I'll prove to you that's the case. Here is a model of the world. And that model is wrong. Now, you may not notice it immediately, but if you look carefully, you will realize that according to that model of the world, Greenland and Australia are the same size, which is wrong. So you have a completely wrong model of the world in technical terms, but it's still useful. It still tells you what's where the oceans, where you can travel, and things like that. So the fact that it's technically wrong does not prevent you from using that model in many, many circumstances. And so this is going to be the talk today. A lot of the things you'll hear will be technically wrong. So if the machine learning / data science inside you screams, that's wrong, yes, I know. Okay? I may not know what's the right one, but I know it's wrong. So, we talk about AI. Every time we talk about AI, you hear about AI, what you hear is models. AI models, model this, LLMs have the word model in it. So model. What is a model? So if you start digging, the first thing is that model is that piece of something that on one side you have this data scientists and machine learning experts and all the smartest people in the world with like the most expensive infrastructure in the world training it and producing it, and they do that great work and produce something, right? On the other hand is people like us who are talking or interacting with that model. And that's called inference most of the time. There are even companies who now build dedicated hardware for inference and whatnot. So it's this like two worlds. You either on the like creating models side, or you are on the consuming, so to say, model side, which is not new thing, not a new concept in software engineering in general. And if you talk to Python developers, or not really Python developers, but people in data science field, for them that's very obvious thing. They don't even think about it. It's like, yeah, I just use throw some data and whatnot. But what is like from Java perspective? What is that model thing that was bugging me when I started digging? I was like, okay. Started learning about it, and if you talk to the data science folks, they tell you it's a function. All right, so yeah, it's a function, you get some data, and it produces some data. And it seems like it's a fairly reasonable and sufficient explanation for all the data science folks. Okay, not for me. So I start digging more, and I find some comparisons. It's like, okay, let's try to make it look like code. right? So there is this function or procedure, depending on whatever language you use or call, and then you put some input data in it, and the body, the logic of the function is somehow generated and knows what to do, and then it produces some output. But then who generates the body of that function? It doesn't fit together to me. So the more I was thinking about it, like how to map that thing to things that I already know, it occurred to me that it's actually very similar to a piece of technology that pretty much every single developer has been using, which is databases. You essentially have a database, and you query, from inference perspective, you query that database with some piece of data, and you get some results back. And if you think about ChatGPT, for example, that's precisely the same concept, except that you don't use structured language, you don't use SQL, right, or whatever the particular database language is. You use natural language, but it's the same concept. You query it, and it gives you some results back. And then the reverse, like that's the inference part, and then the training part is basically filling that data, that database with data. Kind of like, database architects who figure out like what tables and schemas and indexes and keys should be there and whatnot. And so if you are on a consumer side, you don't really care about those things. So all the things that you care about is querying that database, getting the right data, but there are a bunch of folks who need to prepare that database so it works for you. And so came to this idea as like AI as a database model, and thought like, what if I try to simulate this just so that I can understand how that works? And so here is a tiny little demo. If you want to download it later on and play with it, not that there's much to play with, but that's the URL. Let me see if that's going to work now. Demo gods. OK, so I have a Postgres database running. And as you can see here, I have no tables at this database. So let's create some. So I'll open a file here, set up. And in here, I'm just going to create a table books. And I'm going to import some data from CSV file. And I'll create this extension vector. We'll talk about that later on. So let's run this. And if I refresh, there should be. OK, I guess it didn't run. Yeah, but OK. Let's do it manually then. OK, now it should be. Yeah, here you go. So there is a table, books, and it has some data in it. How to zoom in? Here. It has some titles and whatnot. And so now, what I would normally want to do with this, close that, is query. I want to now get some information. So ideally, I want to. I have a very simple table that has some information about some books, title and description. That's the entire thing. And so what I would want to do is give me the books that are about animals, or about music, or about, I don't know, scientific achievements, or whatever. But I can't do this with the regular databases, because the only thing the database can do is match exact things. So all I can do is select something like this, and it's going to tell me, well, yeah, there is something that has the word music in it, right? But that's not all the books that have that are about music, right? So what we can do is we can use an extension to Postgres that is called text search, and allows you to do a full text search. Now, how full text search works is it has this thing called 2TS vector, and when you give it a text, it tokenizes it. Now, I'm pretty sure most of you are familiar with the concept of a tokenizer, so I'm not going to spend too much time on that. But it does some fancy tokenizing. So if I do this, you will see here that it converts the description into tokens. Right? Now, once we have the description as tokens, we can do fancy queries like this. And we can say, convert the token, the description to the token, to tokenize it, and then find we can convert the query to a token and then search for the specific token. So if I run this, you will see here that's essentially a full text search. If you've done it in the past, you can see here that it found the word piano and whatnot. So this is like much better, but it's still not what I want, right? It's still not answering the question. So next step is to optimize this. So now, instead of doing this live, we will create a table, and we will create a vector column in that table. And we will use something called embeddings in the future. You'll see that in a second. I forgot to create the previous table, I guess. Was rushing too much. Here we go, sorry. So here it is. So now to optimize this, because here, this query that I run, it does the conversion every time you execute the query. And so we now will create a table called books TS. Let's do that. And we'll just update that table so that it has the TS description in the table. So let's look at these tables again so you know what I'm talking about. Refresh. Bear with me for 1 second. I promise you will get to the Java part. And here is the tokens column, which contains the tokenized version of the description. And now when we have this, we can now go to the vector part, and we can create a table that actually will contain another field called vector, and you'll see that why is that important in a second. Okay, so we have this table books vector now, and if I select from it, from the embeddings column, you will see that it all has null values, like no values in it at all. Now, what we will try to do is we'll come up with an idea to classify text. So we'll say, if a text is about animals, we'll put in the first column a value between a 0 and 1, which represents the percentage. It's like how much this is about animals. In a second, it will be how much it is about science, and in the third, it's going to be how much it is about music. And then we can do this for pretty much all the records that we currently have. And so this is what I call a naive tokenizer. So here is, no, that's not, where is my, here it is. Nope. IntelliJ, where are you? Here you go. So this is what I call naive embedding. So it's a piece of code that basically selects all the words from the database, tokenized, right, and converts them to this quote-unquote embeddings or vectors using this naive embedding thing. Naive embedding can generate embeddings. If you look into that code, it basically has 3 maps. And it basically says if it sees the word cat, dog, lion, bear, blah, 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 it applies a certain percentage, a certain probability that this piece of text is about animals. And it does the same thing for science, and it does the same thing for music. And it's like the super naive. So it creates a vector that has the size of 3, and the 3 elements of the vector represent, have some meaning, right? And so if you now, and then, let's hide that. And then it goes through, selects all the records, all the rows in the table, and updates our vector accordingly to this naive embedding. So you will see vector update complete. And if I go back and do select again, now we have some vectors in here. So we know that this record has a 55%, this one, has a 55% chance of being about science. Like, super naive approach. So how can we make use of that? Well, we can now search. And this is a piece of code that uses the same table. And you can see it uses this TS vector to array kind of thing to convert. So we give our query a tokenizer, convert it to vectors, and then we find the vectors that are closest to our query. So this is what you will see here is you'll notice that the select doesn't have a where. We don't say, find me the records where this condition is whatever. We instead have something like order by distance. So basically, we're trying to find like the vectors that are closest to our vector. All right, I'll run this. I'll explain that on the slides in a second. I'll run this, and then you will see that it returns some books that are relevant to our query, and our query is somewhere here. I want to learn to play a song on a piano. This is what we ask. It converts it to vectors and then finds the nearest vectors and returns us the nearest vectors, and this is what we got. Now, what this means conceptually is that we are still in the three-dimensional space. We have three. The vector size is 3, so we for every piece for every record in the database, we can draw a vector in a three-dimensional space. Now our query comes in, so we tokenize the query, we convert it to a vector, and here is our query vector. Now what we can do is find what's called the nearest neighbors or similar vectors. Now, this is one way to do it. It's called Euclidean distance, which is basically the straight line between the edges. And you can this way find vectors which are close. There are other ways to do it. For example, here is an article that can tell you more about Euclidean distance, or you can do a dot product, which basically also takes the angle, or you can do a cosine similarity, which only takes the angle. If you want to dive deep into math and linear algebra and all that things, like there's plenty of resources out there to navigate. But essentially, what you're trying to do is you're trying to find the vectors who are closest to you, because that's the likelihood. Now, three-dimensional space is hardly enough. Like imagine that you want to classify by a lot more. Like what you would do, you can go 500, and then you assign a meaning to each value on that vector. It's like not a task that as a human you can and would want to do. But what you can do is you can just say, I have an n-dimensional vector. And that's n can be several hundred, it could be 1,000, it doesn't matter. And now, if you have lots and lots of data that you know that this piece of data is somehow similar to this piece of data, you can run a training algorithm on top of that data that assigns values to those places. And those are called weights, by the way. So now you create something that knows how to map a text, or it doesn't have to be a text, it could be a sound, it could be an image, it could be anything, to vectors. Right? You need a lot of data to train a model, but once you have it, it can do it for you. And this is what's called an embedding model. And embedding models are the simplest types of models they exist. That's their job. They get some unstructured data and they convert it into vectors. That's all the things they do. And now, okay, now you know, you don't know what all the models are, but you know there is an embedding model. How is that thing distributed? How is that thing useful, right? Well, in lots of different ways, as it turns out. So for any model, actually, that's true. So there's tons of different ways to persist that and distribute it. And one that is getting, I guess, more popular recently is the ONNX one, the Open Neural Network Exchange, because it kind of pretends to be a standard. But by the time I'm saying this, it may be another one. And you will see the popular Python frameworks have their own, like PyTorch and TensorFlow. Goof is another one that's very popular because of Llama. So there are plenty of ways to distribute those models. And so what a model is essentially this data, this bunch of numbers, lots of numbers, we're talking about gigabytes, as well as the framework that knows how to deal with those numbers. And these frameworks are also different. So if you get a model on TensorFlow, probably not going to work with PyTorch and vice versa. So yeah. But in the Java world, turns out, there is a library. Hey, there's a library for that. And the library is called LangChain4j. And one interesting thing LangChain4j does, among other interesting things it does, is that it provides some models as jar files for you. So there is this embedding model called all-mini LM L6v2. It's a model, it's one of the many embedding models that the only thing it can do is get a piece of text and convert it to embeddings. And it's provided in this LangChain4j embeddings all blah, blah, blah jar file, right? And so all you got to do is put that jar file on the class path or in your Maven, whatever, Gradle thing, and then you can use it straight from your Java code as a class. Now, behind the scenes, that uses LangChain4j, which behind the scene uses the ONNX runtime environment, which is the only thing that understands what ONNX model is, right? But all that is abstracted for you. All you need to do is, just grab the model and run it. And so I'll show you how that actually works. So let me hide this. Actually hide it like this. And first of all, I think I need to, where is my, that's not what I want. That's what I want. I want to create another table here before I forgot. So I'm going to create this table of book embeddings. And as you can see again here, embeddings are, the embeddings column is empty. And now I can show you, not this one, this one. How to do model embeddings. So it's the same situation as before, except, what happened? Whew. Magic. Okay. It's the same code essentially. The only difference is now we have model embeddings instead of my dummy, naive embeddings. And if you look at the code here, it says return all mini LV blah blah blah. And if you look at the import statements, it comes from lang from J blah blah blah. So that's all I had to do as from Java, is just grab that model, right, and use it. And because it is an embedding model, what I can do with that model is call .embed. So they even prepared the right methods. So later on, you will see using an LLM, and the LLM will have a method chat. right? So they kind of prepared this stuff so you can interact with the model the way you are expected to interact with the model. So if I want to create the embeddings now, I'm just going to run that code the same way I did before. And it's going to take a little while. But meanwhile, we can go back to here and select from the embeddings table. And now what you can see here is we have tons of numbers. All right, I think this embedding model, I think, is the size of 300 something or 600, the vector size. Not quite sure. I will be able to see that later on with the next example. But there are also embedding models that are much larger. Like you can have an embedding model that has like 2,000 or 4,000. The thing is, the larger is your model, the larger is the vector size, the more precise is the model, the more memory you need, right? So, okay, so this is the part where you create the embeddings. Now is the part where you search, which is what is called a semantic search. So now we're doing the same thing, except on a different table, on the one with the embeddings created by the model. And we're doing the very same thing. We do embeddings, the distance between the value in the embeddings in our query. And this here is the L2, the equivalent, I can't never pronounce that word, the distance. There are like different ways to do that. If you do the equal instead of the dash in the middle, I think that's L1 or something. You have to check the docs exactly what the spec is. But basically, this is like the most common used version for distance. So this calculates the distance between the vector in the database and the vector that is created from your query. Right? And so we'll run that code here and see what it will find. And it will see that it finds different things that it found before. Like, for example, it will find Chopin, the man and his music. It has music with the brain in mind. I think he did or like choral experience. As you can see, Postgres even has provided pgvector, which is a sort of vector store, and this is partially what we're using here. If you want to do this on a very, very, very large scale, you need a proper vector database, and one such is Pinecone. So, well, am I already at, let me, yeah. So, in this case, LangChain for J allows you to do part of their, like a common API to talk to vector stores. So here is an embedding store that connects to Pinecone through some, you need an API key, and you need to tell which region it works. And then it does the same thing. It selects title and description from books. And then it goes and creates the embeddings in batches of 500, because this is now doing it online. So let me find that. Make sure this works, as I'm not sure which. Okay. So as you can see here, I only have one index. And if I run the code now, it should create an index, connect and upload all the. See here, I only have one index. And if I run the code now, it should create an index, connect and upload all the vectors in the vector database. In batches. Yes, that was expected. And I'll explain to you why it happens after it works okay the next time. Or it doesn't. Let me see. Well, it created the index, so I'm clearly authenticated. And let me open it. Yeah, records count. Okay, so I'll explain to you why it happens after it works the third time. Here it goes. There is a bug in LangChain for J because what happens is when you create an index on Pinecone, it's asynchronous. So when the call returns, it tells you OK, but the index is not created. It takes a little while to create the index. The LangChain, however, tries to insert immediately after that, and this is where you get the unauthenticated message because the index is not there. So you have to wait a little bit for the index to be created before you can add stuff to it. So now, here is this, and as you can see, we already, in this index, I have like 1,000 vectors. You can see here like what is the text segment that was embedded in the ID, and you can see the actual vector here. And so you can use that now with billions and billions of vectors to search, which is what I'm going to show you next. Is basically the same thing. We have I want to learn to play a song on a piano query, and it uses embedding search result here in query embeddings, and it gets the max results of 5. So if I run this, it's gonna now not query my Postgres database, but it's gonna query the Pinecone index, and it's gonna give me the results now from there. So not this one. I'm lost on my own presentation. Yeah. So this was the embedding store. So we were talking all the time about embedding, converting text and stuff to numbers, which is boring because you've probably been using things like ChatGPT and Midjourney and whatnot. And I was like, I want to use those things. Well, those things are more or less the same, except they require more and more resources. Now, so the difference between, like, conceptually, remember, all models are wrong, some are useful. Conceptually, what happens with this generator models is the same thing that happens with embeddings. They get similar things, and then they predict what is the next similar thing. Like once they predict the next similar thing, they get the whole thing and predicts the next similar thing, and then predict the next similar thing. And this is like conceptually how large language models work when you interact with them. They just give you one token at a time. All right, and of course, technically that's more complicated. You're probably going to have to go and read the paper about attention is all you need and about transformers and whatnot. But conceptually it's the same thing. It just generates you the next token up until reasoning models, which is completely different story. But if you want to run them, if you want to use a model like this, a generative AI, you basically have two options. You either call an API that the model is hosted somewhere on some infrastructure that can handle it, right? And you just interact through an API, or you run it on your local machine. Now, obviously, you need to have a machine that can run it. And this is one way to do it with Java through another tool called JLlama. Now, JLlama is a new kit on the block that can run a large language model. It uses the newest Java Vector API behind the hood, so it only works with the latest version of Java, and you have to provide some enable things for it to work, but it works. It's super slow, but it works. So let me, sorry, that was funny, I guess, okay. The reason I'm saying it's super slow is because it's terrible for when you do live coding. and on stage, right? So this is the entire code. Like that's the whole thing. You basically say JLlama chat model builder. You give it which model you want to run. This is Tiny Llama, one of the smallest LLMs that you can run, right? And you can say build, and then you can say model generate, and it gets you the response. And that's it. That's the entire thing. The only bad thing about it is when I click that button, yeah, I now need to find the configuration where it actually has the settings for the vector API. The only bad thing about it is that when I run this code, I need to figure out what to do on the stage for a minute, right? Because it takes about a minute for that thing to spin up a model and then interact with that model and then get the result back. So as you can see here, it tells you that it's allocating memory, 27 prompt tokens. So that thing I want to learn to play a song on a piano resulted in 27 tokens. That's essentially what it tells you. And then it's allocating more memory. And thanks God I have a CPU with a GPU that can do this, because on my previous Mac, which had an Intel processor, that doesn't work at all. Like you can't even run it. On this one you can. As I said, the downside is figure out what to talk about for a minute before it results in something. Here you go. But finally, I'm talking to an LLM. And an LLM tells me, I asked the LLM that I told the LLM I want to learn to play a song on a piano, and it tells me to learn to play blah, 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 some answer, whatever. Now, obviously, that's not the most efficient way to do this. Another way to do this on a local machine is to use something called Llama. Now, Llama, you can think of Llama as a Docker for models, right? And Llama has its own repository. You can do stuff with Llama, like where is my so Llama list, and you will see what models I have installed on this machine. So it's Cogito, Gamma 3, Qwen, Llama 3.2, and DeepSeek Coder, right? And if I do Llama PS, you can see no model is currently running on my machine, right? But I'm going to go back now to my code. And here is the entire code as well. Again, using LangChain for J. So it's the same query, and I'm saying I want to use Llama 3.2. And this is going to be a Llama model running on localhost, blah, blah, blah. Because I already have, you can see here, I already have a Llama running on my machine. It's just that when you don't need a model, it doesn't keep it in the memory. It loads it and when you need it. All right. So when I run this code now, here, this is going to take a lot less than a minute. It's still not the fastest thing on earth, right? But as you can see, it runs a lot faster, and it gives me some result. It tells me like how to learn to play a piano and whatnot. Now, if I do this Llama PS again, you will see that now I have Llama 3.2 loaded in memory. It's going to stay there for a while, and then if I don't use it, it's going to shut it down. So that is another way to do to talk to LLMs with Llama, right? Now, what we've been doing so far is you saw two things. One was we put stuff in database, do some embedding, search stuff, and get the stuff. Right? The other is we're talking with an LLM. LLM produces some nice response, but these two are like separate worlds. Like, what if you want to use both. So I want the LLM to be able to tell me what books we have in the database, right? Well, first of all, let's consider something here that's called a service. That's something that provides, as I said, like LangChain4j gives you a lot of abstractions that are that makes things very easier. One of those abstractions is a service, and basically that's the same thing. So here I say I have a chat language model, the same thing. It's a llama, except this it uses Llama 3.2 model, and I also have an AI service which I called librarian. Right, and it uses that particular chat language model, that one that I created here. And now instead of talking to the model directly, I'm talking to that librarian. Now, why this abstraction? Because when you have and this is the librarian as defined here. So when you have this abstraction, what you can do is you can provide, one of the things you can do is you can provide system messages. So you can send now instructions to your LLM how to behave. And in this particular case, my instruction is your helpful librarian, respond with the names of the books that we have, blah, blah, blah. So let me run this. No, it still runs the previous one. Sorry, current file. This one. So this is going to call the LLM. And it's going to follow the instruction, and as I asked, it's going to give me the 3 books that it knows of, except none of these books is in our database, because this is all the model knows from its training, right? So it figures out, like, if I run this again, it's probably come up and hallucinate 3 more books, right? So it has no idea about the actual books that we have in our database. So we can fix that using an approach that is known as RAG, or Retrieval Augmented Generation. So essentially what we do here is we combine the 2 approaches. We get a query that asks about something, we tokenize it, we vectorize it, and we go and ask the database what is the relevant information for that query. Now, we get from the vector database the relevant information, and then we go and talk to the LLM and say, hey, LLM, give me answer to that question. Oh, and by the way, here is the context for you that we just grabbed from the database. That approach is known as RAG, Retrieval Augmented Generation, and it's somewhat cumbersome to do. It's not rocket science, but it's step-by-step repeatable. So LangChain4j created a very nice way of doing this. So first of all, it's here is again using a model. So this time I'm going to use Gamma 3 through Ollama. Right. Then I'm going to say I'm also going to be using an embedding store or vector database. I'm going to be using Pinecone for this particular one. And then I have this thing called content retriever. Now, as you can see, content retrieval has embedding store. That's going to be using my Pinecone store, and embedding model. And that is the thing that actually gets the results from the database. And here I say I want max 5 results. Right? Now I have something that's called content injector. And then content injector basically says which part of the metadata I want to get. And in this particular case, I'm interested in getting the title. And finally, I have this retrieval augmenter who basically says where to retrieve it from and how to augment it. And so use the content retriever and the content injector to kind of make that query. And that's it. The final thing is the librarian that you saw before, except here it has a little more precise system message, like how to behave. And so if I run this now, you'll see that is exactly what's happening. It goes, grabs the relevant information from the vector databases, and the LLM now responds with, we have Newsies, we have music with the brain in mind. You saw that those books before, and Chopin, the man and his music. So now the LLM responds with an information that's accurate. That is the actual books that we have in our database, right? Because we were able to pass it, to pass that information to it by retrieving the data from the vector database first, and then pass it to it. So there are tons of other things you can do with LangChain4j. By the way, yesterday they released 1.0, I believe, version. If you want to play with inference side of AI with Java, it's probably a good thing to look at. And it can use behind the scenes lots of other things like Onyx runtime that can run models, but also JLlama, Llama, tons of other things. It also has convenient abstractions for other things like image models or document loaders. So if you want, for example, to scan a folder of PDFs and convert them into embeddings and things like that, you can do this a lot more conveniently with LangChain4j. And it has a memory. And now the memory concept is if you chat with ChatGPT and use any of those tools, you know how it remembers things, right? So if you say my name is, and 3 messages later you say what's my name, it's going to respond your name is, right? Well, that's not the language model. The language model does not remember anything. So ChatGPT is basically 2 parts. It's chat and GPT. And GPT is the model, and it doesn't remember anything. Chat is the application that allows you to talk to the model, and that application is what remembers things, right? And to remember things, you need this concept of a memory. So essentially, with every next request to the LLM, you send the entire history of the conversation, right? And so now that is limited to what is known as context window, because there is only so much data that you can send to the LLM and whatnot. But anyway, the reason I'm telling you all this is because LangChain4j allows you to also use things like that. And last but not least is tooling. Now, before MCP servers, which are a relatively new thing that came up, started by Anthropic last year, and now it's the de facto standard for tooling, there was a way for each LLM to be provided with information about a tool. So basically, and even you can try this on your own. You can go to ChatGPT and ask it a math question. And what you will see in the bottom right, it's going to tell you that this was calculated by a Python script, and there is a place where you can click and actually see the Python script it generated to calculate, to solve the math equation, right? So this is how LLMs solve things that they don't know how to solve otherwise, by tools. So you have that in LangChain4j as well. So that's pretty much it. I was trying to build up a mental model of those concepts. So you're not going to build the Terminator. You're not going to, solve the biggest enterprise AI problems getting out of this room. But hopefully gave you an idea of what is what, where to look. As I said, the talk is very, very basic. Hope it was useful. If you want to dive deeper into the AI world from training side and in Java, you may want to have a look at Deep Java Library. These folks are much more deeper into the topic, but that requires a lot of math. Warn you. Feel warned. And that's it. Thanks for having me. Thank you. I hope it was useful. Thank you.
Ain't no sign of healing, so I get myself another round. I can't take the silence anymore, you gotta set me It's so cold when you leave me alone in the dark. It's freezing inside of my heart. Baby, I can wait forever. Oh, can't you see it's now or never? So come save me. Just come save me. Baby, I can wait forever. No, I can't wait. No, I can't wait.
In the day, in the night, say it right, say it all. You either got it or you don't. You either stand or you fall. When your will is broken, when it slips from your head, when there's no time for joking, there's a hole in the plan. Oh, you don't mean nothing at all to me. No, you don't mean nothing at all to me. But you got what it takes to set me free. Oh, you could mean everything to me. I can't say that I'm not lost and at fault. I can't say that I don't love the light and the dark. I can't say know that I am alive and all of what I feel I can show. You tonight, you tonight. Oh, you don't mean nothing at all to me. No, you don't mean nothing at all to me. But you got what it takes to set me free. Oh, you could mean everything to me. Oh, you don't mean nothing at all to me. You don't mean nothing at all to me. No, you don't mean nothing at all to me. Don't be fooled by the rocks that I got. I'm still. Demons rolling, I'm feeling for the time. That's just me. Nothing phony, don't hate on me. What you get is what you see. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Broken this business, I've grown up so much. I'm in control and loving it. Rumors got me laughing, kid. Love my life in my public. Put God first and can't forget to stay real. To me, it's like right there. Fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from. Don't be fooled by the rocks that I got. I'm still Jenny from the block. Used to have a little, now I have a lot. No matter where I go, I know where I came from.
We stayed up all night, talking to each other, whispers under covers. You told me your life wasn't always easy. I said I know the feeling. I told you all about the scar on my shoulder, and you told me you were terrified of getting older. We stayed up all night, the first night of a million more. 'Cause I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me. We're gonna love you inside out. We love to, we cried, made fun of each other, lost in one another. You held me so tight, and it felt like I was home, just the two of us alone. You said you don't wanna end up like your parents. They said, don't you worry, I'm not gonna let us. We stayed up all night, the first night of a million more. 'Cause I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside out. I'm gonna love you inside out. I'm gonna love you inside out. Nothing you say is gonna scare me now. Still gonna love you inside. What do you say, babe? 'Cause I wanna know.
Okay. This is the final single talk of this conference, or better say, solo talk of this conference. After that, we're going to have a panel, and the speakers are getting ready with a beer for the panel. Yeah, so it's going to be a very, very productive panel. But before that, I am really, really happy that on this stage again comes the representative of the best city of the universe. Yes, it is called Plovdiv. He came all, who's from Plovdiv? Applause. The best city of the universe, yay. Yes, exactly. And I'm really happy that Stefan is not only like doing great talks. He started from jProfessionals as well. Second year in jPrime, so we make good speakers, as you know. But Stefan is also doing his academy, Hackerche. Yes?
Yeah.
Yes, he's teaching the new generation of next jPrimers. Yes, so he is the one who is investing in our future. So, Stefan, warm welcome. We're happy to have you here.
Okay.
Thank you. Warm welcome.
Hey guys. So just to confirm. Okay, so let's begin. So couple of events ago, I just mentioned that I'm not going to speak about Kafka anymore. So now the title is related to Kafka. Again. But we're going to speak not only about the Kafka, we are going to speak about the alternatives of Kafka. So why we want to do that? There is many reasons that the Kafka is not good fit. So we need to think when we use it. Don't just use it because nobody cares that it's Kafka or something else. You just need to do the job. And to do the job right, that is the most important things. What the right mean, we're going to discuss during the talk. So let's first introduce myself. So you can scan the QR code and go to LinkedIn, connect with me. Currently, I'm working as a software architect in Trading 212. So let's begin with the real part of the talk. What we are going to speak about. The first thing we are going to speak about is the message technologies, the role of them in our distributed world. Everybody of us are doing microservices and things like that, so we need to know how to use them. I hope we will see. And after that, we are going to speak about Kafka. First of all, we need to know what the Kafka is, how it's working, where are the problems in the Kafka, and right after that, we are going to speak about alternatives. Please raise your hand if you're using Kafka in production. Okay, how many of you guys are facing production problems with Kafka? Okay. How many of you guys solved that production problems? Oh, okay, it sounds good. So we're going to speak about them. We are going to understand why there are some problems and how we are going to mitigate them. Right after that, we are going to speak about the alternatives. So we are going to discuss different technologies that are doing almost the same job with a different way. We are going to speak about the Aaron, Chronicle Q, NATS, and many more, or at least some of them. We are going to deep dive in 2 of those technologies and try to understand how they are different with Kafka, and probably it's good to use them in some cases. After that, we are going to deep dive in their technologies, their architectures, and try to think about their performance. And at the end, we are going to try to do some kind of real-world examples, benchmarks, use cases, and see their differences. And after that, probably some kind of decision framework about the technologies and try to map them with our use cases. So let's start. When there is some messaging, we need to care about durability, throughput, availability, latency. Those are the most important things when we start working with the messaging. So why we need to care about them? So latency, everybody wants to get data fast. Doesn't really matter if you're working in the trading industry or banking industry or every kind of industry, the data should be coming fast, or at least as fast as possible. Most of us are working in the big data world, so the throughput is very important. Let's imagine that you're working with many different exchanges and you need to get that data. All of those trading market data need to come to your service. So there is a lot of megabytes per second that you need to process. So we really care about the throughput. Durability probably really depends on the use case. So the main question that we are going to ask today is, do we really care if we store that data, or the data is going to be old 1 second right after we receive that data? Do we care about the data that it's not useful for us? Depends. And after that, we are going to talk about the scalability. Every system should be able to scale somehow. We are going to see. Use case about the messaging. So there is many use cases. Event streaming, real-time analytics. We want to do LM almost real-time. We want to know if our customer is doing something really stupid or abuse our system close to real-time in order to react and prevent some bad things. So everything should be almost real-time. We have microservices. Almost everybody in the world have microservices at that moment, so we want to communicate somehow. Right after that, some sensors, who cares? Finance trading. So as I mentioned at the beginning, when you're working with the finance industry, the data is too much. And we need to process that data. And after that, we are going to discuss how the Kafka or other technologies could help us to process the data faster. Work aggregation. How many of you guys using Kafka for processing works in production? Or is there a buffer between the Kafka and ALK stack? Okay, only 2 hands. Guys, please raise your hand if you know. Okay. If you don't know, don't raise your hand. What we are going to compare today? Today we have 3 demos. The first one is using Kafka. The second one is used technology called Aaron. And the third one is used something called NATS. We are going to compare them. What we have in the one side, we have some kind of exchange. We have a WebSocket server that is the main responsibility to take the data from the exchange, parse it in the format that matters for us, and push that data to some other service. The next service on the chain is the service that the main point of using it is just to check the latency. How long it takes to process that data? Okay, so that is the main things that we are going to discuss today and the main demo that we are going to see in a couple of slides. But before we move into the demo, we need to understand how the Kafka is working in order to know how to compare it with everything else. So we have topics and we have partitions. The topics is something that stores the data. It's some kind of name with many different sections. Every section of that topic is called partition. And when we send the data with key or without the key, we just provide the information how that data is going to be sent to the particular partition. And in every partition, the data is ordered. Basically, I mean, if you send the data with the same key, it's going to be in the same partition. Okay. There is something really important. If you have two applications sending data with the same key, which application is going to win when you're sending the data? Nobody knows. There is no way how you can prevent that. Basically, who first reached the broker. After that, we are going to speak about replications. So in Kafka, you can replicate your data between many different brokers in order to have durability. After that, what happens when you send the data? Basically, sending the data means reaching brokers, reaching partitions, and that's it. So we do some kind of load balancing of the data. Okay, let's move. How the message looks like in Kafka? So in Kafka, almost everything is binary. So the key is binary, the value is binary. You can compress the data. You can use Snappy, LZ4, or something like that. You can use JSON. You can use Avro, Protobuf. There is many different way of presenting your data in Kafka. Really depends on your situation. For example, if you're handling microservices, probably you're going to go with Avro and some kind of schema registry. If you want to process a big data, probably you're going to go with something else. What else there is in the message? There is a different kind of headers. So yesterday there is amazing talk about open telemetry and how you trace the data. So if you want to trace data with Kafka, basically you need to provide some kind of headers that can trace your message to all services. Also, in every Kafka message, there is a partitioning offset. So we need to track where we are. And when we're persisting the data to the Kafka, we basically mark where the offset is. And some kind of timestamp. There is two ways how to provide that timestamp. The first one is producer to add the timestamp to the message, and the second one is to broker to add the timestamp. It really depends on the use case. What else? We have a consumer groups. We can divide the partitions per consumers, and every consumer could pick one or more partitions. So, and basically that is the way how we distribute the data. As you can see here, we're basically scaling based on the partitions. Let's imagine that there is a limit of partitions. How many of you are using MSK in AWS? AWS, MSK? Okay, only 1, 2. Okay, do you know that there is a limit of number of partitions? So you cannot go up of that limit. If you go up of that limit, basically your application is not gonna work. So you're not going to send the messages, everything is crashed, and there is a downtime. So we are kind of limit based on that. Let's move. When we're speaking about the messaging system, something really important is the delivery. So if there is any kind of delivery, the first one is no delivery, no guarantee, nothing else. Why? Because we are sending a message, and when we consume the message, we are marking the destination. We just send that message to somebody else to do some kind of work. But in the same way, asynchronous, we are sending the offset as well. So we really don't know that if the message is processed or not. We can lose the data. We can do some kind of bad things if you're working in the finance industry. So there is no guarantee. The next one is as most ones. What does that really mean? We first said, okay, that message is already processed, and right after that we process the message. So what could happen here? We can just lose the data, because we already marked the data that it should be processed, but it's not. Probably, we will see. At least once, there is a risk of duplications, but we can implement some kind of duplication in our end. For example, we can use Kafka streams and do some kind of duplication in our end. It's amazing, it's working, it's fast. So there is a way how you can handle that. If you want to get exactly ones, we can use the Kafka transactions, Kafka streams with the exactly one semantic. There is a many different way how we can get that with Kafka as well. Let's move. How the Kafka is working. When you send a message to the Kafka, there is a couple of steps that happen. The first one, Kafka receives the message, serialize the data, write data to the disk, probably replicate the data if that is required or not, and return back a knowledge based on the producer. Probably the producer don't care if the data is delivered or not, or could care if the reader at least accept the data, or if all the replicas that are configured accept the data. So when you send the message, you just basically mean persist the message to the disk, because the Kafka is walk system. Put everything inside the walk. Okay, what happens when we start consuming the data? We are not consuming the data from the producer, but we are consuming the data from the Kafka. Basically, this means that we are reading the data from the disk. And when the request from consumer comes to the broker, there is a couple of operations that happens. The first one is the consumer request the data from the topic. Right after that, the broker identify the consumer group, identify where is the offset, and based on that offset, find the walk file in the file system and return that data back to the consumer. This basically means that there is a couple of steps before the data goes back to the consumer. Okay, why I'm spending so much time for discussing that? Because you can see there is a couple of operations that happen behind the scenes before the data is going to the consumer. So there is a latency. And we are going to see that a little bit later. Okay. Where is the things that the Kafka is really strong? So the first one, the Kafka is really strong with using high throughput, scalable event systems. Most of us are seeing clusters with 10 and more brokers and could scale almost infinity. There is always a limit, but could scale very well. There is a persistence walk for durability. Everything that we send to the Kafka, configured correctly, it stays for some times. Could stay forever if we're using compact topics without deletion, but it stays for some times. Okay, there is a big ecosystem around the Kafka. So there are many tools that are using Kafka. There is a Kafka Connect, Kafka Streams, KSQDB, probably it's almost died, but it still exists. So there are many different technologies that are working with the Kafka ecosystem, and we can just use them. Okay, where is the limitations? So when we're using Kafka for low latency use cases, there is a milliseconds time frame between the messages consumed by the consumer. So it's not suitable for low latency systems. There is a complex setup. How many of you guys adding new Kafka brokers to your cluster? Or just create a cluster and don't care about that? How many of you guys? Somebody add a cluster? Okay, so there is many problems with that. So when you add a new cluster when you add new broker to the cluster, you need to distribute the data to that cluster. There is an additional operation that you need to do. If you do that in the time when you really don't need to do that, there is a problem, kind of. Okay, there is an overkill for low latency systems, and let's meet the alternatives. So every system has alternatives, and we need to know them before we start using the systems. So one of those alternatives, okay, so let's move to the next one. Why we need alternatives? Right after that, I'm going to discuss the alternatives. So why we need alternatives? We need because of latency, simplicity, persistence, management overkill, operation, and cost. So if there is a way how we can move Kafka away, let's just move it because the Kafka is elephant. So it's very big, it's very complex, and we need to think when we use it. So something else before we move to the alternatives, we need to understand how the protocols is working. What is the UDP? What is the TCP? What is the difference between them? In which case we can use which transport protocol? So the UDP is very fast. It's good for streaming, gaming, but it's coming with the problem that there is no consistency. There is no way for checking the errors. There is a little overhead, so it's fast, really fast. On the other hand, there is the TCP. There is to ensure that data is delivered. There is a way how you can handle the errors, retries, but at a lot of overhead. So we need to know which protocol we are using when we decide which message broker to use, or messaging system. So what is UDP multicast? So there is an easy way how you can send the data to the particular address and broadcast that data to all participants that want to listen to that. Let's say that I'm subscribing from the Taner presentations, and next time when the Taner presents something, I'm going to receive that. And all of you guys who subscribe to the Taner presentation is going to receive that. But that is coming from the UDP multicast. There is no broker in that way, and you can get the data more fast. Okay, the next thing that we need to think when we're using brokers is what is the back pressure. So there is a way how we can handle a lot of data in our systems and how we're gonna process that data without crashing everything. So we need to take the decision based on that when we decide which messaging system to use. Okay, now let's move to the alternatives. We're going to discuss a couple of them. The first one is ARN. So the ARN is high-performance UDP-based messaging system for ultra-low latency applications. Why we care about low latency applications? Let's say that the price of the particular stock is now around 100, 1,000, and something like that. In the next second, or less than that, the price could be changed. And we need to react if we're building high-frequency trading or the systems like market makers and things like that. So when there is a system that needs to respond fast, we care about the low latency. What else? We can use something called Chronicle Queue. It's basically another low latency queue messaging system that uses the memory mapped file. It's very suitable for finance industries, time series data. What else? We can use NATs. And the most interesting here, how I learned from that, for that particular technologies. One of my colleagues come to me and say, okay, you present us different technologies, you speak for Kafka, ARN, and things like that, but do you know that there is technology called NATs? I was thinking at that time, I really don't know, I just Google it, watch a couple of YouTubes, go over documentation, try it by my hand, and okay, this is awesome. There is many ways how I can use that technologies, and doing some perfect job that with Kafka, I'm not able to do it. Or at least I'm able to do it, but I need to do a lot of other things in order to achieve the same goal. So it's amazing. What else? There is the RabbitMQ as well. So with RabbitMQ, we can do traditional messaging system. Traditional, just sending a message to the queue, process the data, do the work, and just that. So it's good. If you need to implement a notification system or something like that, that's care about the order, or you want to implement the queue that have a priority or something like that, RabbitMQ is amazing. Okay, what else? Redis, it's good. So it's open source again. So yeah, it's good. About the Kafka. How the Kafka is really working. So behind the scenes, Kafka is working with the pool-based model. Basically, we pull the data from the Kafka. So when we're pulling the data from Kafka, there is a lot of configuration that we can do. We can configure our consumers for latency, for throughput. So we have that choices. So we can do that. The transport layer is TCP. If we return a couple of slides back, you can see that TCP is really slow. So yeah. Okay, scalability. Just add more brokers, but you need to handle how you're going to distribute your data in the cluster. Okay. Let's see the quick demo and see what we got with that. So I built a couple of projects. The first one with Kafka. So let's just see what we have. It's typical Spring Boot application. There is nothing special. It's just Spring Boot. So we have a client, and inside the client, we have a WebSocket. The WebSocket is connecting to one of the most famous crypto exchanges. I'm care only about the BTC-USD because I'm doing a trading, and I have a server in my home that basically do kind of trading for me. So I just care about the BTC-USD because the prices goes bigger and bigger, and I could make some money. So I really care about that. So what I did after that, I have some Micrometer and get the data. from the exchange, parse that data to some object at some kind of nano time, because I really want to track the latency. So I really care of nanoseconds, and send that data to the topic. Okay, what else I'm doing here? I just use the symbol as a key, because I want to distribute that data to the same partition in order to have a guarantee that when I'm processing them, I'm going to process them sequentially. Okay, amazing. And basically, that's my first application. Let's try to run it. Let's first confirm that my Docker is running as well. Okay, it's there. And let's run that. I hope it's going to work. We will see. Okay, the configuration is there. And as you can see, that we are producing so many messages to Kafka. Okay, amazing. Let's try to consume them. So before we move to the consuming, let's look how I'm configuring my producer. So inside my producer, I just add a couple of things. First of all, I just add ringer milliseconds to be 0, because I want to push the data as fast as possible to the broker. Okay, what else? There is a batch size, but I'm not gonna go to that batch size because I'm pushing the data as fast as possible, and I only care if only one of my brokers produce the data, get the data, because I don't care about the durability in that particular example. Okay, what I'm going to get from the dollar application. So let's look at that. First of all, let's start with the configurations. As I mentioned in the beginning, there is a way how you can configure your consumer, your producer for latency or for throughput, or between. So I'm configuring my consumer to pull the messages also when there is at least 1 byte to get the data. This basically means getting data as fast as possible. When the data is there, just get that data. And I add some kind of interval, because logging is so slow on my machine. So one of the most slow operation is just writing to the city out. Okay, let's see. Let's just run the example. I hope it's gonna work. We will see. Okay, it's there. Let's wait a couple of seconds. And now we're going to open my browser and verify the latency of that particular application and see how long it takes to process the data. So we're going to ignore the first couple of messages because I start my producer a little bit earlier and the messages are too old, but we are going to focus only to the live data. So let's move. I hope that this is the correct port. Let me see. Okay, let's zoom. Search for Kafka. Latency, refresh couple of times. Search again. Okay. This is what I'm getting at the moment. So current latency is those milliseconds. That's because the first couple of times the data is too old. If I restart the data again, or at least I'm restarting the application again, let me do that. It should be a little bit faster than that. Okay, it's running around 5 or 6 milliseconds most of the time. So it's kind of good, but we need to take care that this is running on my local machine. There is no network hops and things like that. But the still data persists to the disk. Okay, let's move. We're going to discuss something called errand. The errand could be divided in 3 main parts. The first one is errand transport. This is only the way how we are sending the data. The second part is called errand cluster. With errand cluster, you can send the data, you can have a fault tolerance, you can just distribute that data around the cluster. Everybody's taking the same data, do the same work, but only one produces the output. It's amazing. So if you need to build a crypto exchange, probably you're going to have 3 or more matching engines that are doing the same job, and only one of them to produce the output. if most of them produce the output, that's going to be a big problem, and we are going to give the money to the person that we don't want to do. So there is something else called ARN archive. That is the way how you can get the data to the disk. Right after that, there is a way how you can replay the data. For example, in every system that is working as a crypto exchange or something like that, you need to be able to process the data, because everything is like events that need to be processed again to rebuild the state. For example, if you have an order book and your system is just crashed in hops, we can process at least 1 million messages per second. Okay, we can run that everywhere. We can run that on-premise, we can run that in cloud, we can run that in Kubernetes, but it's a little bit hard to do it, or at least I don't manage to do that. It's brokerless. So when you use the ARN transport, there is no broker. You can just send the data over UDP to all participants that want to get that data and do some kind of operations. Okay, how that really works. If we need to speak about the ARN and how it's working, basically there is 3 different components. There is a client. We are building Java applications, so our Java applications are the clients. There is a media driver, and the media driver is responsible to communicate with the media. The media could be UDP, IPC, or something like that. The media driver just takes the data and try to transport that data as fast as possible to the media. Also save that data into the work buffer. Okay, let's discuss some of the things that ARN could do. So the ARN is push-based. Basically, you're pushing the data as fast as possible. It's using UDP, so it's fast. You can do that with multi-class as well. So you can have one or more application that is interesting to your data. So there is a back pressure as well. You can implement that back pressure with the flow control. For example, you are able to say to be as fast as possible, as faster consumer you have, or to be as slow as possible as the slowest consumer you have, or to be in the middle. So there is some kind of flow control that you can implement with ARN. Okay, so what else we can do? It's basically, there is some kind of limitation. There is no good technology that you can just get and put it in every place. There is always limitations. One of the limitations of the ARN, at least that I'm facing when I'm working with the ARN, is the limited scaling. So what that really means, there is no just way how to get the broker, add it, and scale. That's not going to work because there is no broker. It's brokerless. Also, with my tests, I'm able to just go around 15K messages per second, so it's kind of good. It's not designed to go with the same scale as Kafka. So the Kafka can process terabytes of data, but with ARN, we are not able to do that. Okay, let's look at the demo with the ARN. First, I need to stop the Kafka. And what we have almost the same demo. It's again a Spring Boot applications, because I want to be easy to just run it and don't think about anything else. I have a subscriber, and inside the subscriber, there is a lot of configurations. So the first one is the media driver context. I basically describe what to happen with the directory that stored my work when the application is starting. So first of all, I want to get rid of that data because it's not important for me. I don't want to store it. On shutdown, I also want to delete the data. Why I'm doing delete the data on startup and on shutdown? Because the data is old. The application could crash with out of memory and things like that. So I don't care about the data right now. Something else that is really important, that is the trading model. So if we return back to the presentation, a couple of slides ago, we see that the media driver have 3 components. And there is a way how to configure those components to be a separate threaded or to use the same thread. So if you use the separate thread, you basically got to get the better performance because the thread is only for you. Right after that, we describe a couple of different strategies, what we can do with our threads when there's no work to do. So currently we're doing busy spin idle strategy. This basically means that we're keeping the same thread busy with some kind of operations and don't give that thread to somebody else. And the processor is only for us. Amazing. What else? With that particular example, I'm starting the media driver, which is embedded. So I can start another process, probably in C++, that's going to be a little bit faster than that. But with my current example, I'm starting that my media driver is embedded working in my Java process. What else? I'm connecting to that. I'm just at a subscriber, basically describe which is the channel, which is the stream ID, and right after that, I'm just pushing the data to it. Let's see where is that, probably somewhere below. Okay, bookmap. This is the subscriber. Let's see the WebSocket one, because I'm sending the data on the WebSocket. It's here. Let me check. Okay, send. And basically, I'm sending the data. So just simple like that. Get the data, add it as a string, or use some kind of protocol as a simple binary encoding to send that data over ARM. Okay, let's run that example and see what happens. Okay, I hope it's going to subscribe to Binance. We are already publishing some book updates. Let's move to the subscriber one. Let's run application and see what happens. As you can see here, we're processing data much faster. It's less than 1 millisecond. And please take care that this is running on my machine. If you want to get faster, we can run on other big machines. We can go with a different process because this is currently running as embedded mode. Let's try to see the data inside the browser, just to confirm the results. Probably the port is the wrong one. Oh, okay. We are not able to do that at the moment. But as you can see here, it's pretty fast. Okay, let's move. What else we are going to discuss? We are going to discuss about nuts. First time when I heard that here, it's pretty fast. Okay, let's move. What else we are going to discuss? We are going to discuss about nuts. First time when I heard that is, okay, probably it's not gonna be used by all of my cases, but when I deep dive in that, it's amazing. One of the things that we're going to discuss is about the way of communicate. How many of you are trying to do request reply over Kafka? Somebody? Request reply over Kafka? Okay, last week I did something like that. It's pretty terrible. So we can do that with nuts. What the nuts can give us? Basically, they managed to divide that in two different projects. The first one is called Core Nuts. It's basically just a messaging system. It's not like Kafka, because there is no partitions, there is no topics, there is a subject. We're going to discuss about subjects a little bit later, but there is just a subject. And there is another project called Jetstream that adds durability. So if you care about durability, you can use the Jetstream. If you don't care about durability, you just want the messaging getting to your data and basically storing for some times inside the core nuts, you can just use the core nuts. So you have that flexibility. In Kafka, you don't. But here, you have. Okay, the back pressure. So the nuts support two kind of things. Support the pull-based and push-based. So you can decide which of those to use. What else? How the nuts scaling? Basically, just get and add new cluster, and it's gonna scale. Okay, why? Why we need that? Do we need to replace our Kafka with something like that? Probably depends on the use case. So let's see what we can do with NATS. With NATS, we can just do a pub subscribe. We can subscribe to the stream. We can get the data. We can process the data. Nothing special here. We can do request reply. So there is a way how we can say that when you're sending some kind of data, for example, you want to send the email, but when the email is get back, to persist that email is already sent to your customer in order to not spam your customers. So you can implement that with NATS, because when you send a request via message broker, the message broker is going to reply to you that the data is there, the request is finished, and we have one-to-one relationships, we are happy. What else we can do? So I just mentioned a couple of minutes ago that I'm going to speak about the subjects. So let's imagine that you have orders. Orders completes, orders processed, order received, and send all that message to the message broker. Right after that, there is a way how you can say, okay, I care only about that subject, or that part of the subject. For example, if you care about all, you can say orders.asterisk, and you're going to get all of the data. If you care about only the orders received, you can do that as well. If you care about all of them, you can subscribe to everything and get all of the data. You have a control to use pull, push, depends on your case. If you're using monitoring or something like that, probably you're going to use push. If you have the other service that could pull your data, probably you're going to pull. You have that flexibility. We don't have that with Kafka. And let's see the demo. Is that going to be the same simple as Kafka? Probably, we are going to see. Okay, let's move to the example. And let's first start with this WebSocket. Again, it's simple Spring application. We have a client, and almost the entire logic inside the client. So we have some kind of configs. Basically, in the configs, just describe the connection and build that for us. What we have in the client. So again, we are getting some messages. We add some metrics. We read the data, add the timestamp, convert that data to the payload, some kind of bytes, and publish that data. And here is the subject. So in the subject, I have book, ticker, also have booker get symbol, and send the payload. Okay, amazing. Let's do that. Let's run that example and see what happens. I hope that I stop all other applications. So let's run that. Probably it's gonna work. Okay. Yeah, it's working. Let's move to the consumer part. So inside the consumer part, I'm going to just go in the book ticker consumer. What I did here, I subscribed to the book ticker BTC USDT. So I hope that I'm going to get only that data. Let's see. Let's run the example. And as you can see, we are getting only that data. As also you can see that the latency is much faster than Kafka, because the NAT is optimized for low latency as well. Not low latency as Iron, but still better latency than Kafka. Okay, what else we can do? Let's just open the README, because I don't remember the curl. I'm going to add one more pair. I just want to confirm that my subject is receiving only the BTC USDT, because I don't care about others. Let's imagine that you have a WebSocket and connecting to that WebSocket, and your client only wants to receive the BTC USDT pair, and you don't care about all other pairs. But if you stream that data with Kafka, with different partitioning, you need to provide that data to all consumers that handle the WebSocket. But with NATS, you can just subscribe that, because the consumer is not really managed at the application. It's managed by the cluster. So you basically provide, I want that, and the cluster send that to you. It's not the other way around. Okay, let's see. Okay, it seems that it's subscribed. Let's see if that's gonna work. Okay, now let's scroll. Now we have 2 pairs, but on the other side, we just consume the BTC. Let's change the consumer to get all the data. Because let's say I'm caring about the Ethereum as well. The price is good, the market is good, let's see. Okay, where is that? A little bit down, let's just get rid of that. Okay, and try to restart the app. Now I hope that I'm going to get all the data. Let's see. It's not working, interesting. Did I start the correct app? Probably. Let me just restart that as well. Strange. Do I need to just add that? Let's see. Okay, now it's working. Let's try one more time to add the Ethereum pair. Okay, now we are getting both of them. Amazing. So there is a way how we can subscribe only for particular information that we want. In the Kafka, there is no way to do that. Why? Because you basically partition your data based on the key and do some kind of hash and set it to only particular partition. So you need to know in which partition your data to subscribe to that partition to get the data back. Here, we don't care about that. We just use subject-based. Okay, let's see. What else? Let's try to compare them. So Kafka, TCP. Persistence, disk-based. Back pressure, pull. We are pulling about the data. If you're slow enough, probably we're not going to get the data because there is some kind of retention. Scalability, scalability by the money. So just add a new broker and everything gonna work. Scale by the money, scale by the credit card, amazing. Aaron, the protocol, UDP multicast. You can persist the data or not persist the data. You have that flexibility. You have a flow control. There you have a windowing, but it's limited for scale. It really depends what you want to achieve. So Chronicle queue, file mapped, disk-based, producer-driven, because you send the data. There is no other way how you can handle the back pressure, at least I don't know. And it's single node. With NATs, it's still TCP. You have optional persistence, so you can enable it or disable it based on your case. You have adaptive flow control. Basically, you can say, give me the data that is 1 minute old or something like that. You have a control. In Kafka, you can just say, OK, I want that particular message on that particular position, basically using offsets. You can just add more brokers, so it's again scaled by the money. So amazing. Let's move. Key differences. TCP versus UDP. So Aaron is UDP, everything else is TCP. Persistence. One of them get the persistence, other don't. Pull versus push-based and flow control. So amazing. Use cases. Now we need to think about the use cases. So when to use those technologies? For example, when you have a market data and you care about the speed, probably the Kafka is not good. When you have a lot of walks, terabyte of walks, because you're deploying many different clusters, Kafka is good. When you have a data streaming, you want to do analytics almost real time, there is a way how you can do that with Kafka, Flink, and all the entire ecosystems. When you have a monitoring, alarms, you want to learn from your data and things like that, the Kafka is an amazing choice. When you want to get the data from your database with some kind of Debezium adapter and things like that, and stream that data to the data lake, do analysis later, Kafka, amazing. When you want to do something else, like migrating one system to another, Kafka is very good choice. But there is other ways when the Kafka is not a good choice. If you have typical request, reply, or just some kind of queue that is a really queue, not an event system, so it's not good. Okay, Aaron. When we use Aaron when there is a high frequency trading, we care less than 1 milliseconds. We use the Aaron For real-time gaming, when you want to play with somebody and it's close to real time, because if there is a 1 millisecond later, somebody can kill you in the game, so it's not good. Happens a couple of times to me at least, because I'm not a good player. Chronicle queue. We can use the chronicle queue in the finance systems when we want to stack the data. There is audit trails and things like that. Time series, we can monitor our system with chronicle queue. Deterministics, this is really important in the matching engines, because if you execute your order in the same way, you need to go in the same state. What about NUTS? You can use NUTS with the microservices. You can use NUTS with the Internet of Things. It's lightweight. It's less cheaper than Kafka if you need to compare the infrastructure. So my suggestion is to try it. Probably you're not going to adapt that as soon as possible, things like that, but it's really good. You need to know it when you decide from new project, do you need to use that? What else? Everything comes with the trade-offs. There is no single bullet that you can just get and use it. I tried that a couple of times. I failed, so please don't do that. Think about it. Discuss about the trade-offs with your colleagues. Come to your architect. Speak about your problems. Not your personal problems, your working problems only, please. Most of the architects, I don't care about the personal problems. At least I don't care about the personal problems. So I care about all the technical problems. Speak with your architect, discuss that, and decide what to do. So the trade-offs could be durability versus latency. As I mentioned in the market data, we don't care about the data that it's too old. But we are caring to processing that data as fast as possible. In the scalability, probably we care about scalability versus simplicity. So the Aaron is most simple than Kafka. Okay, ecosystem. Probably the best ecosystem that I ever see in my life is Kafka. So there is many things that you can just get, use. Amazing. Operational overhead. Probably all of you know that the Zookeeper is deprecated, but still used in most of the production environments. So there is some kind of overhead for most of the ops guys. Turning, you need to configure it to work correctly. For example, there is an amazing article that describes how to change your disk in order to be fast enough. So you can try to change the disk system to go better performance. NUTS, simple setup. Jetstream, add some complexity, but not so much as Kafka. Okay, not sure what to do. Now we are come to the most important things, decision framework. Try to put ourselves in the place when we can decide which technologies to use. Okay, need high throughput and durability, Kafka, data pipelines. Need ultra low latency, less than 1 millisecond, Aaron, trading, chronicle queue. Don't go with Kafka if you need low latency. You can achieve with low latency with Kafka, but there is a price. The price is the money that you need to pay to your cloud providers. Okay, need lightweight PubSub microservices. NUTS, do it. Need trading queue. Traditional queue, not trading queue, sorry. RabbitMQ, amazing. Need in-memory streaming, Redis. Other things. When you decide which technologies to use, first and the most important thing to discuss with your team members, do you have experience with that particular technologies? So there is no way how you can just go there and say, okay, from this day, we are going to change our language from Java to Kotlin. That's not gonna work. Please don't do that. So there is no way how you can just go to some meetings and say, okay, let's remove Kafka. You need to think about your expertise in your teams before we move to that. Think about your infrastructure. So the problem why I'm showing everything now in my local machine, because I did not manage to start the Aaron in my Kubernetes cluster, unfortunately. So we need to think the infrastructure. The budget. Kafka, too expensive. NUTS Aaron, probably not so much. Prototyping. Always do benchmarking. Don't take the things that I'm presenting here as just a tool. just try it, run it into your work machine, go to my GitHub page, check out the project, do it benchmark by yourself, and see if it's good enough or not. So basically, that's it. Thank you, guys.
No matter how hard I try, you keep pushing me aside and I can't break through. There's no talking to you. It's so sad that you're leaving. It takes time to believe it. But after all is said and done, you're gonna be the lonely one. What am I supposed to do? Sit around and wait for you? Well, I can't do that. There's no turning back. I need time to move on. I need love to feel strong. 'Cause I've had time to think it through. And maybe I'm too good for you. Do you believe in life after love? I can feel something inside me say I really don't think you're strong enough, no. Do you believe in life after love? I can feel something inside me say I really don't think you're strong enough. Fish swam out at the ocean and grew legs and they started walking. And the apes climbed down from the trees and grew tall and they started talking. And the stars fell out at the sky and the tears rolled into the ocean. And now I'm looking for a reason why you even set my world into motion. 'Cause if you're not really here, then I don't wanna be either. I wanna be next to you. Black and gold, black and gold, black and gold. Black and gold. Black and black and gold. I look up and see the night sky and see 1,000 eyes staring by. All around these golden beacons, I see nothing but black. I feel a weight of something beyond them. I don't see what I can feel. Vision is my only validation, then most of my life isn't real. 'Cause if you're not really here, then I don't wanna be either. I wanna be next to you. Black and gold, black and gold, black and gold. Black and gold. Black and gold. Black and gold.
My baby, my Valentine. Girl, you don't make him out to play the right. If you leave me, I go die. I swear. You are like the oxygen I need to survive. I'll be honest. Loving day, you're turning me. I'm so obsessed. I want you to know. Right there, fucking me, see you. Open up, make I see you. Give my love 1, 2, 3. We for made that Batman sing. Oh. For your head, don't call it one that don't care what they said. Cause your mother, now you the girl we carry to my head. Every night, now you I want to carry to my bed. Oh, no, no, tell me no, no, no. You can be my partner, never ride you solo, low. I can know I'm broken, no, to party, go. I'm feeling what you're doing, oh, baby, carry go, carry go. I'll be honest, loving, babe, you're turning me. I'm so obsessed. I want you to know, right there, fucking me, see you, but now make I see you, my love, 1, 2, 3. We for made that Batman sing, oh. We for made that Batman sing, oh. We for made that Batman sing, oh.
And she'll always get the best of me. The worst is yet to come, but at least we'll both be beautiful and stay forever young. This I know, yeah, this I know. She told me don't worry about it. She told me don't worry no more. We both know we can't go without it. She told me you'll never be alone. I can feel my face when I'm with you. I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it. Oh, and I know she'll be the death of me. At least we'll both be numb. And she'll always get the best of me. The worst is yet to come. All the misery was necessary when we're deep in love. Yes, I know, yeah, and I know. She told me don't worry about it. She told me don't worry no more. We both know we can't go without it. She told me you'll never be in love. I can feel my face when I'm with you. But I love it, but I love it. Oh, I can feel my face when I'm with you. I can feel my face, but I love it, but I love it, but I love it. Oh, I can feel my face when I'm with you. But I love it, but I love it, but I love it, but I love it. I can feel
spread love, 'cause I know, yeah, and I know.
You are a child, crawling on your knees, distorted, making mama so proud, but your voice is too loud. We like to watch you laughing. You pick the insects off less. No time to think of consequences. Control yourself. Take only what you need from it. A family of trees wanted to be haunted. Control yourself. Take only what you need from it. A family of trees wanting to be haunted. The water is warm, but it's sending me shivers. A baby is born, crying out for attention. The memories fade, like looking through a fog mirror. Decision to decisions on the man and not about where I fell. It's one hurt like it's night. Control yourself, take only what you need from it.
Hey,
A family of trees.
okay, still music. Okay, now, this is the final activity of this conference, except our most awesome and useless closing conference. We do slides for it now. Yes, these are the most unprepared slides you will ever see. And this is lovely that this activity now will be completely without slides. There was only one slide. We are doing this experiment for the second time. We once had a panel. It was pretty nice, I guess. And we decided to close this conference with, of course, talking about AI. What else can it be? Not Java at all. It's a Java conference, but of course, it's AI. So it's going to be 15 minutes as well. Then we're going to do the closing. We're going to prepare the slides, maybe. So as far as I know, there will be a moderator, Ken Fogel. It's a great honor for us to have him as a moderator. And there will be a microphone in the audience. The biggest guy, volunteer of the conference will be with it. So I guess Ken and other people will moderate. And if you want to ask a question, if you're brave enough, the guy will be there. Okay, warm welcome, this wonderful panel. Thank you.
So, thank you all for coming. We were talking out in the hall and we figured there'd only be 5 of you left as everybody went home. So we're really excited to see you. We feel bad for the people at the far end. We're really a lot taller than you see us, so you could come towards the center. The name of this session is called The Future of Java in the AI World. So you're looking at the only slide. There's no live coding. This is about what we up here see AI as affecting our role as Java developers. Are we still going to have a role? What is going to be the future? We're at the very beginning of this, right? We've seen what AI can do in entertainment, in other areas, social media, kind of scary. But what is it going to mean to us? So let me just quickly introduce everyone here. And some of these people I just met today. So there's Milan. There's Jonathan. There's Pasha.
Hey, everyone.
I've got the names wrong. And Raphael at the end. There we go. Actually, some of these people I've known from other conferences and so on. So I will begin by just saying a few things and let the real experts talk. You know, we think about AI is going to take our jobs. And I have to tell you that my feeling is it's not going to take our jobs, it's going to change our jobs. That we are going to end up working alongside AI as opposed to being replaced by it. So think about that. And can we start with Milan, who gave a great presentation earlier on actually coding to AI?
All right, thanks. I don't know, to be honest, that's the common belief, I believe, at this point, that and if you are a software developer, that's what you want to believe, right? I mean, anyone tells you something's going to take your job, you know, what do you want to say? Like, yeah, of course. Like, no, you want to believe that it's going to change your job. Honestly, I have no idea, because I've been in software development industry for close to 30 years, or maybe even more than 30 years now. I've never seen things changing that fast, like in the last 2 years, right? So I would be very careful stating things there. Like, we literally live in a world where, like, a year ago, you would bet that AI cannot do something, and it can do it today, right? So anything we bet today that AI cannot do in 1, 2, 3, 5 years, I think it's irresponsible. But so yeah, that's the long answer to that could be like shortened to, I wouldn't be surprised. I hope Ken's right. I hope this is gonna just change how we work. But if it turns out it actually takes our jobs, it wouldn't be much of a surprise to me.
Jonathan.
Who has attended my talk? Shout, because I think we are very sleepy now. Who has come to my talk? What? Who? Okay. Anybody can repeat my sentence? The one thing that I've said during my presentation is the one thing that you should keep in your mind. What else? Time, not confidence. So I think my point is that AI is going to give us time, and it's going to change, as Milan said. It's going to change our role, but it's not going to replace us. So we are going to give more value to the chain. Also, it's a trend. Anybody remembers the blockchain trend years ago? Exactly. So I've worked in this for more than 30 years now, and I've seen trends coming, going, and more or less everything remains the same. Things are changing, and I think AI is changing, but it's part of us to make the change something valuable and not just simply a trend that we are just using what AI is vomiting and putting in our products.
I am also quite calm about our future with AI. I don't think AI will go anywhere. The other thing, yeah, blockchain, it went away. I didn't hear about it for a long time already. Yeah, some people work at crypto startups or sort of things like that. It won't happen to AI. But I'm very calm for you and frankly for myself, because AI inevitably is somewhere in the middle, because it learns the best things and learns from the worst things, and it can't distinguish them, and there is no way for it to distinguish it, because it's not like, I don't know, it's not sonar to understand what's a good code and what's a bad code, and it doesn't it doesn't have sonar built in. It's also not Java, which can understand that we can compile this code and we can't compile this code. It is average. And you all here are probably above average, otherwise why would you care to come here, right? As well as me, as well as myself. I think I'm I'm above average, and it makes me better than AI today and probably tomorrow too. And then we'll see. But I wouldn't recommend my children to go and work in IT.
Well, it was mentioned that things never changed so fast as they do now. But I very well remember when I was much younger than I am now, I made my first money as a web designer. And that was in the times when you would write HTML by hand. And that was common, and that was the only way to design a web page. And then Macromedia released Dreamweaver. And everybody said, whoa, now web design and building web pages manually will not be a thing anymore. People will buy Dreamweaver, they will draw up their layout and put in the content and upload that. And obviously that has transformed how web design looks. But as you all know, web design is still pretty much alive and a profession today, despite that web design is a much more complex topic today than it used to be. And I think that is in a way a hint on how our profession will be transformed, because AI is around already. It's been around for 2-3 years. We're all still here. We're still able to afford a conference ticket to come here. And like as it was said, I don't think anybody understands or knows how our job will look like in 10 years. But even without AI, it would have changed drastically. And I think anybody who's working in any job has to expect changes. If you're a shoemaker, you have to expect changes in industrialization. There's still shoemakers. Their job just has changed drastically. So yeah, we'll have to see, I guess, and be around for that. And we can just discuss how we think it's going to be like, but we'll probably be wrong. So if this is watched, then it's going to be the IBM analogies where we're probably off by quite a lot. Yeah.
Cool.
Thank you.
It's fun to listen to all these youngsters up here who talk about they started 30 years ago and I started 41 years ago. So the question now is, you know, we have this thing called AI. We have people who have companies, businesses are going, so do I spend a lot of money and get a subscription to an AI and let go of my programmers? Or do I add to my programmers an AI? Thoughts on that? We'll start at the end.
Well, I think people already do that, have the tools ready, and that's still cheap enough, and it's still like the startup phase of a technology where things are heavily subsidized and very cheap. I think at some point the prices for these products will increase by a lot, which will then really show how valuable they are, because they are resource intense. However, like I'm a consultant, I'm doing like technology on the side, it's open source, but my main job is actually like anybody's job, sitting in meetings and extracting the actual requirement from customers. That part, which is the main part of my job, I don't see how it will change. I do, however, see that at some point I will use AI more to maybe sketch out something, create prototypes, maybe accelerate that, because I might be able to sit in a meeting and show how a feature might work and then fine-tune it. I think the job will at some point go further towards quality assurance. That's also what makes me optimistic about Java. Java is made to read, not to write it fast, which will help me to actually assure the quality of a program. I see my wife, she's an electrical engineer. They do a lot in Python. They use AI a lot, and that has transformed the full approach to it, because my wife cannot really program Python, but she generates it, and then she can adjust it, so it lowers the entry barrier. But I don't really see that to be the case for Java, which is mostly used for enterprise apps. So my best guess is at some point that it will be used for prototyping. Then there will be a quality assurance phase where you will rewrite a lot of the AI-generated code to make it more canonical. And then we'll see if AI catches up to be even further valuable at some point.
It is a very nice bridge to from what I said and to what I'm going to say. As I said, I'm not going to recommend my children to go in at least programming, because I think it should be a hell of a ride to be a junior developer when there is JetBrains Juni, Windsurf, Cursor, and other Augment and other tools. I tried some of them. They work very close to how junior engineers work. They do understand basic requirements. One day, they probably will understand complex requirements, and you won't need to sit in meetings because they will be able to understand and transform them into a code. We don't know. But for junior developers, it's really hard. If I'm a business and I'm going to think about hiring a junior developer, why would I do it when I can just pay for junior subscription, which is what, 200 euros a year? It will be 2,000 euros a year. It's still significantly cheaper than junior developer, and this is the part I'm afraid of, and this is the part of an answer. Will we hire people? But eventually, I had a very interesting chat with Simon Martinelli about it. When junior generates a code for me, it is deeply imperfect. It needs a lot of refactoring. It needs a lot of performance optimization. It needs to be fixed. It asks to be fixed. And Juni can't do it because it doesn't know how, because, again, it's average, and I'm above average. So we will always need these people above average level, and I think that at some point we'll tell, okay, we are actually ready to invest some time and money into teaching people to be at least middle or better senior developers for them to be able to fix errors of AI. But probably we won't need so many developers anymore because developers will be drastically more effective and efficient.
Well, I think with companies, it's hard to know because what we think it's the good way of doing things, it's not most of the times what companies are doing. Sometimes they are more focused on short-term decisions, right? So we all remember all those companies that were outsourcing projects to other countries just because it was cheaper, but then they needed to hire a lot of consultancies to fix a lot of issues, a lot of requirements implemented the wrong way. Nowadays, I assume that there are consultancies being hired to fix what Copilot has generated, just because they simply submit those changes. So it's interesting how the same system is going to feed itself. So for one point, we are going to need less developers, but for the other point, we are going to need more experienced developers. What I see the problem here is, in order to be an experienced developer, you need to experience, you need to fail, you need to fix, you need to understand, you need to use your brain. But the problem is, if the young developers are starting using too much AI without following this process of failing, understanding, fighting with documentation, going to the GitHub repository in order to understand a library, playing in their laptop, they just simply ask Copilot, write this. Are we going to have senior developers in 5 years?
It will be us. It will be more expensive.
Well, I pretend to retire someday, so...
I do not.
Okay. So I assume that this is going to affect. So we need to think about, in our companies, how are we implementing AI? Because it's not only the short term who is being impacted, not only the result, but also the medium term that is going to be impacted by the usage that we do now.
I'll try to be a little controversial. So I assume you all write tests to your code, right?
Sure.
Okay, so what happens when you run a test and it's green or it's red? Right, you need to fix the test or you need to fix the code. It's green, you move on. It's deterministic, right? Let's expand that to code coverage. You do code coverage in your project?
No.
What is a good percentage of code coverage?
I don't know.
Is it 75, 83, 99? So that now is the situation we are in. We think of code by developers as something deterministic, good code, bad code, whatever. And code generated by AI is non-deterministic. It is in some percentage good. So I think logically what's going to happen is in all those use cases where we can say something, the equivalent of 75% is good enough, those will be the use cases where AI will heavily grow. In the cases where you actually need 100%, that would be next to impossible to have unsupervised AI deliver the solution. Now, how long is it going to take that? For it to happen, for companies to realize it, for the hype of I'm gonna fire all my software engineers because they cost me so much money and get AI to do it, 10 times faster. I have no idea. We certainly will see that. We're actually seeing it now. There are companies doing this. There are companies going back, by the way, who did fire software engineers and now rehiring them back. So yeah, there's going to be a wave because businesses are businesses. They are driven by two things, like profit and cost optimizations, right? They will try. Most of them will fail. Some of them will succeed. Some of them will follow those who appear to be successful. So I wouldn't predict like what's going to happen, how long it's going to last. But I think ultimately it's going to balance it out somewhere where we, in a situations of software development where we can afford that non-deterministic approach, AI will play much bigger role, and in cases where you need to be precise, there will be more developer focus. If I have to guess, that would be my guess.
Cool. In preparing for this, I did some reading about how we're going to interact with AI, beyond just having it write the code for us. And I came across this interesting dichotomy. Do we write code to the API of a AI system, or do we talk to it via microservices? The idea that AI will become a subscription service, and that we'll continue to write code, and most of the code we'll write will be to make a request from whatever subscription our company is paying for. What do you think about that?
So if you ever worked with a Silicon Valley company and see the way they can acquire money, if you don't go for a subscription service, you will get so little money compared to the companies who will work for subscription service that these subscription service-based companies will certainly outrun you. So I'm 100% certain that subscription services in AI are going to be the standard at some point, because this is how you can extract the most money out of people. And to some degree also, that's a risk to some degree. If you outsource your developer confidence to a specific vendor, possibly in America, then you will create big dependencies to that. So I'm also curious to see how this will develop and how legislation around this will form. And also how copyrights of this generated code are going to be assured. But yeah, that's where I think we're going to go.
Yeah.
I have experimented with JetBrains Juni quite a bit. I was an early adopter, and I spent countless machine hours generating code with JetBrains Juni. Then when they published it, when they made an announcement that it's generally available, they gave to me as JetBrains alumni a pro license for JetBrains Juni, which I burned in one day. All the tokens I had, I burned in one day, and the way is to actually buy JetBrains Juni Ultimate, not JetBrains Juni Pro, which is even more expensive. So it is already not use AI. I do not see a future of the world without AI, actually. I think that all these banks and insurance companies and all other heavily regulated establishments they will host their own AIs, like Qwen, like DeepSeek, whatever. They will have the hosted version, probably fine-tuned on their own code bases to generate.
Just one thing. I've been thinking about this for a long time, and if you know the famous saying, if you have an infinite number of monkeys typing on an infinite number of typewriters, randomly pressing keystrokes, eventually all the great works of literature will be created, right? So I think
I have some good news. A mathematician has done the math and proved that's not going to happen.
Yeah, I mean, but
I have some good news. A mathematician has done the math and proved that's not going to happen.
Yeah, I mean, but you know what it implies. Like, I think we are in kind of this situation with AI, because let's say our worst nightmare comes true, and AI writes all the code and whatnot. How many times it would have to write the same code? Like, why it would be like? Think about it for a second. It generates an app that does something, right? Why would you need 10,000 or 100,000 developers all over the world to run that very same reasoning on top of the very same model to generate the very same thing, right? It's going to be just, to me, with time, it's going to be just a matter of time before we get so big pre-generated code blocks that we would in some form or shape reuse. Like, think about it. We had this conversation minutes ago. Raise your hand if in the last project that you used, in the, say, last 3 months, you used a code that sorted something, an array, a list, whatever, some sort of data, and you had to sort it out, say, alphabetically. Like, I'm pretty sure most of you, right? How many of you wrote a sorting algorithm in their life? Yeah, at the university, I guess, right? I mean, you don't think about it. You just use the language capability or a library or something. This is how we create code. I think that's literally what's going to happen with AI. We will have, at some point, something that we today called APIs or libraries or whatever, that will have most of the problems solved already. And we'll be just using those. Now, how is that going to be provided to us, whether that's going to be through an API and we're going to pay someone money for it? Most likely. I mean, companies have learned their lessons. They know that that's the most sustainable business model, to ask you to, or rather your employer, to pay a subscription fee. So I wouldn't be surprised if that is the model, but hey, who knows?
Well, I would say that usually there is a new technology. At that moment, everyone thinks that with that technology, all the humanity problems can be solved with that specific technology. So now we are using, I don't know, GPT-4, we are using OpenAI to create a loop, to iterate a stream, to create a method that connects to Postgres. Are we sure we need GPT-4 to do that? So in Hugging Face, there are more than 1 million models that we can run locally. I don't mean every developer needs to run a model locally, but for most of the use cases, that it is AI tab-assisted autocompletion mode, that it's not using chat, but autocompletion. I would say Qwen 2.5 probably is enough. So going back to the subscriptions, I think that a lot of people follow the biggest duck without asking. But eventually, people will start thinking, is this what I need? Do I need this power for the use cases that I'm doing? So it should be that we make a rational decision about AI and not follow trends, just evaluate what exactly we need and then use the tool and the model that we really need. So I assume that eventually companies will do that, and not everyone will follow subscriptions. They will follow on-premise installations or any other kind of installations, but not based on subscriptions to the big models. That's what I think.
Just one sentence. That's what, by the way, many years ago, system administrators used to say about server rooms.
Yeah. Pasha.
I disagree with the idea that we shouldn't follow trends. Recently, I made a small question in my quiz in my Twitter. I asked people, should we hire developers who are not using and not willing to use AI? And the consensus was that we shouldn't. People should be willing to use AI. When you use IntelliJ IDEA, you already use AI. Always, even if you don't have any AI assistant or something like that, there is a built-in model called Melum for full-line completion, and it is powerful enough, but it's not powerful enough for future. I'm guessing a lot of people will and should generate boilerplate code with AIs. AI should become better, for sure. In the presentation of Jonathan of AI in the code quality in AI era, there is a very interesting example of how the code generated by some model, Copilot, is not too good. It could be better. I think we could make, and we will make them better. JetBrains will make it better because they know a lot about quality of the code. They know how to do it better. But still, the majority will be subscription. The majority of things will be a subscription. And IDEA itself is a subscription with all the models included, and it has a separate subscription for Junior. Thank you.
I'm going to ask the panel one more question, and then we're going to open it up to the floor, if anybody would like to ask something. Let's consider a doomsday scenario. And the doomsday scenario is the job of Java developer, C# developer is over. It's gone. What is it replaced by? QA. That the next big career is validating the stuff that comes out of the AI. And even that, I wonder, well, they'll build another AI to do that. I was a big fan of the TV series Star Trek. The Next Generation, Captain Picard. And I was always fascinated, there were no computer programmers on the spaceship. Instead, the engineer would go into his office and he'd muse. If we increase the warp core by 5%, and then you'd hear somebody say, working, program complete. And then he'd rush to the captain and said, I did it. No, he didn't. Yeah, I did it. But so going back, is there a scenario where we're all going to be out of a job in the next, say, 20 years?
I honestly think that it's not a doomsday scenario. I think that doomsday scenario is when there is no QA, there are no developers, there are only users. And maybe, I don't know, CEOs of startups. Yeah. CEO tells AI what to do, and then users test it. Yeah. And it actually works. This is a doomsday scenario for us. Being a QA is actually a good job. They did it for a couple of years, would do it again.
So, I like your doomsday idea, but I think we need to kind of conclude based on what we've seen in the past. Like what you do, and I don't mean now Java developers or developers per se, like the whole world. When you have an impossible quality standards to meet, how do things end usually? By lowering the standards. So I think the doomsday for me is that's exactly that we as a society at some point will decide that for those group of people, organization, whatever, to be financially successful, we don't have to have such high quality standards or whatever. We can lower it down so the AI can meet them, right? And we're just gonna assume that whatever that thing generates, because obviously AI is gonna get better and better. Like there's no question about it. They will train it, even though now the most recent conversation I heard around OpenAI is that they are running out of data on which they train models, because now you're talking billions and billions of parameters. But they overcome. Now there is another idea about synthetic data generation. I'm not sure what exactly the term is, but basically what they try to do is synthetically generate data on which the AI can be trained. Now, take a second to think about that. Now, you training, like first you use the AI to come up with something, and then you use that something to train another AI. Like, I don't know. I mean, my point is, the doomsday for me is basically when we decide that this is just fine, right? We don't need the high standards that we hold people to. We can just hold it, you know, to the good enough that our technology can do, right? So to me, that's going to be the doomsday.
So I have two childhood friends, where one is a radiologist and where one is a translator. And both of these jobs have already been affected by AI to a way larger degree. And yet both of these people are rather happy with the transformation of their jobs. Because in translation, which large language models really are good at, the job has gone from you'll get a book, an entire book, and you will translate the same sentences that you translated many, many times, again and again, and you have like a memory, a muscle that will kick in, and you will do a lot of the job without really using your brain. The job now is more that you have a pre-translation and then you refine it, which is the preferred way, and that's what we talked about before, that this might happen to programming as well, might be the thing. Right? The same goes with radiology. If you ever had to take an MRI, then you will likely have to wait 2 or 3 weeks for the result today. And that might change drastically, because radiologists have long waiting queues and have to prioritize. By having a pre-evaluation, they can already take out the things that get warnings, right? Give you a diagnosis earlier and have help and get more work done. So also in IT, the state of today is that a lot of companies and governments did not digitalize services they want to digitalize. They have to prioritize. And then once they prioritize, they choose these 2 or 3 things, spend $1 billion on doing this one thing. And with AI, maybe the future project will be that instead of hiring 300 developer consultants, they might just hire 20 and then use AI to do a lot of the boilerplate. And this enables a lot of network effects where you can talk about things more easily. So I'm just positive about these doomsday scenarios. I think this is where we want to go, because I've been in charge of large teams with 100 developers, and it's hard. It's absolutely hard. You only do damage control all the way, and people like to laugh in IT about these big failing projects. But you don't have a chance. It's not doable because it's too many people. So I think if we get to resolve these projects, there will be more projects instead than fewer people working in IT. And these projects will be more successful.
Are you really ready to trust AI interpretation of your MRI?
Sorry, AI of, no, but that's the thing. It's just a pre-selection, because otherwise you will do at random, right? And the AI will do, on average, a much better job than the random selection. Often it's like you did the MRI today, and nobody even looks at your picture, right? But now the AI makes a quick scan and sees this is 95% cancer cells. And then, of course, the radiologist will look at it immediately and maybe give you 2 weeks of heads up. Or the radiologist will say, like, nah, this is an error, right?
What if the opposite happens? AI says that everything is fine, and you actually have cancer cells.
Yeah, but that's the utilitarianism in it, right? Of course, that might happen. The AI might say nothing to worry about, but if the AI said that, then you will still have to wait 2 or 3 weeks. And if no AI is used, you will still have to wait 2 weeks. And more people live thanks to AI than people die. And it's, of course, not always right. Some people might be wrongly classified, and that's horrible, and you can make discussions if AI is actually good, but the great picture is that it's an improvement.
It's interesting. It makes me think that we're all going to need AI insurance. Jonathan?
Well, I think the doomsday is going to be fixed or managed by a lot of lawyers, I think. The problem in the end comes to legal responsibilities. So, as I said in my presentation, when you do git blame, you don't see Copilot there. You see your name. So, yes, AI can generate a lot of code, but we need someone with experience that it is rejecting or approving, and in fact, assuming the responsibility for that. For the same case that Rafael mentioned about cancer diagnosis and so on, that's a tool. Perfect. It's great as a tool, but we need a doctor there to certify things. Recently, I heard about some issues with truck drivers following Google Maps directions and ending up in streets that the truck was stuck, just because they were following blindly, because that became a commodity. That's, for me, the doomsday is when something becomes a commodity. I always use this analogy. When I started using Google Maps, it was a 2-step task. So I asked to go one destination, so I checked the route. So sometimes I said, come on, there's a better way, because I know some shortcuts. Come on, I'm local, so I know. Now, I just tell my car, home. And it's an interesting experience. Usually it's like, why? I mean, this is nonsense. Well, sometimes it's also the other way around, because the other day I did that and I said, come on, I'm local, there's a better way. But it's a street closed. So Google knew, but I didn't know. So sometimes it's that way. But we are losing our ability because we are making these things a commodity. So when we make AI a commodity, and maybe we lower down the expectations of the quality just because it's easier and cheaper, that's the doomsday. Let's expect, well, I'm talking because I'm here, let's expect that Europe regulates that with certifications and organizations regulating the use of AI and the validation for biases and the validation of results, and that companies are responsible for what they deliver. That's how I see it.
I remember times when people said that you should be able to write valid, correct Java code in Notepad. You shouldn't be dependent on idea. This world doesn't exist anymore. I love when something becomes a commodity.
Great. So we have Mr. Mike. Do any of you have any comments or questions? There we go. Let's start here.
Hello, I'm Troyan Momkov. In 5 years, the prediction is that we'll have artificial general intelligence, AGI. And I want to challenge you to think the following scenario. Imagine this AGI will obey the first law of Isaac Asimov, that the robots or the AGI cannot hurt people. So imagine this AGI can do something good for us. For example, they can improve our lives without we knowing it is doing it. For example, it can go in GitHub and improve a library, commit and so on, make new versions of libraries. it can understand that we need a new software product and design and develop this product without we knowing that. And this is in our domain, but it can also do that with the cars, with the food, with the medicines, everything. And yeah, I just want...
What's the question, though?
The question is, how do you see the world in this, in 5, 10 years, let's say, if we have this context? Thank you.
Go ahead.
I think that the first thing AGI will try to do, if it obeys the first law of Asimov, it will try to create communism, because it's objectively an amazing system as soon as you can build it, because anyone can do whatever they want. For example, I love programming, so I can do programming. My son likes to draw, he can draw, and of course, it will be deeply imperfect, and this communism will fail, and it will be anarchy and capitalism and so on, and AI won't save us. Sorry.
I think when we have general intelligence, that's the least change we will observe is how we program. I think then the world will change to a degree that we cannot comprehend. Then that said, it's like, I think the same predictions about this that are made today are the same predictions like about self-driving cars that are just around the corner. I think this is nothing I expect to see in my lifetime still, until I maybe see it.
I agree with that. And one thing to consider is, because I really love people talking about Gen AI, and even superhuman, whatever. Like, if we have that, that essentially means we have a species that's equal to us. And that species, well, I mean, let's talk about, like, not super, but like general. So if we have a species, a different species that's equal to us, they will demand rights like we do, right? So I think we will be in a situation none of us is able to imagine at this point. So with all the excitement about, like, whatever Sam Altman said, I think, like, with 2 years, 3 years, 5 years, whatever years, like, with all the excitement about that, like, think about that, because that's literally the same scenario as alien species landed now on Earth. And I think a lot of people imagine this not ending well.
It's funny to hear the word general intelligence. I'm concerned as a species, we don't have it yet either. So, you know, waiting for an AI to have it, how are we going to recognize? Anyways, is there any other questions?
I wanted to mention
that.
Oh,
please, sorry.
In these days, what we need is philosophy. If you use philosophy, you will answer to that question very easily. It's impossible to follow those rules. Everything in life is subjective. So that's impossible that situation becomes a reality, ever. With philosophy, you can deny everything of that. It's impossible.
Will harm people,
actually. No harming anyone, it's impossible. So again, this AGI making things, and always remember, AI is based on past data, on past experiences. So, well, but we have a damage in our brain, that it is creativity, that it is being full, and that's why we've reached this point at time. Yeah, that's what I think.
Sadly, we only have enough time for one more comment and question.
Thank you. Hi guys, Ivo. I'm a speaker actually. I couldn't attend everybody's lectures, but those who attended were great. Thank you for answering. I've been using AI tools for different reasons, like for front-end generation, for back-end generation. I've used Cursor, Copilot, June recently. And what I've noticed with SaaS in general is that basically you pay for something that's not really available always, or sometimes it's slow, sometimes you wait. What I find out, because I'm an engineer, for context, I'm an engineer for 15 years, I know architecture, I've done front-end, back-end, some data engineering stuff. Their initial prompts are pretty bad. So like you get big files, you get no separation of concerns, you know, like all those problems. You can kind of try and prompt it. It kind of tries to escape from it, right? But what I've noticed is like the bill stacks up to like 100, 200, 300 euros per month, let's say. And that's because usually models can be like smaller models and distilled, right? You know, like you have models that are agents for specific reasons. They're smaller and they can be used. So I've been thinking of like buying project digits, like it's the new NVIDIA thing. And I've been thinking maybe in the future we can have really small distilled, pretty going deep models. And we as engineers can use it for different purposes, like for an image, for front end, for back end, for Java, for whatever. Do you think it's a good idea to have like a local one and not be dependent on big tech? Because I've seen this with XGS, like they were like licenses for 200 euros. You write code and in 3 years they say, yeah, 2,000 euros. And then you're dependent on them. Thank you.
So you've all got 30 seconds to wrap this up.
I will answer with one sentence. Like I remember someone asked me that something similar to that like about a year ago, and I said that what I envision is that small language models, small models in general, will in the future be embedded in some way in programming languages or runtime environments or whatever the infrastructure is for that particular thing. So I think that's literally what's going to happen. We'll have more of those small models who solve particular problems. They will be shipped with the runtimes, with the languages, with whatever the infrastructure is at the time. And that doesn't mean the large language models will go away, but...
Yeah, I think I agree with him. And also Pasha mentioned that. So Juni comes with a small language model already. So we are already using those small language models. So I assume that in the future, yes, it will be more a chain of small language models for a specific parts, and maybe an LLM for the conversational thingy. But that's how I see it.
I have nothing to add. Okay, just if you remember when cloud services came along, how prices increased since the first days, we'll see the same with language models, because you can already see in the stock prices of big tech companies that AI data centers became so expensive that it impacts them negatively. So there's already now a big pressure to increase price, and I think we'll easily see a 10 times. So, and that has to be kept in mind if you consider the usefulness of AI in development and in general in the future.
So, thank you all. I hope we haven't depressed you too much, or maybe we've excited you. AI is here. We can't ignore it. We're going to have to live with it. So thank you all for coming, and if you want to talk to any of us, come up here after we shut down.
Yes, huge applause, Mr. Ken Fogel, for the moderation. It's pretty awesome. Thank you so much. Let's thank everybody. Milan, thank Milan.
Thank you, everyone.
Yes, thank Jonathan.
Thank you. Muchas gracias.
Yay. Thank you, Pasha. Applause.
Thank you. Thank you. See you around.
Yes, and thank you, Raphael.
Thanks, and thanks to the organizers.
Thank you. So did you, once again, did you like the format? You like the format? Awesome. By the way, thank you, Sasha, for helping with the microphone. Thank you. So next time we're going to make it again. Please stay for the closing. We have prepared
we are closing pretty quickly, and then we go and drink beer.
Yes, we prepared the most useless slides you'll ever see. Yes, stay just for a second. Some music, please.
Please don't make any sudden moves. You don't know the harm or the abuse. We don't deal with outsiders very well. They say newcomers have a certain smell. You have trust issues, not to mention. They say that they can smell your intention. You'll never know the freak show sitting next to you. You will have some weird people sitting next to you. You will think that I get here sitting next to you. But after all I said, please don't forget. All my friends are heathens, take it slow.
Wait for them to ask you, you know. Please don't make any sudden moves. You don't know the heart or the abuse.
Turn the mic on, yes.
So jPrime 2025 is almost over.
Yep.
And we from the gang of 6.
Now gang of 4.
Or not really.
Yeah, the Plovdiv guys
Yeah.
went to Plovdiv, sorry.
Would like to thank you very much for being with us, for coming to the event, for staying till the end. And we hope that you will join the beer and networking afterwards. So
The
yeah,
weather is so good.
It's our what was retrospective. Now.
Yeah, the most useless retrospective, as always.
Next slide. Next, please, and it's you.
Научих се да карам, каква беше думата за това подвижното нещо, да те вдига на 8 метра? Друга е думата. Моля? Вишка, и един от господата там отзад ми го даде и каза, ти нали знаеш как се кара, и си тръгна. И като се хванеш горе за релста, тя също се люлее. И спадаш в ужас. Един слайд за...
Thank you for being here with us.
Thank you. It's you who made it. Thank you.
Yeah. You're the one who are making this event like this.
Yeah, there was a LinkedIn post yesterday by one of our sponsors who was saying that next year we need to hire a stadium. And another one of our speakers said, yeah, the stadium of Ivan Ivanov's favorite team, I won't say which it is, should be ready. But you know which stadium is going to be ready and who is the next champion.
This stadium in the park, we're waiting for this stadium in the park. You know what is the stadium?
Yeah, but thank you very much. Thank you.
So, by the way, we did our homework. So we have received a lot of complaints about the workshops. They were usually back there. And it was so funny to see how many people are trying to put chairs in front of that door and see from the left corner, from the right side, upstairs, what slide this speaker shows. So that's why this year we spent a whole bunch of money to hire a really good facility down there in the incubator. And as far as I see, we have a huge presence there. And as far as I see, people did you like this location? Who was there? Was it good? Yes, say yes. So that means that the money we throw to this location are working good. So I think that the workshops have a new life, I would say. We will do better workshops in this better location. Thank you.
Yeah, I would like huge thank you to the sponsors. Without them, this jPrime edition will not be possible. They are very important for us, and we are very grateful for their support.
Thank you. Thank you. Sponsors, thank you. Won't be possible without you, really.
И вече приемем пари за следващата година, нали? Да е ясно.
Yes.
So our biggest concern when we do the preparation the day before the event is with the water, because we have to distribute 4,000 water bottles to our storage rooms. But this year we had this motocar, not sure the English word, that brought it down, and then from the truck, and then next slide. We used this thing that got the pallet, and we brought it to. So this year was perfect with our work, and we were finished much before most of our volunteers, male volunteers, arrived, and they said, when do we carry stuff?
It is AI powered.
It
Yes?
is Ian, it's Ivan, but anyway.
It's natural intellect powered. Кажи нещо.
Това е твоята снимка, говори си.
Wi-Fi. So this is our Wi-Fi setup. It was set up by Misho.
Yep.
Кашонът е от подаръците, празен кашон си търсих и ми дадоха един.
As you see, even the Wi-Fi is community driven.
Yeah, that's the whole two Wi-Fi.
Homemade.
Homemade, home group.
5G. Perfect.
Do it by yourself.
Yes, do it yourself Wi-Fi. And here I would like to say about the speakers. So, dear speakers, who is in the room, please stand up. Please stand up. We thank you so much for making this conference so much awesome. Thank you for staying us. And as a community, big applause to the speakers. Yay! Thank you for coming. Your talks are great.
Thank you very much.
Thank you. Just to finish something. Okay. You can't imagine how much effort it was for me to organize all this stuff, because I'm one of the guys who actually pays the tickets, make connecting flights, make, talks to other conferences. Like, how are we going to share the speakers? Because speakers is a shareable resource. Yes, so speaker resource operations, I will call it this way. Yes, really, I'll be honest with you, because we have to shift the dates. We were in clash with some other conferences. And pulling the speakers out from one conference, so they speak in one conference, then they do overnight flights. You can easily recognize speakers by their beard. Yeah, those speakers don't, just speak. They fly to our locations. By the way, huge thanks to those speakers who made flights for other conferences just to be here with us. Once again, big applause. And screw these awkward conferences that changed their dates because it was so bad. And we have to do all these operations. But once again, thank you for being with us. You are so much great. Thank you.
And yeah, the biggest thank you. All the guys and girls with red t-shirt come to the stage.
All the volunteers, please come to the stage.
These are the people who do it really for free and with all their hearts.
More applause.
And big applause for their passion. Let's make a photo. Where is our photo?
Okay, where is the photographer? Here is the photographer.
And when brotherhood comes first, and that line will never be crossed. Established it on our own when the line had to be drawn, and that line is what we reach. So remember me when I'm gone.
Okay, thank you so much.
So there we go. Everything I went through, you were standing here by my side, and now you gon' be with me for the last time. It's been a long.
Yes, thank you so much.
Thank you very much.
Volunteers, keep on the stage if you like it, actually. Once again, those people work for free and for food.
And I like the connection between Mitya and Misho on this photo.
Yes, we like each other. Yes, thank for the dobrovolcite for feeding.
Okay, so we have dates for next year. jPrime 2026 will be in June this year, next year actually. And it's, yeah, you can read it, right? Especially the guest speakers. It's 3rd and 4th of June, so that we don't clash, hopefully, with anything. And that's the public official reason. The other reason is that me and Ducin have children who are abiturienti next year. So May will be very busy for us. So yeah, thank you everyone, and see you next year on the 3rd of June.
Thank you. Thank you. Goodbye.
And now, let's meet everyone outside and have some beer. Pizza is coming.
Pizza is coming, beer is coming.
25
Let's
minutes.
network.
20 minutes and yeah.
Thank you. Haydi çal.
You're trying to put me in a waste mood, Do you want cleaner than my gym shoes, Really born to just to hurt me, All red lamb just to tease me, None of these stories on a list, you, Made my whole year in a week, too, Main chick out of your league, too, Side chick out of your league, too, You're so empty, need a centerpiece. Ready, run to table, girl from Lebanese. Cut that ivory in the skinny pieces, then I'll sign it with my name, say you love me, baby. You talking money, need a hearing aid. You talking about me, I don't see the shade. Switch up my style, I take any lane. I switch up my cup, I kill any pain. And look what you've done. I'm in love with a star boy. And look what you've done. I'm in love with a star boy. Every time my boy try to test me, Every